Rasky from UC Davis was also very active in both India and California. Systematics and the management of nematodes in vineyards were his areas of expertise. He encouraged the formation of the Indian Society of Nematologists and the Indian Journal of Nematology. The Professor D.J. Rasky Academic Merit Award was created in honor of his. A number of students from India received PhDs at UC Davis, and several were visiting scholars and postdocs. John Chitamber and Umesh Kodira are currently with our California Department of Food and Agriculture. Here are some titles from a recent issue of the Indian Journal of Nematology that illustrate the breadth of work in eco-friendly nematode management taking place in India. The topics include essential oils, biocontrol agents, trichoderma, and medicinal plants. Eco-friendly management research in nematology includes a number of cultural, physical, and chemical management techniques. Today, I want to concentrate on a few new products that have recently become commercially available or are expected to be available soon. In the area of biopesticides, Ditera, which is a toxin produced in fermentation by the fungus Myrothecium verrucaria. A second product in this area is the fungus Bacillomyces that is being marketed under the names Melicon and BioAct. Plant extracts include one from the soapbark tree Quillia that has saponin as the active ingredient. Essential oils, which can either be a single oil, such as cinnamite, or a mixture of oils, such as Duogard and Cedros. Then there are self-defense inducers, such as Nematex and Tecaroot, that are designed to stimulate plants to defend themselves. Finally, in the past few years, we have seen the development of products such as Nimitz, Celebro, and Vellum 1 with new modes of action and that have a caution signal word on the label rather than the danger classification of the fumigants. A wide variety of fruit trees are grown in California in the Central Valley area. Yields are reduced through infestation with ring, lesion, root knot, and dagger nematodes. Since the loss of dibromochloropropane, or DBCP, in 1977, there has been an unfulfilled need for replacements that can be used after planting. To find out if two new products, Ditera and Quillia, could fulfill this need, we conducted a trial in a mature walnut orchard that had a mixture of paradox and own-rooted English walnut rootstocks. We used a randomized complete block design with an untreated check and one rate each of Ditera and Quillia. We were able to monitor trunk circumference, yield, and tree vigor and take soil samples for nematodes. Trees were treated in October and April each year for 4 years. In the upper left graph, if we look at the differences in trunk circumference from 2003 to 2006, we were able to show significant increases for both products on both rootstocks. So the products increased the size of the trees compared to the untreated. On the lower left graph, there are also significant increases in yield that are evident. The upper right illustrates a vigor rating the farm advisor developed once she could see what looked to be differences in tree vigor, using a scale from 1 to 5, with 5 being most vigorous. The bottom right graph illustrates that in several cases, treated trees were more vigorous than those that were not treated. What I will show next is data that I haven't presented previously because it goes against our normal way of thinking. The white bars are the untreated and the yellow are treated. The vertical axis is number of nematodes in a liter of soil. On the horizontal axis, working from left to right, are data for lesion and ring nematode taken twice a year during the trial, with the first date being the baseline data. What we see is that in spite of increasing tree size, yield, and vigor, nematode populations either did not decrease or in some cases actually increased significantly. This has actually become typical of what we are seeing with several of the newer products. Apparently, we are creating a healthier root system that is able to support larger populations of nematodes. Next, I'd like to talk about results from using essential oil products for managing lesion nematode on Easter lilies. This crop is only grown along the coast on the border between California and Oregon. It has historically required a pre-plant treatment. Bulbs harvested each sold to greenhouse operators for forcing to produce plants that flower at Easter. On the left, at the top, you see a field devastated by lesion nematode compared to a treated field on the right. At the bottom left, you can see the difference in bulbs harvested from a non-treated compared to a treated field. The growers operate their own research station managed by Lee Riddle, shown in the picture in the lower right. At this station, we conducted trials for nematode management each year for more than 20 years. Our research cycle for this crop is to plant trials with small bulblets in October each year. At Easter, we meet with the growers to discuss results and plan future trials. Each June, there's a field day to view the experimental plots, and we harvest our trials in September. This slide illustrates the components of the essential oil products that we used. We did 2 trials with similar results, but I will only present data from one of them. We used a randomized complete block design with 3 replicates of 75 bulblets each per treatment. We looked at 4 essential products as 1% dips to the bulblets prior to planting them in the field. We tested cinnamite, which was cinnamon oil alone, and 3 products, DuoGuard, EF300, and EF400 that were combinations of several oils. The grower standard treatment is a combination of the fumigants metam, sodium, and telone pre-plant, followed by thimet at planting. We also had treatments that tested the organophosphates, phosphthiazate, and mocap as potential replacements for thimet. The essential oil products were tested either alone, in combination with thimet at planting following fumigation, or in combination with thimet at planting following fumigation. My screen doesn't seem to be changing here. Are you still hearing me?
Yes.
Okay, well, I'll keep on talking. My slides are not changing anymore. Let's see. What to do about that? Okay, well, I'll keep talking. Okay, in the graph that we're not able to see.
Maybe escape.
Oh, escape, good idea.
Yeah.
Well, nothing's happening.
Oh, maybe your mouse is not working.
Oh, okay, there we go. It just changed. Maybe it's slow.
Yeah.
Oh, so who knows what it's going to do. Okay. All right, we'll just proceed. In this graph of bulb circumference at harvest, the white bar towards the bottom is the untreated. All treatments, where am I here? All treatments above the line drawn across the graph are significantly better than the untreated at the 5% level. With respect to bulb circumference, 13 treatments, including all treatments with essential oils, outperformed the untreated. The grower standard treatment was not significantly better than the untreated. Okay. It's changing again here. Okay, well, I'm going to just keep talking. So the next graph is of lesion nematode and roots at harvest. Again, there was a white bar, which is the untreated, and all treatments above the line drawn across the graph were significantly better than untreated at the 5% level. So 9 treatments, including 3 with essential oils, and the grower standard treatment were in this group. As in the walnut trial, it appears that we are seeing improvement in plant growth without actually reducing nematode populations. What's my time like? Should I go on to one more trial?
You have another 3 minutes, ma'am.
Okay, so what I'm not, the slides are not changing, but the last trial we did was a trial on carrots with eco-friendly products. And basically we used essential oils, self-defense inducers, soil extracts, a surfactant plus amino acids, and the newer, more environmentally benign chemical products, and some traditional fumigants.
Okay.
And basically what we saw is that as in some of the previous slides, we had quite a few treatments that increased the percent marketable carrots, but either did not decrease the nematode, root knot nematode, or actually increased it in some cases. So, so I think at the end now, and I'd be happy to answer any questions. I think what we have is, we have new eco-friendly products for nematode management.
Thank you, ma'am. Now, if there are some questions, I can allow 2 or 3 questions. Yes, Dr. Pandey. You have to unmute Dr. Pandey.
Ma'am, what is the fate of trichoderma in management of nematodes? Because in some institute it has done excellent. Hello.
Yeah.
I think, sir, network problem, I think, sir.
Professor Vicky, are you able to listen, Dr. Pandey? I think, yeah, some network issue.
Nani, yes, it is audible.
It is audible, but she is not listening, I think.
She is, I think, disconnected, sir.
That's it.
Disconnected.
Okay, I think then you may post the question, Dr. Pandey.
Sure.
Now, thank you very much, Dr. Becky, for wonderful presentation. Of course, there were some network issue and interruptions, but the information given by her was excellent on eco-friendly management of nematode diseases, particularly the root lesion nematode. Now I will invite the second speaker, Professor Daniel Roberts, who is a microbiologist and research leader of the USDA ARS, Sustainable Agricultural System Laboratory in Beltsville, Maryland, USA. He is in molecular plant microbe interaction and biological control of soil-borne plant pathogen. That is the area of specialization. He also has interest in the use of geographical information system, that is GIS, in sustainable agriculture. Professor Robert has published more than 130 research publications in his area. Now I request Professor Daniel Robert to start his presentation.
Okay, thank you. I pre-recorded, so I'm just going to run my PowerPoint. I'm going to share my screen now and get started.
Yeah, just wait, I am sharing from my side.
Oh, you're going to do it. Okay.
Yeah. Hi, Robert. We don't have your slide. I can see that. So could you host yourself?
Sure. Here we go. It's frozen.
Before Robert start, I would like to request Dr. Malkhan Singh to invite Dr. A.N. Mukhopadhyay to co-chair this session.
A.N. Mukhopadhyay, sir, joined, sir?
Yeah, he has joined.
Professor A.N. Mukhopadhyay, sir. Voice is not coming.
I think he has some audio issue. I can switch on his video at least.
Yeah, you put the video and
Yeah, now.
Yeah, sir is there.
Sir,
Sir, you are not audible, sir. Please switch on your audio, sir.
In the meantime, please introduce Professor Mukhopadhyay.
Yes, sir.
Singh. Yeah.
Yes, sir. So Professor N. Mukhopadhyay was born in March 12, 1940 in Katwa, West Bengal. Professor N. Mukhopadhyay started his professional career as an instructor in plant pathology in BHU 1962. Later joined the Department of Plant Pathology, GB Pant University and Technology, Pantnagar 1967. Later on, he's a professor head of Department of Plant Pathology, Gujarat Agriculture University 1982. Later, he joined as a Dean, College of Agriculture, Pantnagar from 1992 to 1997. And he in 1997, he was appointed as a Vice Chancellor, Assam Agriculture University, Jorhat. Currently, Professor Mukhopadhyay sir is Honorary Director of Biopesticide Division of Super Agro India Private Limited, Kolkata. He has guided many students, 15 PhD students, 20 MSc students. Professor Mukhopadhyay is received many awards like Professor M.G. Narasimhan Academic Award, MS Pagi Award, and he is invited and visiting professor in USA, UK, Canada, France, Singapore, Hong Kong, Italy, Malaysia, Philippines, Switzerland, and Thailand. Professor Mukhopadhyay has a distinguished alumni of BHU and received Lifetime Achievement Award 2008 of Agriculture and Horticulture Development Society. Also received N. Prasad Memorial Lecture Award from ISMPP 2009. And in his research area is well known. We know that biocontrol aspects, his international fame of biocontrol aspect of research. So I request to Professor A. N. Mukhopadhyay sir to kindly chair the session in the eco-friendly management, especially biocontrol aspects. So I cordially, on behalf of society, I invite you, sir. I think why?
Sir is just offline. Maybe he will
Offline.
join again. We can proceed.
We can proceed from link.
So, Professor Daniel Robert, he can start his presentation.
Okay, try this again.
So slides here.
Amlindu, are you sharing slides or Dr. Daniel Robert is sharing?
We don't have Dan's slide, so he have to share himself.
Okay, sir. So Dr.
Can you-
Daniel Robert, kindly share your slides and you present your from your side.
Yeah, I'm trying to share screen and it's,
Amlindu, you option is share screen in the right corner. You can allow the multiple participant can share.
It's enabled.
Enabled, na?
how about now? Can you see it?
No,
Oh, there. Can you see? It's not.
Yeah, it's not coming. Can you try again?
I am, yeah. Oh, boy. I'm hitting share screen and nothing's happening.
some technical. No.
So you just stop sharing and then share it again.
It's not working.
Or you can send your PPT by email, so we can move to the next speaker, and by that time we can download your PPT and you can come up.
It's too big to send by email.
Okay.
It's too big.
I sent it Sunday.
Okay, let me check.
So to
Dr.
save
Roberts,
time, I think we can move to the next speaker by the time he's getting ready. Will it be
Sir,
okay?
yes, sir.
That will be okay, I think.
Yeah, so I think we should invite the next speaker, a very close friend of ours, Professor R.N. Pandey. who has been the president of Indian Pharmaceutical Society in the year 2018. So briefly, I will introduce Professor Pandey. Professor Pandey started his career as assistant professor in 1986 to 1991, associate professor 91 to 99, and professor from 99 to September 2007, and different institution, and served as professor and head from 2007 to 2018 at Department of Plant Pathology, College of Agriculture, Anand. He taught several courses to PG and UG students, guided 15 MSc and PhD students, has published 45 research papers, 5 books, 8 book chapters, 5 bulletins, 5 practical manual, 10 review article, and more than 68 popular articles. Dr. Pandey has presented several of his papers in international and national workshops. He was principal investigator in 28 research projects sponsored by different funding agencies. Dr. Pandey was instrumental in establishing the state-of-art lab for molecular characterization of plant pathogens and also trichoderma production unit at Anand. I personally visited when he organized the Indian Phytopathological Society annual meet. Dr. Pandey conducted research in the detection of plant pathogens, pathogenic variability, genetics of host-parasite interaction, epidemiology, and chemical and biological management of diseases, and recommended 28 technologies of disease management to the farming community. Professor Pandey is on the panel of experts of several agricultural universities, ICR, and other institutions. He has been course director of 2 winter schools, 2 SAR training programs, organizing secretary of one ICR workshop, and he also organized 4 IPS and ISMPP annual conferences. As I said in the beginning, he has been the president of Indian Pharmaceutical Society in the year 2018, and he was also zonal president in 2010 of IPS, joint secretary of ISMPP, and member of QRT ICR of many institutions. He has been awarded the fellowship by various professional bodies and also awarded Jirsa Nidhi Award. So with this brief introduction, I request Professor Pandey to deliver his talk. Professor R.N. Pandey, please.
Sure.
So your time is 15 minutes, Professor Pandey.
Sure,
So,
sure. Sir.
yeah.
Yeah, thank you, my dear friend, Dr. Singh, for your kind introduction. Chair, respected chair, dignitaries, distinguished participants, a very important topic today on the trichoderma species in management of stresses in. Just
Go to full screen, Dr. Pandey.
sure.
Slide mode, sir.
Yeah, slide.
Yeah. So trichoderma species in the management of stresses in plants, their commercialization for sustainable agriculture and rural prosperity. As you all know that the researches are conducted to solve the basic problems and technology development for the betterment of mankind. So with that aspects, we had developed, did the different researches to develop the technology for the betterment of human being. So as all you know that the agriculture is the livelihood of many countries, many people, and it provides the raw material for human. And as per the estimates of that we will be 9.8 billion in 2050. Now the agriculture is facing different challenges, that is biotic stresses, that is prevailing and emerging pest of the diseases, abiotic stresses, that is deteriorating soil health because of salinity, alkalinity, drought, heavy metals, and then extreme temperature, that is cold and heat waves, etc. Now, just to feed all these population, we have to enhance 70% of our production of the crops. And as present, as per the estimates, crop yield losses and pesticide use are that in with the pest we are getting 31 to 42%, losses and diseases is causing about 20% losses in India, which is of 1.9 lakh crores. If we save this crop, we have to save this 60 million tons of food grains and 60 million tons of the horticultural crops, which will be the sufficient for feeding 30 crores people in India. So this is the nowadays the management problem of the stresses are limitations of chemical which is used in large stage because of the injudicious use of the pesticide, lack of resistant host cultivars, fungicide resistant development in the pathogen and breakdown of the host resistance. As you know that among all the pesticide, now the biopesticide is having only 4% shares for the disease management. Now, as you know that these different crops are caused by different diseases are caused in different crops because of the particular soil-borne pathogens like here, and they are causing collar rot, crown rot, etc. Now you see that the soil that is the rhizosphere is the fertile soil of the plant nutrition, and it thrives about 1 billion microbes per gram of the soil. So root exudates stimulate the biological interactions for plant growth and survival of the microbes. And this rhizosphere is the playground for soil-borne pathogens and beneficial microbes. Now about this all many pathogens, many these microbiomes have been detected, very useful. And in that this trichoderma is a wonderful fungus. It is a cosmopolitan. Up till now, more than 200 species of trichoderma has been detected, and about that, many are of the endophyte in nature. And this trichoderma has been studied for stress management, crop growth, and so on and so forth. And they are the best decomposer of organic matter, phosphate solubilizer, and that's why they release the micronutrients for the growth of the plant. Then phytohormones are also being released by the trichoderma, and it also cause the good growth to the crops. So the management of abiotic and biotic stresses also, it has been fully utilized and doing very well. At present, the commercially registered trichoderma in India by CIBRC is permanent registration is 30, Trichoderma harzianum is 1, Viridi is 29, and temporary registration to the companies, etc., is 322 Trichoderma harzianum and 55 is Trichoderma viridi. So, like that, we are getting that what are the different mode of actions of this. They are used for the biotic stresses because of they do the competition for its nutrition and cytophore production, pathogens, because of the presence of the hydrolytic enzymes, that is all these are there. And they are also associated microbials because they produce different molecules which help in the induced systemic resistant and systemic acquired resistance. And it is also used for management of the abiotic stress, that is salutary alkalinity, root growth, and that's why it being produced in large scale nowadays. And Dr. H.B. Singh and Dr. N. Mukhopadhyay sir is the pioneer of this trichoderma. And now because it is a biopesticide, biofertilizers, growth enhancer and stimulant of the natural resistance. Now you see that this trichoderma is now the new concept of the endophyte trichoderma. They are the opportunistic avirulent plant symbiont. They increases the plant growth, resistance, and antagonistic to the pathogen. The main thing is that when they become the endophyte, they develop a ecological niche inside the plant and compete for the space and nutrition and inhibit the pathogens and reduce the necrosis. In one case, in the pinus, the Gramenella, which is causing the necrosis to the pinus, and with the treatment of the trichoderma, the necrosis was reduced. At IRI, the work has been done by the trichoderma asperillum and spheruloids, and after the inoculation to the seed and seed soil treatment, they have become the endophytes. So this is very good that this trichoderma is also an endophyte. And if you see that the mode of action induce systemic resistance, if you inoculate the plant or the seeds or the soil, they are becoming the endophytic in nature, and then they cause the systemic resistance to the crop. This trichoderma, there are number of strains of the trichoderma have been studied for the inducing the systemic acquired resistance. In the bean, tomato, grapes, and all these, they have been tried, and they have induced the resistance where the no infection was there. Like in the pesticide, if it is there, then it will be causing this one. And in this case, they activate the pathogen activation of the pathogen pathways related to the antifungal compounds in leaves, and they develop, and that's why the word of the pathogen. Now this rhizosphere microbiome community, as I told that we have, they have been found rhizosphere microbiome community, and where uh, we can develop the associated, in that case the aspergillum and Pseudomonas fluorescens, if they are doing together very good synergistic effects are there. And consortium enhances the plant growth promoting activities and biotic and abiotic stress management. And because they occupy the different zones in the rhizosphere, so they are not interfering each other or competing. Nowadays, the two type of the models have been developed for the use of these bioagents. That is model one in full registration and marketing, if they are the microbial pesticide model. So if they are used for the pesticide as a claim, so they have to be registered with the environmental protection agencies, like in US and in other. And model 2 inoculants, for the inoculants are PGP are growth stimulant. And in this biofertilizers, so trichoderma, viridi, fluorescens, etc. have been developed for this. Now for the commercialization of the trichoderma species, we have to go process wise. Then the isolation of the native efficient strains from the natural ecosystem, standardization of solid and liquid state mass production, then develop the formulation, standardization of delivery system, compatibility with the agrochemicals if they are to be used together simultaneously. Now, as you see that delivery of the trichoderma management for the biotic and abiotic stresses, the different scientists, they have developed a very good delivery system for the efficiency of the trichoderma, that is seed treatment, nursery treatment, cuttings, soil treatment, plant treatment, and furrow application. But and now this seed priming, seed coating, and drip irrigation is also developed, and that is very good novel delivery systems. With the guidance of Dr. Singh at BHU, they have developed the seed biopriming, and at our laboratory also we have worked for this biopriming, and it has done very good because there is close association for the different type of the seed coating and through the drip irrigation. So uh, the seed biopriming, when we are treating the seeds with the trichoderma, then incubating in the moist chamber, then in the meantime the trichoderma is getting entry into this, and this establishes the relationship for radical and all these emergence. So it is doing very well. In the drip also, somewhere in other countries, they have developed the formulation that is 1 liter of per hectare formulations for the management of the Sclerotinia sclerotiarum. So as you know that when we give the seed treatment, this radical and plumule elongation is very good in that cases. And also here, if you see that this seedling elongation or seedling development is very good in comparison to the control. And in this case, we have developed a sick plot comprising of the Fusarium pathogen, Fusarium seseri and Sclerotium rolsi. These two are very, very important potent pathogens for the causing the reduction in the seedlings in the soil. And if we do the seed biopriming with Trichoderma viridi and showed the seed in the sick soil with the Fusarium and Sclerotium rolsi, even though the seeds, you can see they are grown very well and they did excellent. Similarly, in case of this different bioagents, Trichoderma harjanum, viridi, and virens, they have tried in together in combination with Pseudomonas fluorescens, and these are the different Trichoderma species, and here they have been in the combination. So In the combinations also, Trichoderma bridi and Trichoderma pseudomonas fluorescens have done excellent. So this indicates that if we use together for the seed treatment, that will be the additive effect or synergistic effect. Now the solid state fermentation, different substrates have been developed, and Dr. Mukhopadhyay and his colleagues, his student, they have developed the sorghum grain and other type of the substrate for multiplication of the trichoderma. And out of these sorghum grains are now widely used for the multiplication of trichoderma. It is doing very good. And similarly, the liquid fermentation is also have been developed. And in that, the dextrose broth is doing excellent in the laboratory for the production. In our lab also, we have used this medium and for the growth of the trichoderma. Similarly, the substrate used for the mass multiplication of trichoderma is all the agricultural based, because I told that they possess the different hydrolytic enzymes, and they are very efficient in decomposition or mineralization of the organic waste, and then make it a very good food for the nutrition for the plants that they can use. What we have found that organic matters, well decomposed organic matter, then pressed mud, poultry manures, etc., and vermicompost, etc., can be used for multiplication. Now, in our laboratory, we have developed this fermentation technology, and in that we have found that 200 ml of the trichoderma, we inoculate in 14 liters of the water. In 14 hours, they can develop, they are converted into a mass of the trichoderma, and then sporulation we can get very good in this one. So we have developed these formulations, as I have listed here. In that, this starch-based formulation is doing very well, because it is very easy to use and very handy also, and very convenient to the users. And in our laboratory lab-to-land initiation, we have developed this unbotrichoderma with that, by designing the different technology. And with this help of the RKBY project, we have developed this trichoderma, unbotrichoderma, our brand in our university. And we have supplied to different farmers and tribal farmers. We have got very good overwhelming response from the farmers. And now they have, because the technology is good and doing very good in the management of the wilt and root rot, so the farmers are taking it and using it in large scale. So similarly, we have developed these different technologies, that is here, seed biopriming, then seed treatment, and the another benefits for the enrichment of the this FYM, etc., for enrichment of the manures and cakes, etc., and to use in the agriculture. So what Dr. Singh was telling, that we have developed this laboratory, and we were the fortunate to have a number of stalwarts of this working on the trichoderma at our laboratory, and for the visit of the lab. So here, lab to land initiation, we have got very good fund from the tribal fund from the central government, and we have propagated this technology in our laboratory. And these ladies and women and men and women scientists, these workers are the farmers. They have visited, they have been imported training, and they are now using this technology, and whole transformation is visible in the villages. So this farmer has got very good success story with this tomato, and that's why in our Kitsim also he interacted with our then Chief Minister and now the Prime Minister of our country, Honorable Narendra Modi ji. This is the success story that you can see here, the tomato crop and luster and fruit size and everything was very good in this one. Now issues for commercialization of the bioagents is availability of the CIBRC registered strains to the entrepreneurs. Up till now in India, only one or two strains are there, breeding and all these, and they have to multiply. So with different institutes, they have worked very well, and they have isolated different efficient strains. So they need the promotion for the bioefficacy testing. So they require the fund from other things, and then they can do the better. So now the emphasis should be laid in the research is to develop the endophytes and to register them with the CIBRC. And the subsidies are required to establish the laboratory. Then in each districts are in some area bioresource complex developed for the training and the guidance to the people and societies for awareness about this bioagent and particularly trichoderma and PGPR is needed to be established for the promotion of the bioagents and establishment of collaborative research groups. This is also very much required research groups for the innovation to outcome. Now this is we have worked out the project and for profit and loss, and what we have found that we are getting about 46 rupees profit when we are developing this 4,500 kg trichoderma per month. And it cost about 4,57,000 initial money, and with that if we are calculating and 15 rupees profit is coming per kg about this one, and we worked out it, if you can get about 2,07,000 per month a entrepreneur can get. So this is naturally a profit making business, and like that different bioagents they can try and they can sell to the farmers, then farmers will be benefited and the entrepreneurs will also be benefited. Then trichoderma in rural prosperity. This is the about the large
Professor
area of.
Pandey, you please wind up now.
Yeah, only 2 minutes.
Yeah, 2 minutes.
Then the growth of the agriculture sector is very much important, and this for the trichoderma is very much working very good. And now this organic farming is increasing in and Sikkim and Uttarakhand has been declared as organic states. Forest area is converted into organic states. So this is a sunrise sector, and the funds are available with the startup recent development Atmanirbhar Bharat by Government of India and all this. Now at the conclusion, the trichoderma is working very good. The students, they are working under experiential learning program in the universities. They are getting the experience training for the production unit, establishing the production unit. If all these agencies can be contacted and they give the money, subsidies as well as loans to the entrepreneurs, the number of units can be established and they can do better. So thank you very much for patient hearing. Thank you all.
Thank you, Professor Pandey. Now I welcome Professor N. Mukhopadhyay, who just joined, sir. Very good morning, sir.
Good morning.
Yes. So
I'm sorry, there's something wrong in the communication. As communicated yesterday, the meeting will start at 10:30.
Yeah, I
So
too was
I
given.
let.
Yeah, yeah, I was also given.
I'm very sorry for that.
Good morning, sir. Mukhopadhyay, sir. Good morning very much.
Thank you. Thank you very much, Dr. Pandey. It was an excellent presentation.
So kind
you have
of
given
you,
a
sir.
review and you have spent your lifetime in trichoderma and still continuing. And it's a very good opportunity for the stalwarts like you to continue with the work.
It is because of your guidance and blessings, sir.
Thank you very much. Thank you.
Sir, if you permit, I can invite the other speaker, Professor Reddy, or if the previous speaker is ready, Professor Robert is ready.
We have Robert's slide, so I can share from my side.
Okay,
Okay, good.
Then yeah, please.
Go ahead.
Okay. Keynote speakers. I don't know.
Trichoderma Center. The agricultural community is faced with a number of challenges, including production of nutritious food, increasing production of nutritious food, while at the same time decreasing the impact of production on the environment. Plant disease control will figure prominently into meeting this challenge or these challenges. It's estimated that plant pathogens and pests, insects, weeds, cause plant yield losses of up to 40% in these staple crops. Endosperm of cereals alone supply about 50% of calories in the human population. Clearly, decreasing these yield losses will help meet food production needs now and in the future. We also, and this is really important, need to speed delivery of new technology to farmers and increase adoption of this technology by the farmers. Because without adoption of this technology, development becomes a simple academic exercise. Use of geospatial data will figure and change the way we grow food and control plant disease.
No, I can say that.
And change the way we use current technology. Precision agriculture.
Mute or unmute? Please, you can speak. You can speak. You can speak.
Instead of across the entire field.
So I think your voice is cracking. I'm sorry, Mr. Speaker.
Biologicals, such
Your
as
voice is cracking.
Dr. Amlendu,
this is like
clear actually.
Geoinformatics as part of IT systems will increase collaboration among scientists.
so this is recorded one, and we can't modify much.
Okay, recorded. Okay, this is recorded.
Maybe it's better to play tomorrow when it's refined. There's no point.
Makers and importantly, farmers and other members of the agricultural community.
Can't understand anything.
Lot of echo is coming, sir.
Farmers' fields are heterogeneous.
What I can do,
you can just delete the voice part
that
of
I
the
can,
slides.
what I can do, and if Dan can speak the slides.
You just delete the audio part and share slide again.
What would you like me to do? Can you hear me?
Yeah, just wait for a minute.
Who's speaking now?
Professor Daniel Roberts is speaking.
I'm sorry?
Professor Daniel Roberts.
No, but his voice,
it's
a recorded one.
Yeah, so it's cracking. A lot of noise is coming from the background, so difficult to understand.
But Dan Roberts, when you are speaking from there, you could hear him very clearly.
Yeah.
And he's on
what's going on? Hang on a second.
Yes, I think you can go ahead. If your recorded message is not coming out properly, you can speak as such.
Hang on, let me pull up.
Okay. Okay.
So Professor Singh's up.
Yes,
I think since it is recorded, you guys
it
can
be
play
played at the
anytime.
end. Yeah,
Anytime.
absolutely fine. Yeah,
Point.
I agree with you.
You understand it is almost 2 a.m. for us here.
So, Professor Mukhopadhyay, sir, if you permit, we can invite the next speaker, Professor
Dan can start. It is there.
Okay.
It's coming.
Go ahead.
Okay.
Dan, please proceed.
Try this. Can you hear me?
Yes, now it's clear. The voice is
Okay.
clear.
You know who I am. Sorry about the technical difficulties, but it's a pleasure to present today some work I'm doing with my collaborators, Dilip Lakshman, Nick Short, James Sill, Lane Graham, Zoja Mike Booser, and others regarding the use of geospatial information systems, or GIS, and geospatial tools to solve problems in plant disease control. Now, who's got control of the slides? Do you or me?
So then you continue. And
I'll call you if it is in your head. Yes. Okay.
Okay.
I just keep belly.
Faced with two challenges: increasing production of nutritious food, while at the same time we have to decrease the impact of our crop production systems on the environment. Plant disease control will figure prominently into meeting these challenges. The endosperm of cereals alone supply approximately 50% of calories to the human population, and it's estimated that plant pathogens and pests, insects, weeds, cause plant yield losses of 10 to 40% in these staple crops. Clearly, decreasing these yield losses will production now and in the future.
क्वींसलैंड में कोई इंडियन ओरिजिन की है रीना
From Lindu, mute
Start please mute
session.
Morning, post lunch session.
All right. So we need to decrease these yield losses to help meet food production now and in the future. And this is important. We need to speed the delivery of new technology to farmers and increase farmer adoption. Without farmer adoption of new technology, development of any of this technology becomes an academic exercise. All right, now I'm on the correct slide. Use of geospatial data and tools will change the way we grow food and control plant disease. It's already changing the way we use current technology, precision agriculture, where we apply pesticides only where needed in the farmer's field. And it will change the way we use sustainable crop production technologies, cover crops, biological control agents. And finally, use of geoinformatics as part of IT systems will increase collaboration among scientists, policymakers, and importantly, farmers and other members of the agricultural community. Go ahead and advance the slide, please. There we go. Now, go ahead back. Sorry, we're screwed up. Go back one. No, the other way. One more. There we go. Now, farming is inherently geospatial. Farmers' fields are heterogeneous, varying spatially with regard to not only pathogens and pests, but also with regard to soil fertility, water availability, topography, etc. Sensors in the field and remote sensing, UAVs, satellites, etc., allow monitoring of the field of spatial variability in crop yield, soil fertility, water availability. Geographic Information Systems, or GIS, as the organizing principle for the spatial data, allows collection and organization of this big data being data that varies in type, volume, velocity, so that we can now manage geospatial data and apply analytics. Sense spatial data can then be used to manage application rates of pesticide and other resources such as fertilizer and water. In other words, precision agriculture. The farmers can then stop treating the field as a homogeneous substrate in which to grow crops and then apply resources spatially. This will decrease input, increase yield, decrease costs, and increase profits, and importantly, decrease environmental degradation. Next slide. Thank you. It's obvious that GIS, big data approaches, and geospatial tools will be increasingly useful with precision disease control using pesticides, although more work needs to be done. It's good right now for certain diseases such as cotton root rot. It's problematic with rapidly spreading diseases. Next slide, please. Now here's an example of a sustainable crop production system using biologicals to increase cropping system sustainability and control of disease. It's our sustainable tomato production system developed by some prior members of my group years ago, Ref Abdelbaki and John Teasdale. And with current tomato production, not the sustainable production system, on the East Coast, they use black plastic for weed control, synthetic fertilizer, and pesticides for important diseases, including early blight caused by the soil-borne plant pathogen Alternaria solani. Now, the sustainable tomato production system uses a leguminous cover crop, hairy vetch, instead of this black plastic. For this production system, you make elevated mounds in the field or raised beds in the fall, and then sow hairy vetch, the cover crop. It grows over the late fall through the early spring. Kill this cover crop, the hairy vetch, with a light dose of herbicide, and then the tomato plants, seedlings, are no-till planted or transplanted into the resulting hairy vetch mulch. So you've incorporated this hairy vetch mulch to replace the black plastic. Next slide, please. The hairy vetch is a legume, so it increases soil fertility, nitrogen fertility, decreasing the need for synthetic fertilizer. You get complete coverage of the field with the vetch, as opposed to what you see in the middle image there with the black plastic. So you decrease runoff and soil erosion. You increase water filtration into the soil, I should say infiltration. You decrease pesticide runoff of nutrients. And you also get a modicum of disease control of Alternaria solani. Again, due to this coverage of the entire field with this mulch of vetch, you decrease water splash dissemination of inoculum of Alternaria solani into the tomato canopy, decreasing disease. And with this vetch system, and we're not sure what it is about this vetch system, You also induce some tomato defense genes, osmotin and chitinase, also contributing to disease control. Next slide, please. Now, as I just stated, cover crops can help control disease and deliver a number of ecosystem services. In the example before, soil nitrogen, fertility, decreased erosion. But we need to manage the cover crops. In the case of the past example, this hairy vetch, to maximize these ecosystem services in the crop production system. And in this slide, you can see Mirsky et al., also from my group, the Sustainable Ag Systems Lab in Beltsville, Maryland, using GIS and geospatial tools to develop precision systems to apply cover crops so that you get the needed biomass to get effective delivery of these ecosystem services from the cover crops. Next slide, please. Likewise, with other biologicals, microbial biocontrol agents for disease control, precision approach will allow delivery of the biocontrol agent to where it is needed in the field, not throughout the entire field, driving down costs. And this is important because cost is an important impediment to the use of biocontrol agents by the farmer. Next slide, please. As shown in the past slides, using these precision approaches for application of pesticides, cover crops, biologicals, increases cropping system complexity. There are more cropping system components that we've got to have managed by the farmer. And this is particularly true when you're using these sustainable approaches with biologicals, because the biologicals themselves have inherent management needs. So now you're asking the farmer to not only manage the cash crop, but also the cover crop or microbial biocontrol agent. And as I stated earlier, we need grower adoption for success with new technologies. We need to make decision-making easier for the farmer to handle. This information overload coming from these precision systems to get farmer buy-in of these sustainable approaches. And this is why geospatial decision support tools are being developed to aid the farmer in managing data and making decisions regarding their cropping systems. Next slide, please. Perhaps the most effective way to control disease is through development of disease-resistant crop germplasm. Resistant crop germplasm decreases cropping system complexity. You don't have to time pesticide application, choose the right pesticide, rates, etc. And it's easy for farmer adoption. Farmers really do know how to work with seeds. GIS and geospatial tools are useful here with regard to enabling high throughput phenotyping of new crop germplasm, increasing the speed of development of these new crop cultivars with the desired phenotypes, in this case, resistance to plant disease. Next slide, please. Now, as I've stated a couple times, we need to enhance collaboration to speed development of sustainable disease control tools. Development of sustainable disease control technologies I just described needs collaboration between scientists from various disciplines, plant pathologists, agronomists, plant breeders, molecular biologists, bioinformaticists. In some cases, these scientists need to be located in different geographic regions. For example, with crop germplasm development, where crop varieties need to be tested in different climates, soils, etc. Here, geoinformatics and data science is helping as well. For example, my agency, the Agricultural Research Service, is using GIS-based platform AgCross to foster sharing of data and expediting model development. Because GIS components in AgCross are designed to operate in a federation or systems of systems called WebGIS, data can be easily shared worldwide. And this is important when pushing information products in the form of mobile decision support tools to the edge in remote areas where bandwidth may be limited, but decisions have to be made quickly. Where are we? Hold that slide. AgCross is being used to enhance collaboration among scientific teams, in this case, farmers, to develop disease control technology and importantly, enhance farmer adoption for citrus greening in Florida, which is devastating our Florida citrus crop. AgCross is being used as a platform to collect, aggregate, and manage data from a variety of sources to interface farmers, citrus growers, and scientists in real time. And in this, actually, can you go back a slide, please? reverse one slide. Anyhow, I'll keep going. In the prior slide, no. Okay. So we developed a dashboard to sign up farmers into an on-farm network. Information in this dashboard is aggregated and across from farmers at the edge. The dashboard can be used to collect farmer entries about plant planting, management practices, pest management decisions, etc. Scientists can use this information entered by the farmers to approve projects on farms based on scientific merit and experimental design. This platform across also allows data to be captured, aggregated, and correlated to treatment outcomes continuously from farmer-performed on-farm experiments via mobile apps. And in conclusion, the green revolution we all know about has increased crop productivity by leveraging higher yielding crops with synthetic fertilizer, pesticides, irrigation. The result was that we could feed the masses, but also we got environmental degradation. To meet the challenges that I outlined at the beginning of my talk, we need a second green revolution. We need to change the way we grow crops, including how we control disease. We need to develop more sustainable disease control technologies, and importantly, disease control technologies that function within sustainable cropping systems. GIS, big data approaches, and geospatial tools will contribute as components of smart, more sustainable disease control tactics. They'll also contribute by enhancing collaboration to speed development of new technology, and importantly, speed adoption of this new technology. And with that, I'll conclude. Thanks.
Thank you, Professor Daniel, for a very nice presentation in spite of all the arts. Thank you very much. If there are questions from the audience, yes.
I think I'd like to say one thing.
Sir.
The speaker has very exclusively presented and he's talking about the second green revolution. And I think this is the order of the day. If we can use this technology, which he has just explained, and told that if we can collaborate with different branches of agriculture scientists and can seek for, certainly second green revolution will take place, but we have to collaborate with all the other disciplines of the science. Plant pathologists alone cannot do the job, which is very important. And I must thank Dr. Daniel for making such an excellent presentation. May I ask one question to Dr. Daniel? Hello?
Sure, go ahead.
Yeah, do you have any information about Dr. Lumsden, who was a good friend of mine? We used to work
Bob
together.
Lumsden. I saw Bob maybe a year or two ago.
Yeah.
I used to work with Bob Lumsden years ago.
I see.
Before he retired. He's doing well. He's still with of course, he's still with his wife, but his wife and he are still alive.
Yeah.
And they're doing great. So,
because I sort of visited your lab way back in late 90s when he was there.
I probably met you then. I probably met you. I worked for him in the late 90s.
I visited Bellsville and visited presentation. Okay, thank you. Thank you very much.
Okay.
So, sir, should we invite
any other question? Any question or comment from other participants?
In this session, I welcome our President IPS, Dr. P.K. Chakravarti, sir. Recently, he joined this session. Welcome, sir.
Now, any comment from any participants about Dr. Daniel's presentation?
I'll make a comment, actually. If we have a minute or two, one of the things I'd like to point out is through the use of collaboration in WebGIS, what we can now do is host platforms, say in the United States, on a different continent and help farmers make decisions, say in Africa.
Yeah.
Use of mobile apps, phone, somewhat other mobile app where the farmer in Africa, Asia, can enter information regarding a particular disease or some other question or data in their cropping system. That can be directly inputted or will be able to be directly inputted into models. We're hosting, say, in Across.
Yeah.
Information from these models can then be fed back to the edge at that farmer in Africa. So not only can these geospatial tools be used with very sophisticated farming systems where you're highly instrumented, but also help people who have less sophisticated farming systems.
Exactly. Very true.
You can help feed the world in different
Yes.
regional ways.
Yes. Here's a
Dr.
question here from
Yeah,
Dr.
Dr.
Reddy, Professor
Yeah,
Reddy.
Dr. Mukhopadhyay. Yeah, question to Dr. Roberts.
Okay.
Hey, Roberts, you work for USDA. You're saying you can give inputs to the farmer in Africa or in India. So my farmers in India want your expertise and guidance through your models. Can you give them free of charge? Are you going to charge to them?
Okay, I need to clarify. Towards is a system where we can give this information to farmers anywhere in the world. That's what we're working towards. We can't do it just yet. Free of charge. I'm not in charge of the economics of this sort of thing, but I mean, obviously, it would have to be economically feasible for it to be workable.
Exactly.
Different parts of the world, yeah.
No, I think nothing is free. There is no free lunch. Even if you go to a doctor, if you don't pay the fees, you don't get the
No,
results.
Dr. Mukhopadhyay is working for the government, which is a non-profit organization.
Yeah.
Same as ICR.
Yeah.
If I ask ICR scientists to share his or her knowledge free to the citizens of the country and other partnering countries, the citizens too.
The knowledge would be free.
Right.
Infrastructure, I don't know. I don't fees you'd have to pay to have access to the models and whatnot. But yeah, I mean, it's U.S. government. It would be U.S. government or whatever government's nation.
Me from a land grant university, which is a government funded.
Right.
All our knowledge is freely shared within the country, within the state, within the county, within the municipality. Has to be free.
Right.
But I do have a restriction to share outside of my province, rather state or municipality or a corporation or a county. Then the land grant university administrator asking, why are you giving free? Are you getting any benefit back? So there's, give and take stuff.
Well, thank you so very much, everybody. Now we can go to the next speaker. Yeah, Dr. Chakraborty, welcome. Welcome.
Yeah. Good morning, sir.
Good morning.
Nice to see you, sir. Sir, I'm sorry, missed a large part of Dr. Roberts' talk, but I have 2-3 things in mind because for popularization of these kind of biocontrol agents or biopesticides or biostimulants, whatever we call them. One is agrospecificity. It is required for agrospecific selection of a control strain required for practicing biological control throughout a country like India, where we have climatic conditions from tropical to temperate regions. This is number one question. If Dr. Robert wants to answer now.
Your question is about microbial activity and how it varies with different environmental conditions.
Yes.
Yeah, I mean, biologicals have inherent needs for their performance. And you do need to select microbials that are effective under the given environmental conditions, the soil, etc. Of the region. And one of the reasons, actually, I do work with this sort of thing. We work with strain combinations, where we are combining strains with different ecological adaptations to try to see if we can get better performance amongst or within a number of different environments. And so far, it's been promising. We do a lot of work with Bacillus subtilis and Megabacterium.
Thank you, Robert. That answers a part of our question. But what is happening in India when we test a variety of a crop variety, we test in different regions of the country, and release them. Government of India releases them only in the place where it performs best, because their effect is the interaction of environment, as you have rightly said. So we are all in a fix of mind always, whether a strain of which has been identified in a tropical part, in say Tamil Nadu part of the India, which might have developed in the ecosystem along with the roots or the plant system, along with the conditions, environmental conditions, and then the same strain is also extended to region like Jammu and Kashmir, which is totally freezing kind of conditions, and agriculture region. So will that be effective? That should be, we should be doing it, or we should have tested it in a different before releasing a strain specificity basis release of the country.
You need to test your, are you asking about the microbial biocontrol agent? Or?
Yeah, microbial.
Yeah, you need to test these strains in whatever different environmental conditions. I've been to Jammu and Kashmir, actually. It's very pretty. And of course, it's always best to use microbials from these regions that might be adapted to more cold weather, say. But you do need to test them to see how they work. And it is a problem with microbials in that they are biologicals and have these issues with regard to the impacts of environmental conditions on the performance.
Thank you. Robert, another, sir, with your permission, one more question I wanted to ask.
Of course.
Although I have a volley of questions, but time does not allow probably on biocontrol agents. Like we insist while registering a strain of a, say, any trichoderma or a bacillus or pseudomonas species within the country, because their registration is governed in India like in the United States under Insecticide Act. This microbes used for biological control. So do you think we insist upon 6-pack studies like inhalation toxicity, acute oral toxicity, dermal toxicity, and so many other toxicities, which are impeding factors for the strains to become popularized? And biocontrol area in the country, when we calculate at the moment, is 3%, despite being practiced for last more than 5 decades. So we think one of the reason is awareness, and there are several reasons, and one is the registration requirement by Government of India. So do you think when we test a trichoderma for all these things, once test for any strain will suffice for all the strains of the trichoderma, or we need to have individual tests for different strains?
You know, you're getting into legal aspects.
No, I'm asking the scientific aspect, because when I talk to my Indian Council of Medical Research, they say out of 100 strains of the same species, one may cause some kind of clinical effects, or one can show, but 99 may not. So is there any physiological or clinical determinant which can be found from those strains, and then specify that the strains, instead of going for 10, 12, 20 tests of toxicological tests, why not we determine the clinical factor there in that and then release it? If it is
So what you're saying is use a representative strain of, say, trichoderma, run all the trials with that trichoderma, and then kind of get blanket authority to use all trichodermas based on that representative strain?
Yes.
That's a tough question. If it's similar enough, sure. But you'd have to demonstrate, I guess, genetically that there's a tremendous amount of similarity. I mean, with bacteria, you get tremendous difference in the genomes of species within the same species with different isolates. I think you would have to verify genetic similarity.
But in India, government of India insists that every strain has to be tested for their toxicological parameters.
I know what you're saying.
Because our politicians, our farmers, they always demand why there is already a toxic a Trichoderma viridi or Trichoderma harzianum strain which is being used somewhere. I have another Trichoderma harzianum strain. Why I should go for testing? And politicians are also asking us, why don't you ease it to promote their spread? So can we ignore those clinical concerns, if any? I am not telling they will be having clinical concerns.
If I could, Dr. Roberts or Dr. Chakrabarti, I deeply involved in registration of several microbials here in the United States and the neighboring country, Canada. So as long as the applicant prove there won't be any strain-specific differences with genetically, then you don't need to do any clinical tests. So the USDA or the Canadian Harmonization, the Global Harmonization Act, dictating if you prove in the literature, your strain, somebody's strain, the other strain, genetic map, not much difference. Then, based on the claim, it is just for plant growth promotion, you don't need nothing else. If you claim for a pesticide or a biocontrol activity, if you can prove a similarity by genetic map, then you don't need to do anything. Either in EPA here in the US or Canada.
That, Mr. Then Codex Committee has recently developed a EWG on this, and India is one of the countries with the US as well as I think Libya and USA. We are engaged there to develop regulations for registration of guidelines of biopesticides or biocontrol agents which do not have MRL issues, because what they feel that in the nature biocontrol might be existing at the rate of 10 to 12, 10 to 3, 10 to 4, 10 to 5 in a place, in a given place. While when we practice it, we load 10 to 6 or more. Nobody measures at that time how much he is loading. So does that have any effect on classical? Because nobody has done such kind of studies. Any clinical concerns when you increase it to tenfold times, and then the plants are there and you see that this is a beneficial thing. So there's already an EWG which is set. This is because our Grape Research Institute in India, they have found a microbe which after the terminal application of a pesticide, if it is applied, so what happens is it degrades any pesticide residue if it is there on the surface. it as a degradative. But CIBRC or Central Insecticide Board, Government of India has said, is there a number of CFU there which can be consumed? Because we have not done any such kind of test. So what is the minimum number of CFU which should be there? Because we know we will be washing them and all those things. But even then, many of them, people might pluck it and eat it at that time in the farm. After the PHI is over, after pre-harvest interval is over. So these are the other issues which needs, I think, a lot of research and coming together between countries and coordination between countries.
On that particular issue, if the registrant, the company want to register their product based on MSDA sheet, how much you need to apply, how many CFU per ml need to apply. Based on that, on their MSDA sheet, then only you do say 10 to the power 5 or 6. The government, any government, requiring those doses versus the toxicity. It doesn't matter how much is there. What the guy is recommending, how to use it, how many cell CFUs per ml to be used.
But nobody sees in a country, vast country like India, you are just applying it. Nobody sees at that time MSDS that we should not go beyond 10 to 6. We think more is better. So that is the way which is, and then there is no paraphernalia by which we can test them. So
that's a different, yeah.
Anyway,
thank you. Yeah, nice discussion, Roberts. Thank you, my man. Yeah, excellent presentation.
Thank you. Nice being here.
Nice to see you.
It'd be nice if it was actually the morning here, but you know, it's.
You said he just woke up. You don't need to worry.
Yeah,
I have to go to bed.
I need to go back to bed too.
Okay.
Right.
All right.
Thank you, Robert.
You're welcome.
Thank you. So, sir, yes. Now we should invite the next speaker, Professor Mukhopadhyay, sir.
Mukhopadhyay, sir, voice is not coming, sir.
Professor Reddy is on the line. I think he is the next speaker. Waiting for long, I think.
Otherwise, sir, you can invite, sir.
Yeah.
Yes.
Now the next speaker will be Professor M.S. Reddy, who is good friend of ours. I will read his small CV. Professor Reddy is a professor in the Department of Entomology and Plant Pathology, Auburn University, USA. For 15 years, Dr. Reddy served as senior scientist and R&D global manager for several agrochemical industries, such as ExxonMobil, ISO Imperial Oil, before switching to academia in 1998. Over 40 years, he orchestrated multidisciplinary global research for biological control of soil-borne diseases, biofertilizer and biofungicide (PGPR), induced systemic resistance, and organic agriculture for safer, environment-friendly products. Poverty alleviation for rural farmers was the key objective of Professor Reddy. Professor Reddy contributed over 350 peer-reviewed research papers and several book chapters. He worked with National International Research and Development Organization, funded by multi-million-dollar grant. In 2009, Professor Reddy founded a non-profit Asian PGPR Society for Sustainable Agriculture, registered in India and the USA, to enable scientists, researchers, and others to share teaching, research, and commercialization. Dr. Reddy has trained several MSc and PhD graduates, postdoctorates, and visiting national and international scientists. He received many prestigious international awards for research and entrepreneurship, successful business person, investor, and entrepreneur of Auburn, Alabama, USA. He consults for educational, private sector, government bodies, and NGOs globally. With this, I invite Professor Reddy to start his talk. Professor Reddy, please.
Thanks to Baya, Dr. Singh Saab, Namaskar. Let me start with sharing my screen.
Sir. Great.
Yes, it's visible, sir.
Wonderful.
Visible?
Visible, sir.
Audio is good. So with
Wonderful.
with my starting, me as born and raised in our mother country, India, I have to start with my salutes with the man behind the plant pathology, the IPS Society, Dr. Balachandra Bhavani Shankar Mundkar. I love the name, so I have to say his full name. Yesterday we saw a video about him. I don't want to. And then, of course, the societies behind ICR DG, Dr. Mahapatra, and our friends, and of course the IRI director, A.K. Singh, my beloved friends, Dr. P.K. Chakravarti, current president, upcoming president, Dr. Pratibha Sharma ji, the current secretary, Robin Goyal, and the chairman of the technical committee for this IPS, Dr. Agarwal. And these are all just put some faces because most of them, I know them personally, met them several times, outside, inside, nationally, internationally, the presidents of the IPS. Without these, this is a recent one. I don't want to go back a long time. This is my acquaintance through IPS. So I just want to show. And this particular Dr. Chakrabarti is not only a past president, but is a current IPS journal chief editor. My friend Pandey and Thakur and Chaudappa, Anandaraj, Ketrapal, and Charis. So just want to show these people behind the IPS today, what we are doing it, why we are celebrating. Let's see. And my topic today, I think yesterday and just this now, Dr. Roberts touched on the smart agriculture and some integrated. Some people mentioned some biofertilizers. Mine is today just a synopsis of integrated nano-based microbiome. Yesterday, Dr. Verma mentioned microbiome. So I thought a long time ago this talk. So just let's see. And with that, with our national flags of our Indian national flags, by my bread and butter, I'm an American citizen, we salute our two flags today. On behalf of my Auburn University here on the right side, my founded non-profit scientific Asian PGPR Society, with all our blessings, and I would like to move on. Hacking somebody, I don't know. Okay. So yesterday, Dr. Keter-Paul also mentioned how to feed the growing population 20, 30 years from now, maybe 10 billion population around the globe. If you see today here, 1 billion people in 2020 is hunger. because they make less than $1.25 a day of their income. What to do? How to do? How to reach the growing population of 10 billion in near future? How we can feed? How we can end the poverty of hunger? So, with that in notion, I'm going to present a few hypothetical and realistic future approaches to feed the hunger in near future that are mentioned. What are the forecasted changes in the structure of agricultural production in the future? Right now we are sitting here, a basket full of beautiful veggies and food and stuff. By 2020, just last year, the state of agriculture commodity markets, depending on the markets and the sustainable development and their global value chain, smallholder farmers and digital innovations. The title yesterday also, Dr. Anupavarman and everybody talking about, hey, forget all this sustainability, talk about microbiome. But I gave this title to the IPS guys long time ago. So not yesterday stuff. The exploiting plant microbiomes. You see here, this is so-called crop plant. The microbiome application and its challenges, its approaches, and its insights. The application right now, conventional breeding. Like to see a new plant breeding strategies, improved crop field and quality. Challenges, maybe a temporal and spatial dynamics of microbial communities, multi-tropic interaction in the plant microbiome, environment influence on plants and microorganisms. Approaches, integration. Yesterday, Anupa Verma mentioned omics, multi-omics, in situ detection of metabolites, network analysis, Robert just mentioned, microbial cultures, wild and domesticated microbiomes, plant soil feedbacks, host-mediated microbiome in agricultural practices. Microbiome or plant microbiome is nothing but the holistic approach of bulk soil below the ground, above the ground. If you see the below ground, bulk soil, the rhizosphere, above the ground, root endosphere, leaf endosphere, and the phyllosphere. And on the right side, the fungal culture, fungi, on the left side, bacteria. There's so many bacteria in the microbiome, and so many fungi, majority ascomycete, basidiomycete, and others, and several of microbial. This is the so-called holistic approach of plant microbiome. If you put into perspective, just coming into my specialization, PGPR, plant growth bacteria, I'm not using right now here, I call it beneficial bacteria or beneficial fungi. This beneficial bacteria, beneficial fungi, if you introduce in the soil root ecosystem, they may be a nitrogen fixing bacteria, induced defensing bacteria, drought reducing bacteria, and combating herbivores and snap-sucking insects such as PGPR, beneficial fungi. And if you put all those things, the whole solace in the root, soil, the rhizosphere ecosystem, everybody talks about microbial interactions, It may be a commercial, it may be beneficial, it may be fungi, it may be VGPR. All these things supposed to work through various indirect and direct mode of action, protecting the soil root ecosystem, to fight off against various fungi, various bacteria, various philosphere attacking pathogens, and also abiotic and biotic stresses. Thus, all the secrets behind plant microbiome. So, can you guys advance this? I'm using multi-screens, I think the cursor. If I put together, earlier you mentioned second green revolution. We started the first, the green revolution. This era, you all know the green revolution benefits, enormous increase in food grain, otherwise we would have been hungry without that. But it has its own merits, it has also own demerits, the green revolution. It may not be environmental friendly, but it needs a solution for tackling concerned issues. We have a lot of issues. Now we are in this era right now, biofertilizers, biopesticide, bioherbicide, bioinsecticide, biostimulants, and the newest era is the nanotechnology based biostimulants, biofertilizers, biopesticide, bionematicide, bioinsecticide. So I put together 3 eras in a short time. Green to bios and then nanos. My title is All Integration to Improve and the Advanced Agriculture in the Future. So we need to adapt more realistic approaches in the near future, and we need in-depth study on environmental impact of biosynthesized nanoparticles, preparing a legislative framework and regulatory guidelines for safe and use of nanoparticles. Having said the 3 eras, green revolution, biofertilizer, biofungicide era, now we are coming into nanotechnology era. It may not be a second green revolution, some new. Now I will call some other day as I'll come back a term for the revolution for that. The nanotechnology in agriculture, in sustainable agriculture today or in the near future. So we need to follow several steps. In the nano for crop production, we need a nanopesticides. In the nanotechnology for precision farming, we need a nanosensors. In the nanotechnology advancing in agriculture, we need to combat the biotic and abiotic stress tolerances. And this technology, we need to enhance soil enhancement using nanomaterials and the nano fertilizer for crop growth, for crop improvement. Having all this, again, we need to use a nanobiotechnology, genetic materials, the nucleus, the cell, and the nucleus, and all kind of gimmicks, and produce a transgenic plant with the different and newest traits to combat all kind of abiotic and biotic and stresses on a given individual crop in a given era or given area. So ultimately, generally in a degraded soil, we want to make that degraded soil to be healthy soil. On that healthy soil, we put a good seed to germinate. If it germinates, that I mentioned earlier, the biome, plant microbiomes use that to enhance the crop yield like this, and with the nanos and if government permits, use the transgenic genes to produce the best ever ultra modern crop. I hope so. I just give an example. What is a nano? Nano is nothing but very minute small particles we can use as a protectants, we can use as a carriers for plant protection, such as fighting against pathogenic bacteria, fungi, viruses, and insects. So this guy or this ultimate crop, whatever it may be, to be healthy, so to get benefits to the humankind, all these nanos to be self-life has to be safeguarded. There may be site-specific obstacle, their solubility. We know the benefits. We still do not know much about nanos, soil leaching and toxicity and their registration restriction to get into market. So, if at all the nanos integrated or approach coming with technologies, suppose you see a thing. This is the so-called healthy, lovely plant, maybe indoor, outdoor. I'll come back in a minute, other cropping systems. Nano fertilizers. We need to be improved application, stable suspension, surface area coverage, more precise target, high efficiency. I believe in with the nano-based technologies. If so, then increase the nano bio interaction between soil, root ecosystem, more uptake, and to be controlled release what it needed at a target space, and increase surface area to volume ratio, improved physico-chemical properties. If so, would like to reduce the stresses, decrease the losses, improve in the quality of the ecosystem environment. That's the main ultimate goal, to reduce the atmospheric pollution. If so, still there is a question mark. Not yet proved with its nanos. But on the right side, farmers, not farmers, the industry, forecasters, and financial investors, he said, will make a lot of money out of this technology because reduce the waste, recycle, and reuse the waste into compost, and that compost particle become nanos for the plant microbiomes. And it has to be accepted by the public. If so, my topic is nano-based integrated smart agriculture. So I'm bringing into smart farming, smart agriculture. So this is a so-called our evergreen plant, germinated. Looks like 2-leaf stage, very good, healthy. So Robert mentioned smart farming. He said he can dictate the African, dictate the farmers in India, everywhere, sitting in his office. Of course, we're testing. I'm consulting a big international companies. In this smart agriculture, smart farming, nothing but sensing technologies, software applications, communication systems, cellular, telematics, positioning technology, hardware and software, data analytics solutions. It is a cumbersome. You think maybe a lot of money needed? I don't think so. I come out working with the consulting WHO, FAO, Asian Bank, a big multi-billion dollars companies for the last 5 years. I gave them my own 4 things. Data for egg. Just like what do you call 1G, 2G, 3G, 4G, 5G. This is last year. I may call D5 egg, data 5 egg. This is innovation, digital solution, digital technologies, robots, blockchain, artificial intelligence, solution, production, market, finance, supply chain, intelligence. Then enable that big data and analytics means quality content, drones, satellites, sensors, digital identities means we need a business plan. Who is the small or individual, big guys or institutions that facilitate business development services? Who is going to pay for it? As a farmer, thinking there is a business venture, a capitalist, a industry, of course, not institution, not ICR, not UGC, not something, who is paying for it? So, a networking people, smallholder farmers, commercial farmers, co-ops and federation, input suppliers, donors, buyers and processors, financial industry banks, NGOs, of course, governments, ICR, Indian government. So the fourth, promote enabling environment. Digital, non-digital. So far, we've been following our fathers, grandparents, and 4 grandparents, all non-digital technologies. Today, we are digitalized, according to Prime Minister Modi ji. Digital India, produce everything within India. So digital, of course, but e-policy, electronic policies, mobile internet, of course, Reliance and all big guys, big stuff going on within India. 5G is excellent within India. These are my 4 slogans to move on. Then also I gave my 10, at least here, 5 mandates. My future agricultural mandates, at least for me and my followers. Number one, bees and drones, honeybees, bumblebees in each and every form. You grow the bumblebees and honeybees, you use whatever technology on that farm, the bees will pollinate, bees will carry my nanotechnology based on microbials and the dust on the crops and pollinate them and give them spreading all over the crop. Of course, the drones will monitor the canopy through GPS and IPS and all kind of photo imagination. Then artificial intelligence, just Robert mentioned, sitting in his office. Right now, I'm sitting in my office, in my home, in my hometown, consulting WHO, FAO, Asian Bank. We have been developing with, it is a big project, a lot of money involved. And I can visualize the form, artificial intelligence, automation through the Internet of Things, IoT. IoT is everywhere. IoT is everywhere. Then blockchain technology disrupt the local road morphing. Guys bringing the trucks and delivering and throwing out everywhere. Hey, we need to, oh, sorry. What happened? Yeah. So we need to disrupt this regular road transportation, all kind of stuff, use the blockchain technology. That's another one. My recent, I love the urban agriculture vertical farming. I see it in India, Hyderabad and Delhi and Benares Hindu University, SP Singh's place and UP and Delhi, everywhere, everybody from young girl to housewife or mother to grandmother to everybody growing their crops on the rooftops if they have space. Same thing here in the United States, in California, New York, Washington, everywhere the vertical farming is growing and more. I am promoting it, easy to do it, implement the technologies, automation, artificial, nano-based, integrated, stuff like that. And of course, the new graduates, young guys, young scientists, of course, IPS scientists and graduates and postdoc. Yesterday, somebody gave how to revise the educational system in plant pathology. We always keep giving lectures. Who is going to implement? Who is going to listen? The ICR DG is going to implement it. I don't know. It's up to you guys, up to our Indian government. But I still believing in genetic editing. Cut and paste the stuff you needed. We cut and paste everything everywhere on the internet. Copy and paste, copy and paste. All the publications these days, everywhere in the world, cut and paste from the Google. Just cut and paste the gene and use it whatever you need it. And paste it when you need it. So with that, in a cycle, and adoption of modern agriculture, mechanization post of World War I, the Green Revolution, we all know the guy just meant Roberts' second Green Revolution. So what is the next Green Revolution? Dr. H.P. Singh and Dr. Chakrabarti, all these famous faces I showed from IPS, we need to sit down and come out a term for this 21st century will come back. And the digital revolution I just mentioned. In a nutshell put together, agricultural sustainable system, every plant need energy, of course, healthy soil, water, irrigation, plus nutrients, of course, abiotic factors. And so we can take out the image and submit to the cloud services through IoT or artificial intelligence. And that, of course, we need to have a good internet. Of course, in India, as a 5G is a beautiful internet. And then I said Internet of Things for monitoring and water management, machines operations, all those things to put together data collection, application, interpretation of all the crop condition map, soil condition map, yield map, this map, that map, father map, mother map, worker map, finance map, consumer map, who is eating, how much he eats. We need to generate all those maps together. Our crop, platform, the data, the decision, the actuation means implementation with autonomous robots. In the United States, very soon, all the mail delivery, postal guys will be delivered through robots. All the foods ordered through restaurants will be delivered to the homes by the robots pretty soon. The technology is worked out, not yet implemented. Hang on a second. So I just heard yesterday, the precision agriculture, data-driven agriculture, smart agriculture, the idea technology business incubator of NOM through Indian Hindu newspaper, Nidhi Prayas grant, just announced 10 lakh rupees. I'm just showing. I think India realized the Nidhi Prayas grant, probably announced by Morarji Desai, the Honorable Prime Minister. So just keep that. Anybody interested to apply for the grant? So with my slogan, I'm looking for this. in near future. All my thought today and for the last 40 years, future probably, how long my health permits. And I have a global family, Asian PGPR, through Asian PGPR Society. This is my extended family, friends, mentors, and gurus, and professors, and Nobel laureates, and all. We have been doing 40 years. For the last 12 years, we conducted from Hyderabad to China, to Philippines, to Vietnam, to Indonesia, 2 years ago in Uzbekistan. The next supposed to happen this year. Unfortunately, this COVID Mahima or mantra, whatever, were postponed to next year in Malaysia, Kuala Lumpur, Malaysia in August. Please, all these families, 50%, 60%, my mother Indian friends, majority of them, all of them. Look, with that, and also I have in between some local, we have several chapters of Asian PGPR Society. Every country I visit, I have a chapter in that country. The Bali, Indonesia chapter organizing their own national conference. Of course, India chapter organizing the Asian PGPR chapter in Bhopal, Madhya Pradesh. All those are two are virtual. This may be live so far because next year. With these inputs, with this doing around last week, the International Bioegg linkages organized one of the best ever second International Sustainable Congress of all several CEOs all over the globe. They awarded me a Life Achievement Award for sustainable agricultural services, and so just showing that it's not.
Professor Reddy tried to.
Yes, done, sir, done.
Yes.
Hey, this is the last slide, Dr. Singh Saab.
Thank you, sir.
Just came across this morning.
Yeah.
Professor Aparao and colleagues collected, isolated a bacteria from the Space Research Lab, identified a methylobacterium species, have a lot of gene characters, enhance what we talked about, the microbiome, PGPR, biofertilizer characters, when if at all grow all the crops in the space.
Oh, great.
So I'm really proud. This came in a frontier research, published all over national paper, picked up, I think, half an hour ago. You all know Professor Aparao, the Vice Chancellor of University of Hyderabad, Central University of Hyderabad, want to show that technology. And the ICRISAT saying, promoting sustainable cereal grain, small cereal grains to be a beautiful food for all of us. The vision, time for a shared vision. WCSD means World Business Council for Sustainable Development. They're saying Vision 2050 offers a framework for action in the decade ahead, is a practical, grounded in reality, and designed to help companies drive change in their sustainability planning and business strategies. I appeal all the participants, the administrators, organizers, IPS, take this vision, visit this website, WBCST. With that, God bless IPS, God bless all the participants, God bless the Asian PGPR Society, God bless India, God bless our mother India, God bless the United States. That is my country right now for my bread and butter. Thank you. Namaskar.
Thank you, Professor Reddy. Thank you for excellent lecture. Yes, Mukhopadhyay, sir. Any question or comment on Professor Reddy's presentation? Dr. Chakravarti, yes, sir.
Govardhan sir, please unmute.
Singh. Dr. Niranjan.
Unmute, sir. Unmute, sir.
I unmuted. Dr. Singh.
Yes, sir.
Thank you. Thank you, Dr. Good morning, all of you. Good afternoon, almost. Dr. Reddy, it was a very elegant talk. I thoroughly enjoyed, and it was such a passionate. I have attended many of your talks, and um, I just remain spellbound. How much you are doing alone, what I feel with your company or maybe with your group. So it's an enormous amount, and it's a eye opener to all of us. One thing I just would ask is that you have, because many of the microbes which we are using as PGPR now, as per Government of India, on 23rd September, I think I too forwarded that mail or gazette notification to you. 23rd September
Vice Chairman.
of this year only, 2021. Sorry, not September, February, 23rd February. Uh, they have brought all these PGPRs mostly under biostimulants. In fact, we were forced to do that, not forced to do that because it was felt by Parliament, and then the Planning Commission, which is headed by the Prime Minister. He is advised our DG, and DG in turn made me chair for the Committee for Development of Guidelines, and we tried to simplify it because some of the states, they raised their concerns because biostimulant market is growing at the rate of 14% in the globally, more faster than the chemical and even biopesticides or microbial agents or biocontrol agents. So biostimulants are separated, but then they are kept under fertilizer control order. But in that, certain toxicological, this is the second part of fertilizer under fertilizer control order. Am I audible, Dr. Reddy?
Yes, sir.
We, because of the concerns and because the large amount of spurious and fictitious things were going on, as Rajasthan alone reported, joint director from there, he came, all the states represented, and they reported that there's a huge amount of such kind of things, of stimulants which are laced with the pesticides, as well as with some fly-by-night operators, you can say, or maybe it's not normally happening in the country, but then some examples are always found, but they raised concerns about in crores of rupees, such kind of things are going on. So we had to put certain conditions for regulation, like 5-pack studies which the Government of India proposed. Now 5-pack studies means acute and oral toxicity, acute dermal toxicity, acute inhalation toxicity, primary screen, and eye irritation. These are the 5 pack studies, as well as toxicity, ecotoxicity. These 6, whereas in case of chemical pesticide, we are asked for 21 such kind of studies. So these things are, so in doing that, in India, at least we cannot take PGPR without any registration or without any such kind of, which we used to do and which we are used to do, or the farmers are used to do. So what is the status in the United States, and what do you comment about these studies, whether it is required in the United States as well for biostimulants?
Dr. Chakrabarti, and you know that biostimulants still is not defined specifically either in the United States and Europe, even within India too. So every country is trying to define what is a biostimulant. So with still every country, every continent has their own definition of biostimulant. But in the United States, I think recently, last week or 2 weeks ago, the Congress and Senate people put forward their recommendation. The Biden government hey, biostimulant is nothing but one of the fantastic green product. Don't to be worried. So now the new administration reviewing the process, and I think in my opinion that will be legislated very soon, because Biden has a majority in the both houses here in the United States. And of course, India, you just said gadget some new info. And we as the Asian PGPR Society had a meeting 3-4 months ago, virtual conference for several across the Asian countries. I have finalized the green document. I'm ready to dispatch to all the participants, including to you and the government of India and other European nations, the United States. So looking for their comments. So ours is a sophisticated, combined efforts of many continents, many nations across. We have synthesized a 2-page, 3-page reports with the guidelines. So I will be sending you directly on a person-to-person basis, not in a group or any Telegraph or WhatsApp or Facebooks for time being. I think you were right, sir, Dr. Chakrabarti. You did a wonderful work for under ICR when you were ADG. So you have done, and the Commissioner of Agriculture, our friend, you all put together wonderful services for India. And the new gadget, I think there is some modification coming into that gadget with the majority of the parliament, hopefully in near future. With our recommendation on behalf of Asian PGPR Society, reimpose your recommendation and the Chairman of Agriculture Commission of India and fellow our friends across the globe, particularly from Asian countries, and including Dr. Singh Saab and all of our friends. That's why I put together, you have not seen my first slide, our nearest IPS family, the close and neatest family I come across in each and every day. It's a wonderful participating the IPS, Indian Phytopathological Society. I call India Written Pathological Society celebration for me. Coming back to the country, celebrating friends and families of phytos with the senior most legend of Balachandra Bhavani Shankara Munkar's legacy, with all our past and current presidents. Sir, you're doing wonderful. Your current president and our great friend Pratibha Sharma-ji coming over, president-elect, and our council and the young Gogoi, the secretary, has to modify his daily communication, fellow scientists across the globe. So my caution to him, no complaints, but I do have some, but anyways, he is still young. And my Niranjana friend and all my friends from India, if any question, I say goodbye.
Thank you.
All of
Thank
you is
you.
wonderful.
Professor Reddy.
Seeing my friend Pandey, Dr. Thakur, and Dr. Gupta ji, and Sharma ji. All of you. Namaskar.
I have a small question before concluding.
Yes, Mukhopadhyay. Sir, you're a man of wisdom. You're a man of everything. You travel entire nation, enter the world. Your question is my wisdom.
Mukhopadhyay sir, you are not audible, sir.
Voice is not coming, sir.
Mukhopadhyay sir, you are not audible, sir.
No, Niranjana sir is asking a question.
I am asking.
Niranjana.
It's not a question. It's not a question. It is just an opinion of Professor Reddy after listening his lecture, wonderful lecture he has given. Because all
Mysore Maharaja. Mysore Maharaja.
Yes.
Mysore Maharaja, because of Corona,
Gulbarga.
Same. Mysore is the highest now. The second peak, Mysore is highest in the state. So after listening your
Yes, please.
lecture, Reddy sir, I am happy to see you on the screen. and still you are maintaining the same the personality, same health and same face. I'm happy to see you. But my question, my clarification with you is the people are now diversifying from first is the biological control, second is the PGPR, now is the nanotechnology. And you are made it one statement that nanotechnology is not having a much future. Whether we can believe nanotechnology or we can stick on to the conventional PGPR study.
I did not say that. Future is a nano. Future is a nanotechnology with a caution. With a caution.
With a caution. Okay, okay.
Yeah.
But we can afford the technology of nano.
Oh, yeah, of course. I am a 3D guy, or maybe a 4D guy, or 5D guy. I just mentioned 5G.
Yes,
so,
sir.
Nano in the sense, the PGPR with the nanos, nano carrier, nano formulation, nanoparticle combining with the micro or macro nutrients of Dr. Pandya's trichoderma or Dr. S.P. Singh 350 100 patents. So I want to combine all of those things together.
Dr. Singh, I have a comment. I'm allowed, please.
Sir.
Yes, sir.
No, thank you very much. No, Dr. Reddy, I was listening very carefully. Your wonderful talk on nanotechnology. Dr. Chakrabarti has also given his comment very nicely. He has informed that in India we have already registration procedure for biostimulus and bio preparations. My major sort of comment is that we have to devise certain technologies which are more applicable directly in the field. Under Indian farming conditions, we have more than 85% farmers which are marginal farmers and small farmers. They don't have access to many good technology. Of course, this biostimulus, they have been registered very nicely, of course, 23rd February, that's very fine. But how do they go to field? What are the conditions? Under what the conditions these have to be applicable in the field condition that we have to look. Any technology we develop that must be transferred to the field conditions. We are aware that a lot of technologies which have been developed in plant pathology, they have not seen the light of the day under field conditions. So we have to look into these conditions very precisely, that these technologies which we are developing, of course, these are very, very useful in advanced stages. And how do they reach to farmers? And small farmers, of course, they don't have access to these small sort of even computer and computer technologies. And our extension system, government extension system, it is also many things are wanting in these conditions. So my comment is only this, that we must look into this aspect, that how the technology we are developing. There is still large gap between this technology developed under laboratory conditions and technology gone to field conditions. Yesterday also we were discussing this Chattopadhyay, he was given this new education policy alignment. All these things what we develop in laboratory, how to align it with the system which is prevailing in the country or in the location, that is more important to keep in mind. Thank you very much.
I appreciate Dr. Chahal, I appreciate your open and candid question. This question, you need to put forward the current president-elect, president of IPS, the president-elect coming, Mamataji, Sharmaji, and fellow IPS body through PK Chakrabarti and other people. Sir, in my understanding, I'm away from India almost 40 years now, but I do follow the technology available within India, whether in New Delhi or in Punjab. The guys growing mushrooms in Punjab, beautiful mushroom, supplying everywhere within India. And the Bangalore people supplying are all ornamental horticultural crops around the country, globe. And the capsule technology, trichoderma technology, microbial technology. Sir, I think they do available within India. I don't know how to reach. What can I say? The NGOs and the the ICR or DBT and some people IPS. I don't know. That's the internal matter of India.
Thank you, Professor Reddy. A lot of speakers are there. I think time constraints. Thank you so
Yes,
much.
sir. Thank you.
Thank you so much. I think we should now move to the next invited speaker, Professor Ranjit Bandyopadhyay.
Thank you very much.
Thank you, Professor Reddy.
I say goodbye to all of you. Thank you. Professor Chakrabarti, please keep in touch. Sharmaji, Pratibha Sharmaji, we'll see you in Kuala Lumpur. Thank you all.
I would like to draw kind attention of the chairs that we have another keynote speaker left. Then we have 4 invited speakers and 5 more session, and we have to finish by 2:30.
So I think we have to reduce time now.
Sir, that is up to you, sir.
Yeah, that is why I'm telling you.
Time, sir.
Yeah, we will now. So Professor Bandyopadhyay, I will just introduce Professor Bandyopadhyay, who did his BSc in 1974, MSc in 1976 from G.V. Pant University of Agriculture and Technology, and PhD from Haryana Agricultural University, Hisar in 1980, working from ICRISAT India and IIT Nigeria. Bandyopadhyay has made invaluable contribution to manage seemingly interactive crop diseases in Africa and in US. He co-founded and leads the Africa-wide initiative to scale up an aflatoxin biocontrol technology to limit crop aflatoxin content. His team registered 14 biocontrol products in 10 African countries. New product development is underway in another 10 countries. Commercial partner manufacture and distribute AlphaSafe in 9 countries where farmers have used them in nearly 1 million acres. His efforts have left a legacy of human capacity development and laboratory infrastructure for plant pathology across Africa. He has received American Phytopathological Society International Service Award, Outstanding Scientist Award of IITA and ICRISAT, and Agents of Change for Aflatoxin Mitigation Award from African Union. With this brief introduction, I request Dr. Bandyopadhyay to start his lecture. Dr. Bandyopadhyay, over to you.
Thank you, Dr. Singh. Am I audible?
You are audible.
Yes. Right, thank you. Let me try to share my screen and see if it works out. Is my screen visible?
It's coming, sir. It's coming. Now come to slide mode, sir.
Right. I think it's on slide mode now. Before I start, I would like to thank the organizers for inviting me to deliver this keynote address. I'm particularly happy to see my first major professor for MSc, Dr. Mukhopadhyay, with whom I did my MSc at Pantnagar. I passed out in 1976. What I will try to do is to compress my presentation in my work of 18 years of our team from discovery to delivery of aflatoxin biocontrol in Africa. And I would like to emphasize what Dr. Chahal said just now and what Ravi Khatripal said yesterday. Finding effective biocontrol agents is the first step of our work, but it's an important step. But it remains incomplete unless it is scaled up and made available to farmers. And they are the ultimate users of the product. And what I'm going to describe is the process that we followed from research to commercialization pathway. You can get more information about the work of our team at aflasafe.com. Now, if you look at the issue of aflatoxin, it's a toxic chemical produced by Aspergillus species, and it's known to cause liver cancer. It's associated with stunting, immune suppression, and in extreme cases, it does cause death. It's known to curtail productivity of animals, and because of its toxicity, It is regulated at parts per billion level. Aflatoxin is known to cause about 30% of all liver cancer cases in Africa. About 40% of the commodities in the African markets exceed the allowable level of aflatoxin, and nearly $100 million worth of export are potentially lost every year. And as a result, you can see that aflatoxin impacts on public health, on trade and economy, and on food and nutrition security. As a result of all this, there's a lot of media attention that actually aflatoxin gets in Africa. When people die or when agro-processors find it difficult to procure good quality maize or groundnut, or when the regulators blacklist company and there's a reputational loss of these companies. And more recently, Kenya banned import of maize from Uganda and Tanzania because of aflatoxin contamination. There are many, many ways of managing aflatoxin, right from planting to harvest to post-harvest and until consumption. And all of this is actually based on awareness, group institutions, and policy support. Among the various practices, what I'm going to talk about is just biocontrol. And biocontrol is a simple intervention that can effectively reduce aflatoxin contamination right from the farm until it is consumed. Okay. Now, it actually works. In the US, hundreds and thousands of acres of crops are treated by 2 Environmental Protection Agency approved products: maize, groundnut, cotton, pistachio, almond, and figs. They are actually treated to a large extent. In Africa, over the last couple of years, we have been able to promote the technology to the extent that it's actually now more than 350,000 hectares of land is treated by 250,000 farmers, and more than 700,000 tons of aflatoxin-safe maize and groundnut are being produced. The biocontrol development in Africa that we have practiced is a partnership between IITA, USDA, ARS, and many public and private sector organizations. Now, what is the technology? Now, if you look at aspergillus, they are actually associated with the crop in the soil, in the leaves, everywhere it is actually present. And the amount of the propagules of aflatoxin can range from 1 to more than 1 million actually. And depending on the extent of the propagules, and the composition, I'll come to the composition later on. Depending on the composition and the extent of the propagules, the amount of aflatoxin can range anywhere between the safe level from 0 to 20, and 20 is the codex level, to anywhere between 48,000 ppb, and in 48,000 ppb, it can actually kill a cow. Now, if you look at Aspergillus fungi itself, within Aspergillus species, you have two communities basically. You have some toxin-producing ones, and you have non-toxin producing ones. And the non-toxin producing ones, they have genetic defects, natural defects, because of which they can't produce toxins. The extent of the community composition of toxigenic and non-toxigenic strains that determine the extent of aflatoxin contamination. And these non-toxin producing strains, what we call as atoxigenic strains, they actually exist in all regions of the world and can be used as biocontrol agents. Now, we actually develop biocontrol agents specifically for each country. So from each country, we actually collect about 5,000 strains, and then we characterize them so that we select only those strains that do not produce aflatoxin in culture. And then we characterize them using VCGs, vegetative compatibility groups, or with SSRs. So these are the genetic groups, and we are looking for those genetic groups that have wide geographic distribution, and they have no toxigenic members. And we select, and then what we also do is, of these genetic groups, we sequence the aflatoxin biosynthetic pathway to find out those VCGs or those genetic groups that do not have, that have defects in more than 2 aflatoxin or CPA, cyclopyrazinic acid genes, and also in culture that outcompete toxigenic strains. And based on that, we select 8 to 12 native strains. These are natural strains that are found in nature. Now, until all this time, the work, the selection of strains have been done in the lab, but the actual biocontrol takes place in the field. So we take these 8 to 12 strains and then apply them in the field, and then look for those genetic groups that have got superior capacity to colonize, multiply, and survive in soil. They have superior frequency of isolation from the grains and superior capacity to reduce aflatoxin. And based on that, we select 4 native strains to formulate the final product, which looks like this. So each of our product is a multi-strain product. Okay. So what we do is we take these strains, grow them on media, and then make a spore suspension. And these spore suspensions are inoculated on roasted or sterilized sorghum grain in these bottles. And these bottles are incubated for about 7 days at 31 degrees C. And after that, we get about 12 to 14 billion spores in these grains, and then make a spore suspension. And so this is our active ingredient, and the spore suspension is then combined with a polymer, which is a sticker and a dye that actually gives the color to the spore suspension. And those are then mixed with heat-killed carrier sorghum grains. So these are our carriers actually. And these two are mixed in a seed treater. And then subsequently, after mixing them, they are packed. And this is what the product actually looks like. It's blue in color. It's killed sorghum grain, and it doesn't look like sorghum. It looks like a blue granular product. So that's what the product is that the farmer uses. So what the farmer does is to actually take it in their hand and apply that in the field at 10 kg per hectare, 2 to 3 weeks before flowering, and only one application is required, and it costs in between $15 to $20 per hectare. Once the product is applied on the soil in moist conditions, the spores, the active ingredients that are sitting on the grains, they actually begin to multiply and then spread out in the field. So basically, the application of the biocontrol agents are happening twice. Once man-made by hand application. The second time is when these inoculum begins to multiply on the carrier, the sorghum grain, and basically the fungus owns the grain, and it grows on it, and nothing else can grow on it actually, so it can multiply. So once that happens, now let's look at what actually happens in a non-treated field. In a non-treated field, you have a large number of propagules of the toxin-producing strains, which are the red circles. But there are some green, there are some non-toxin-producing strains too, which are the green ones. So this is what happens in the non-treated field. You've got a preponderance of the toxin-producing strains, and as a result, you get toxin production. In the treated field, these the toxin-producing strains are displaced by the non-toxin-producing strains of the active ingredient. And since the composition of Aspergillus is now predominantly with non-toxin-producing strains, what infects the crop is also non-toxin-producing strains, and as a result, you get less aflatoxin contamination. Now, once we have a product, we then carry out the efficacy trials. Like in this case, I'm giving an example of Ghana, where we carry out these trials in farmers' field. These are not done in experiment station. These are farmers' field on which the effectiveness trials are done in real life conditions. And this is now the efficacy data, in this case, Nigeria, in this case, Ghana, in various regions in both treated and control. And you can see there is a large reduction in aflatoxin contamination in the treated field compared to the control field. Now, and it's anywhere between 96% and 100% actually. Now, if you look at the basis of control, it's basically a strain shift. So we actually track the strains in the field. So what we have done is that for each of these trials, we look for the active ingredient in soil before treatment, soil at harvest, and grain at harvest. And the red bars are the controls, and the green bars are treated. So in the soil before treatment, we do see the biocontrol agent, and that's because these are native strains. But after treatment, in the controls, you don't get much of an increase of the non-toxin producing strains, but there's a large increase in the amount of the non-toxin producing strains in the treated field, both in the soil and from the soil. Since the inoculum moves from the soil to the grain, you can see the same thing in the grain also, you know, and the same kind of results in both years. So the basis of the biocontrol is actually a shift of the strain composition from an unsafe to a safe community. Now, this is another example in Kenya where people have died because of aflatoxin contamination. Now, these are the number of portion of samples, and this is aflatoxin in ppb and different aflatoxin categories. So up to 10 parts per billion is something that the Kenyan standard, Kenyan authorities allow. 4 parts per billion is the European standard. So all the treated fields had actually met both the European standard and the Kenyan standard. But about 50% of the field did not meet the standard, so they were unsafe. And about 25% of these of the fields, they had more than 100 parts per billion, which is highly toxic to people who are consuming it. So basically, with biocontrol, you can make the crops safe. Okay. Now, using the efficacy data and also doing some of the tox and ecotox studies, we register the product. In this case, this is a certificate from Ghana, the Environmental Protection Agency for Ghana. That's one of the labels of the products. And then the registration is often we get WHO class 4 or U, which is the highest level of safety. Okay, and so once we register the product, then we go into the commercialization stage. Now, if you look at the status of aflatoxin biocontrol product in the world, there are 17 products that are registered, 2 in the US and 1 in Italy. And there are 14 products that are registered in Africa in 10 countries. In all, there are I think 59 active ingredients registered, out of which 56 are registered in Africa itself. Now, so we have a product, but that's not the end game. The end is when farmers actually use it. So in order to promote the product, we followed 2 processes. One was to incentivize the use of the product by testing the market and by promoting product. And we were fortunate to get support from the Canadian government, Australian government, the Bill and Melinda Gates Foundation, the British government, USAID, and the World Bank. And through the incentivization scheme, we demonstrated that there is a market for the product and the farmers are willing to use it. Once that information was available, USAID and the Bill and Melinda Gates Foundation funded a project called AfterSafe Technology Transfer and Commercialization Project, through which we transferred the technology to the private sector for sustainability. Now, let's look at the process that we followed. I have talked about from step 1 to 4 up to the registration process. Subsequently, we have a business team that actually did the aflatoxin, the market analysis for the product. It elaborated the commercialization options. Basically, it said, what is the market size like? Which sectors are going to use it? How much are willing to pay for it? What kind of processes we need to actually put in place for distribution and other systems. Now, after that, we actually mobilize the private sector by conducting investors forum. And then we select manufacturers and distributors, and at the same time, raise awareness. With the manufacturers and distributors, the potential manufacturers and distributors, we actually test the market and we conduct large-scale demonstration in real-life setting with the value chain actors and raise awareness. Subsequently, the investors, they would actually invest money to set up manufacturing plant and distribution system, and we help them and technically backstop them for some time so that they can actually carry it forward. Now, this is in summary where we are right now. There are work in progress in 20 countries. We have about 14 AflaSafe products that are commercially available in 10 countries. The private sector has invested more than $5 million to set up manufacturing and distribution units. There are 4 factories in Africa right now that are manufacturing and distributing AflaSafe. There's one in Nigeria, one in Kenya, one in Senegal, and the 4th one is in Tanzania. And there are factories being set up in Mozambique, DR Congo, Burundi, and very soon in Sudan as well. Right now, there are 8 companies that are manufacturing and distributing AflaSafe in 9 countries through 92 distribution points, and almost 3,600 tons of the product have been produced. And with this product, the farmers have been able to produce more than 700,000 tons of aflatoxin-safe maize and groundnut. Now, in terms of some impacts, what we have seen is that the annual net income of some farmers have actually increased by about $318, or about 16% per smallholder farmer. About 20 grams per day of safe food has been increased in the farm families. We have seen a revival, the beginning of a revival of groundnut export in Gambia and Nigeria. In one of the food security projects, the Kenyan government was able to feed 500,000 Kenyans for 1 month in a drought-prone area. And this technology has been incorporated into the National Agricultural Investment Plan of 6 countries. And as I mentioned earlier, there has been a private sector investment. Now, this is a company, this is a factory being built now in Nigeria, where the investor has this. This is a $4 million facility that is coming up, and this has resulted in a large number of job creation. So even though the availability of the products is expanded significantly, but uptake is still limited. We are not there as yet, and it's going to take a long time to get there, you know. And it's still limited to aflatoxin-conscious core market segments dominated by large processors, exporters, and government procurement. And remember, all these markets are being supplied by smallholder farmers. So the ultimate beneficiaries are smallholder farmers. Okay. Now, some of the key implementation messages. So we do not actually promote biocontrol as a standalone technology. It's a key component of an aflatoxin management system in which you need to have good drying, good storage, you need awareness, policy, advocacy, and everything put together, financing. Creating awareness is actually important, not only about aflatoxin, but also about its management. We need to increase the number of testing facilities available, because aflatoxin cannot be seen and therefore it needs to be tested. So chemical testing facilities should be made available in various parts of various countries. We need to actually look at the aflatoxin conscious market, where you can start up the initial marketing of the product. And the public sector support, such as input supply scheme, is also a crucial thing to actually to promote the product and make it available and use it. And therefore, partnership with government and policy institutions for standards and food safety are really important. And of course, the partnership with the industry trade bodies, you can't actually avoid it. Okay. Now, there are key scaling and commercialization learnings that I want to talk about, and I'm almost there. So one of the first lessons that we learned was the public sector innovation, like we are a public sector organization, must be championed by the public sector initially, and with support from development investors like government or other donors, for uptake by the private sector. It cannot be done singly by the public sector alone. There are several scaling up challenges. Low awareness is one of them, inadequate market incentives, and poorly enforced policies. So those need to improve as well. The technology development and commercialization of AflaSafe required intervention by a team in a phased manner. I'll show you a slide in which we are a team of not just plant pathologists, but business development specialists, engineers, policy people, communication specialists. So there's a team that actually helps to promote the technology. And we need a well-planned commercialization strategy and careful investor selection and licensing agreements are crucial for scaling up. Another thing is that there is no quick fix here. So technology developers require a few years to champion and steward the technology after licensing to the private sector, and licensees, they require a few years of backstopping before becoming independent. Sorry. The private sector investors are invested in the business case, risks, opportunities, product quality, manufacturing requirements, marketing strategy, and projected return on investment. You can't get away from there. And a marketing strategy for an entirely new product segment requires significant but little known public health risk. Is more than a sales strategy. It requires strategic and collaborative approach. So in summary, aflatoxins are pervasive in Africa. We need to actually, we need to integrate, we need to have more efforts to translate knowledge into actions and for benefiting African smallholders. Integrated aflatoxin management systems can dramatically reduce aflatoxin contamination, but it needs institutional and policy innovations to support the technology adoption. And scale up of sustainable models for commercializing aflatoxin biocontrol pathway is now underway in Africa. I would like to thank many of our partners who have been involved in this project. It has been a it's been a, and then many of the donors that supported our work, and as well as the team. We got a fantastic team who dealt with product development, with communication, with advocacy, with commercialization, with manufacturing and DNA technologies. And this was primarily done by USDA ARS and graduate students. And I would really like to thank the team for getting great work done. And thank you very much for giving this opportunity for speaking. Thank you.
Thank you, Professor Bandyopadhyay, for excellent presentation. Now, if there are some questions, they can be asked. One or two quick questions.
I have.
Yeah,
Ranajit,
yes, Professor. Yes, Professor.
Ranajit, hey, this is a wonderful, wonderful presentation on behalf of your organization. I do have a friend, Dr. Maso Kargil. Is still with you guys, or is moved out?
He is based in Cameroon now.
Under the same organization?
Yes, he is with IIT.
Man, I know him for the last 20 years. He's one of the best friend of mine. However, see, he's in the same line. And you, tell me your position. You from India, how long you been there?
I've been there about 19 years now.
So in 19 years, your technologies is being implemented in this part of the country, or you bringing this technology to our India?
I would like to. In fact, I would like to do that so much. That's what I've been telling Dr. Mukhopadhyay, that we have been working in Africa for this, not only in Africa, in Asia. In fact, I advise a program in Pakistan, and then I advise a program in Australia. And so India is my own country, and I really like to do this in this country. Actually, for the last 1 year, I'm actually based in Delhi right now because I couldn't go back to Africa because of COVID.
So what about same technology in Patancheru ICRISAT?
It's possible. I mean, in fact, we have a framework now. In fact, I see one of my colleagues, Dr. Ortega, Alejandro Ortega, with whom I work. So we would like to actually get it here. And this has been my desire for a very long time, but I would like to actually get an opportunity to do that. And I don't know what is the entry point, because I have not been here for a long time.
Dr. Bandyopadhyay, one question, one inquiry rather than. because you were working on the Ghana this isolates of aspergillus, and you applied all these this formulation into different countries. Uh, is there any limitations for local native isolates as happen in case of trichoderma?
Right. So all our products are country-specific products. So in each country, we go in, and in each country, we collect about 5,000 isolates from the entire country, okay, from all agro-ecosystems. And so the 14 products that I actually talked about, each of the products for each country is formulated with country-specific products. And those isolates that we select are very widely distributed in the entire country. We actually do an SSR mapping of these strains together with USDA ARS. And we know in which part of the country what frequency of this strain, of these genetic groups are actually present. So all the strains are actually, all the products are products made with native strains. None of these things are imported. I mean, we don't even move a product from Nigeria to, let's say, Cameroon, which are neighboring states. But what we have found is there are some products, there's one product I can talk, two products actually, three actually. So one of them is the Afrasafe SN01, which is a product initially developed for Senegal, but we found the same active ingredient in Gambia. And therefore now that product is used in both Senegal and Gambia. Similarly, there's another product which is found, which has got active ingredients that are co-distributed in Mozambique and in Malawi. So that can be used in both countries. And right now, there is another product, Afrasafe KE01, which was initially developed for Kenya. We have found that the active ingredients are also present in Uganda and Burundi. And so now those are being tested in those two countries as well. So that actually expands the whole market of the product.
So you based on that Gupta's question.
That is very natural.
No, last question.
Let me ask you,
what kind of regulatory system in Africa?
Right. So each of the countries, they actually have their own biopesticide regulatory authorities. So, one of the first things that we did together with USDA Foreign Ag Service is that right from 2009, so we knew that we have to deal with the registration aspects. So we began to work with the regulators and talk to them about the whole regulation process that actually took place for the two biocontrol products in the US with EPA. So we had, I don't know, you may know this person, Michael Breverman from IR4.
Oh, yeah. IR4.
Yeah. So Michael Breverman with IR4, we ran a series of biopesticide registration training workshops for various regulators. And we explained the technology to them, and we explained the whole regulatory process in the US. And so basically what we did was, the first product that was registered in Africa was in Nigeria. We used some of the data from the US, okay? And then the regulators asked us to provide some more data. For example, one data that they wanted us to provide was the poultry feeding study, because the poultry are going to eat it. So we did that. And in Kenya, they asked us to do a host of studies, 21 studies. So we did that. But the key point is that in all these tests that have been done, okay, there have been no adverse effect in any test. And so the last 4 products that we registered, we actually used the data from other countries and told them that this is the same genetic group of the fungus. And they waived many of the tox and ecotox studies actually. But we had to actually sensitize the regulators to a very large extent. It was a process, I must tell you, that and the thing is that when we actually go to a country for developing a technology, our first point of call, the first port of call is the government, and the government actually takes us to the regulators. And then we will sit with the regulators and ask them, what do you want us to do? So it has been a collaborative process through which we could actually get the registration done in 10 countries.
Interesting. The IR4 guys gives money to you from USDA?
No. I think we had a collaborative arrangement because that was paid for by USDA Foreign Ag Service.
Ah, okay. Excellent.
Thank you, Professor Bandyopadhyay, for a very nice lecture. I think we are running short of time, so we have to curtail discussion, sir. So now I hand over the mic to the organizer because I don't have the list of the invited speaker. So please.
So the first speaker.
Please.
The first speaker is Dr. DJ Patel from. Yeah, the first speaker is Dr. DJ Patel from Nico Orgo Manures,
Hello.
Gujarat.
Hello.
Yes, sir.
Can you listen to me, my co-chairman?
Yes, sir. Yes, sir. Now
Yes,
you are audible.
you are audible.
Because see, for all this time, I could see you, but there is no sound, you know. Somehow it has to change up, but I must thank Dr. Bandyopadhyay for the excellent presentation. Especially, he is amazing to listen his success story for long years in Africa. So that is amazing. Can you hear me now?
Yes, sir.
Can you hear me?
Yes, sir. You are audible, sir. Please.
Yes. What happened, sir? Some sort of technical problem at your end to connect me or something like that?
It is all okay, sir, from our end.
Okay, good. Now I'm happy. So we can go to the next speaker because I wanted to thank Dr. Reddy. After his speech was over, I couldn't do so. So I thank Dr. Bandyopadhyay for the wonderful presentation and his persistent effort to bring the technology at a higher level. Thank you so very much. Now let's go to the next speaker.
There are few questions in the chat box, so concerned speaker can write in the chat box.
Yeah, that would be better now.
Yeah, and the next speaker is Dr. DJ Patel. Dr. DJ Patel, could you please share your screen? Dr. Patel is not online.
Also tell 8 minutes.
Yeah, Dr. Patel is not online, so we can go to the next speaker. So the next speaker is Dr. Jyotsna Sharma from IPS National Research Center on Pomegranate, Solapur, Maharashtra. Dr. Sharma, could you please?
Yes.
So something happened.
Yes, Dr.
Yes, I'm sharing the screen.
I have one humble submission. I have to go. So if possible, my presentation may be placed right now, if possible. Otherwise, I have to leave this session.
Chair, please.
I have already requested.
I think, he requested Dr. Malkhan Singh. After Jyotsna, you please accommodate Professor Khan.
Okay, it's done.
Immediately after this lecture.
It is done. Dr. Khan will present after this presentation, after Dr. Sharma.
Yes.
Okay, sir. We will take after this presentation.
And try to finish within 6 to 7 minutes, ma'am.
Okay, sir. So good day, all of you. So I will be presenting on 6 steps management practices and effective economical and eco-friendly technology to control bacterial blight in pomegranate. This disease was of great importance and still it is important. And since 2005 when this center was opened, and you can see pomegranate is an important crop nowadays. And I think you can hear me? Hello?
Yes, please continue.
So India is occupying almost 50% area of the estimated global area and 2.62 lakh hectares area with 30.04 lakh
still coming.
Ton production is there. And you can see this in global area, China is second and India is occupying almost double the area than China. And the bacterial blight scenario, you can see it is mostly present in all the pomegranate growing states of India. And outside India, it has been reported from Turkey, South Africa, and Pakistan, but that was carried through India through infected planting material, which was illegally taken to these countries. Then you can see the symptoms of this appear on the leaf, fruit, and the stems, and stems are the potent carriers of this pathogen. And this is the gram-negative Xanthomonas axonopodis punici pathogen. And it can cause losses in all commercial varieties because the studies have shown that genes for bacterial blight susceptibility are tightly linked to the genes for big size of the fruit crop. And survival of the pathogen in nature can be observed that in the fresh active lesion, the canker, it is a high population can be observed, but in the old cankers, negligible population is there. And the dormant buds, where this canker is not observed, there it lives for several months, and this is the major source for the next season, as well as the carrier in the planting material. For long distance spread also, the infected planting material is the major source. And the spread of the pathogen through the planting material, you can see we had done an experiment, and just above the soil level, these cankers develop from where the disease spreads in the orchard. Secondary spread in the orchard, the major source is through wind-blown rain or spray splashes where this bacterial ooze comes out and spreads to the season. So the farmers are not allowed to take the bacterial, if their orchard is affected with bacterial blight, they are allowed not to take the rainy season crop, though it is a crop of the arid and semi-arid regions. And during the rainy season, you can see these factors contributing to bacterial blight from May to October. This is, however, we were taking the schedules, integrated disease insect and pest management schedule, and we got a lot of funding, and we could prove that yes, it can be controlled up to 80% and marketable yield can be increased. But now we came across, of course, this was a study. I got the indication from nature during one of the drought years. I got the indication that where all the leaves had fallen and the naked stems were exposed to sun, the next year blight was almost negligible. So from there, after studying everything, we could propose this technology. And if there is, it is adopted in a community approach, 100% results are there. In this, what we do, generally the farmers do not take anything after the harvesting. So after the harvesting, pruning has to be done, pasting and application of recommended organic manures or bioformulations and fertilizers have to be taken during December to January. And second, then it has to be irrigated for 2 to 3 months after the harvest, after the fertilizer application, and the sprays of only Bordeaux mixture are required for 10 to 15 days interval. Then after 2 to 3 months, we stop the irrigation in April, May, and put them to so much of stress. This is the main step, that you have to put it on so much stress that the leaves should fall by themselves. And these naked stems are exposed to sunlight. For 15 to 20 days, they have to be exposed depending on the weather conditions in different localities. And the tip burning has to be observed carefully. As soon as the tip burning is observed, you have to irrigate it, take pruning, and take the next crop. Otherwise, problem can be there. You can see that after doing this, we got a very good crop. This light pruning is done at the end of the stress period, and applying recommended manures and fertilizers for the crop season are taken, and then need-based sprays of the fungal diseases are required, and the insect pest management are required. Blight sprays, only copper or Bordeaux mixture is sufficient. No streptocycline, which is generally recommended in our routine IDIPM, was required in this, and we could get very good results in different years. So this was the schedule, and after that we do give humic acid and sulfur 80%, which is to reduce the pH. Bioformulations are applied in the soil. We reduce the split doses of nitrogen, because nitrogen increases bacterial blight. Salicylic acid, 4 sprays of salicylic acid are required, and need-based sprays of fertilizers are required. This is the once bacterial blight affected, now 100% bacterial blight free produce we got in the first year. Here you can see also here also very little, 1 to 1.7% blight was observed. That was also on the leaves. No blight was observed on fruit, and we could get very good results here also. and surrounding area was affected with bacterial blight. This is a rainy season crop. Then in another demonstration, also we could get 100% bacterial blight free produce with 11.45 kg per plant of production. Then we had an organic block where a lot of bacterial blight had come because from the neighboring orchard, and it spoiled all the organic block. Here also we took the same schedule and got wonderful results with 100% blight free. You can see the production also was good and the quality was also good. Then we took it to the farmer, and this farmer who was having 75% losses for 2018, since 2 to 3 years he was facing the problem. Then he, after doing this schedule, he could get 100% blight free schedule, and that yield also you can see there was yield was 21 in 2018 when blight was there, 21 tons in 5 acres, and it was 85 in 2019. Input cost was also reduced by, you can see here, input cost of around 60,000 was reduced, and he got income, you can see 11.76 lakhs in 2018, but in 2019 he got 39 lakhs from 5 acres, and the profit was of 9.36 lakhs in 18, and 2019 37.3 lakhs, and benefit cost ratio also you can see it was 3.9 in 2018 and 20:1 in 2019. So he got 100% blight free control, disease in pomegranate production, which increased the yield by 305% and saved on cost up to 60,000. That was 25% cost was also reduced. So with this technology, we can get disease-free produce, only it has to be done in the community approach. And we are now taking these future demonstrations. They are in progress in different farmers' orchards. We have adopted in Maharashtra. And I would like to acknowledge here ICF for funding the flagship project on integrated approach to eradicate bacterial blight, and my co-authors, Dr. Manjunath, Dr. Somnath, Dr. Ramakant Gharte, and Vijay Lokhande, who have helped me to take demonstrations. Thank you. Thank you all.
Chair, please.
Only one, Dr. Josna, after a long period, I am just seeing you. Thank you very much for your very good talk. And is there any problem of copper toxicity in the soil? Because you are recommending only the copper-based fungicides, no?
That is only once in a month, sir. Once 15 days, or when blight season is there, once in 15 days is copper is taken. And if in emergency, if someone sees blight, then it is not recommended. Are not recommended, sir.
Because you are using the along with this recommendations some glomus formulation, BAM fungi, and all these things, yes. Na? So is there any this bioremediation by these this inputs which you are using after this in the soil, rhizopegus or something else you have
yes, sir, that is rhizopegus, and that is a glomus species. Synonym is glomus species. So, and that we have seen that because it's a dry region crop, it gets established within the roots. And during the stress period also, it is giving lot of protection from the water deficiencies.
Sir, I have one more. Sir, I have one more question.
Also increases.
Chairman, I have one question, sir. Hello.
Chairman,
I have one question, sir.
Just 1 minute, 1 minute.
Yes.
I would like to say that this is a wonderful story which Dr. Sharma has presented, how in a span of few years' time, they have come out with the technology which can save the crop and also can yield such a huge results for the farmers of Maharashtra. Not only Maharashtra, other places also people can pick this up. You know, this technology has to be publicized more as a success stories all over the country. Thank you so very much.
Thank you, sir.
Shall I ask one question, sir?
Yeah, please.
Madam, yes, I am from Karnataka, University of Agriculture Sciences, Raichur.
Yes.
And what is the current status of this bacterial blight in Maharashtra? In Karnataka, unlike the previous years, the incidence is not that severe when we compare to earlier years.
Yes, in Maharashtra also,
यहाँ
the
यहाँ
new
से क्या
permanent
क्या
growers,
करना पड़ता है आपको?
the new permanent growers who are not knowing
हाँ,
about it and they are
अच्छा,
ignorant about that they are
अभी
carrying
तो म्यूट है.
the planting material, they are
Okay.
facing problem. The old farmers, they say we are not afraid of bacterial blight now. Now wilt is coming as a major constraint.
Okay, okay, madam.
I have
Here
one-
now we are facing the problem of wilt of a pomegranate.
For that also we have a protocol and we are now adopting orchards in Maharashtra as well as in Karnataka
Okay.
also near Bijapur and Bagalkot areas.
Okay, thank you.
Dr. Chakraborty had a question, something. Dr.
Sir,
Chakraborty,
one small
please.
thing. Josna, congratulations, wonderful work. And sir, I know Josna from her student days. She was my junior in Solan, and she had been an excellent researcher from then onward. Josna, you have developed a simple 6-step method, and is there any regulatory issue regarding use of salicylic acid, which is not nothing but aspirin, because what is the amount which is allowed by Codes Committee on Contaminants in Food or somebody else? No, I mean, because when you are using that as an inducer, so is there any requirement, regulatory requirement, because you are using 300 ppm?
As far as I know, that we are using 300 ppm of this, and salicylic acid, as you already know, that it is being produced by the plant during the stress conditions also.
Yeah.
And we saw that many organic production, even in USA, it is used in organic production also, salicylic acid.
To that level?
Yes.
So
Yes,
because that protocol should be accepted by CIBRC. No,
yes.
when you give. So just get to know about that. Otherwise, it's a wonderful thing. Thank you.
Yeah.
Thank you.
Thank you so much. Thank you. I think if there is no question, we can go to Dr. Rahman, our next speaker, because Dr. Rahman has to leave.
Yes.
Dr. HB Singh? Yeah, Dr. Rahman. Please go ahead. I think Dr. HB Singh has to introduce you. He has that brief biodata. Is it here? Dr. HB Singh, can you please introduce Dr. Rahman?
Please
Dr.
unmute.
Khan?
Unmute,
Emar
sir.
Khan?
Yes, please, sir.
Sorry, Dr. Emar Khan?
Yes, I'm ready. Hello.
Dr. Emar Khan is a renowned biocontrol scientist. He is currently Dean of the college and also head of the department, and pursuing his research career in biocontrol for almost more than 2 and 3 decades. So may I now request Dr. Khan to present his finding.
Yes. Thank you, sir. Honorable Chairperson, distinguished plant
बाकी क्यों नहीं आ रहा है?
watching and joining this session. In fact, I intend to present a general picture about the nematode infestation and damage in cereal crops and their management, because it is believed that the vegetables or the plants which are soft or having succulent, they are more susceptible to nematode damage, whereas the plant, for example, the cereal group which are hard and sturdy may resist the nematode attack. So, as we know that our more than 70% of population is directly or indirectly related to
Markan sir, your slides are not visible, sir.
No, my slides are not visible.
No, sir.
Sharing screen like
It's hang on for a while. It's coming.
what's coming, it's showing. Otherwise, you can again use share, sir. Now
It's coming, sir.
Coming, sir.
Yeah, just make it presentation mode.
Is here? Oh yeah, good.
Okay. So this is I am presenting or speaking on nematode problems, important nematode problems in cereals and their management.
Yeah, it's coming.
Yes.
Okay. Please go ahead.
Okay, so our production system has improved quite at present. We are producing the sufficient amount of cereals, but we need to increase the production because by 2030 we shall be needing at least 15% more cereals, 19% more pulses, 30% vegetables, oilseed 5% and foods more. So the simple question is, can we produce the required amount of food material to the burgeoning population in 2030? The answer is yes. but that could be possible by using the improvements in the crop production system. And one of the important component of the improved crop production system would be the crop protection, especially our protection of crops from abiotic and biotic stresses and factors. I concentrate on the biotic factors. Among the biotic factors, the weed, plant diseases, insect rodents, etc., they are the important. And among the plant diseases, the nematodes, they are responsible for 13% crop damage in cereals.
हम अगर बोलना चाहेंगे बोल पाएंगे कोई दिक्कत है नहीं इसमें
Nematodes, as we know, they are worldwide threat-like organisms. Animal nematodes have been known to us as early as 1960, but the plant-specific nematode was known to us only around 250 years before. So plant-specific nematodes, they are most ubiquitous, constituting 80 to 90% of all the multicellular organisms present in soil. As this picture shows, they are worm-like and thread-like with a clear suspension of nematodes present in water. You see they are thread-like as they are further magnified. At the interior end, there is a fin-like structure which is used by the nematode to feed on the plant or to penetrate to make a perforation in the host plant. There are different shapes of the nematode, but largely they are worm-form, thread-like. There may be the curvature like the C. There may be the further curvature for giving a helical structure or a spiral, or sometimes the nematode may be obeyed as this nematode. The symptoms, this is the limitation with regard to the nematodes. The symptoms which they induce, they are non-specific generally, which resemble with the nutrition deficiency. As a result, the plants ignore their attack, and in place of using some pesticide, they apply the fertilizers. But some nematodes, they cause specific symptoms. For example, root knot nematode, they cause the horns on the roots may become stubby, or there may be the root rot on the underground parts. Now I come to the main topic, the nematode damage to cereals. In this, I shall take some important diseases, only the important diseases in wheat, rice, and the general yield losses inflicted by nematodes to cereal crops that may be the 7 to 22%, and individually there may be 7 to 9% to wheat, 10 to 22% to rice, and 6 to 10% to maize, and so on, depending on the varietal response of the cereal as well as the population of the nematode present in the soil. So in wheat, there are the major nematodes, there are cereal cyst nematode and ear focal nematode, seed ball nematode. This Molia disease, which is caused by the cereal cyst nematode, Heterodora avenue, is prevalent in all kinds of climates, temperate, tropical, subtropical, Mediterranean region. And India is the disease prevalent in the major wheat growing areas, especially Rajasthan, Haryana, Punjab, UP, etc. And the yield loss may vary from 5 to the wide range up to 100%, meaning there may be the complete crop failure if the population of the nematode is very high. And these are the symptoms. There is the severe separation of plant growth in the patches in the field, and on the roots there may be the white cyst will be visible on the roof. The next is this ear focal seed ball nematode, which is caused by Angina typhus. And this nematode problem, in fact, this was a very serious problem in the developed countries in the Western Hemisphere, but has been almost completely eradicated using the physical and seed cleaning techniques. But in Asia, particularly in India and adjoining countries, this problem still persists in the tribal areas where the certified seeds are not used. So this nematode causes the stunting and the main damage occurs to the ear focal, ear head. There is a serious separation and deformation of the ear, and in place of healthy grains, the deformed brown colored hollow empty grains are formed, and these empty grains which are the seed balls. They contain millions of nematode larvae in quiescent state and resistant state, which may survive for 3 to 4 decades. So this is a serious problem. Then in rice, a number of nematodes have been found infesting the rice, and that's important. Is the Ufra disease, which is caused by Dicylanthus angustus, and this disease in India is particularly prevalent in Assam, West Bengal in particular. In fact, there are 2 types of the Ufra, the swollen Ufra and ripe Ufra, and this nematode also attack. In fact, the foliar nematode which attack the reproductive part, and this panicle is converted into a swollen and a reduced structure, having the sterile grains. This is another picture of this Ufra disease. Then white tip of rice disease is another foliar disease caused by Aphalanchoides spacei, and this disease in India is also again prevalent in West Bengal, Tamil Nadu, Andhra Pradesh, Gujarat, etc. As the symptom of the disease is that, as the name indicates, the white tip, the tip of the leaf turns the white to brown in color and gradually extend, and the panicle. This also becomes the catinase in the grains that takes place. The sterile panicles having do not have any grain is caused by this nematode. Then Hirschmanella is another important nematode problem. This causes the severe chlorosis and stunting of rice plants. So root knot nematode, this is an emerging problem. In fact, this nematode problem was considered to be prevalent only the upland and deep water rice, but even very extensively spread to irrigated rice, especially in the northern states of our country. And this disease affects both the nursery as well as the main crop. You can see here the nursery is badly affected with this nematode, surface growth, and having the chlorotic foliage. And then in the field, you can see the patches of the plants showing the stunted growth. On the roots, this nematodes causes the balls, where the terminal balls are formed. Then these are nematodes, the Brittle-Incus D, which is another important problem. This is present in many states, almost in all rice growing states in our country, and the disease is characterized by stunted growth, chlorotic disease, and the root, as a result of this nematode, rotting takes place on the roots. Yeah. And then is the important drug. In fact, I am trying to summarize my this presentation as much as possible. So for maize, in maize, there is the Heterodora V, Heterodora avenue, and Brittle-Incus species are the important nematode species. And the above ground symptoms are non-specific. On the roots, they become bushy and poorly developed system will be seen, and the cyst as the present as a white small oval structure present on the roots, as this picture is showing the cyst. Then Paratyphoidus minor, this is another important nematode. This is the ectoparasite, but it greatly impairs the absorption capacity of the root system, because the lateral roots, which are mainly involved in the root absorption, they are transformed into the short and thick roots, and their absorption efficiency is greatly impaired. As a result, the severe stunting of plant growth takes place. And then these are some other nematodes, for example, Brittle-Incus, which is endoparasitic nematode, Rhotilencolor, which is semi-parasitic nematodes, and Hoplolamus indicus, which is all both ecto as well as endoparasitic nematode, which affects the maize crop. And in the barley, oat, and sorghum, mainly the cyst-forming nematode and anguna, the seed-borne nematode, are important problems in India. In the picture showing the symptoms in the barley, here is the oat field, and having infestation of cyst-forming nematodes. In the picture, the sorghum cyst-forming nematodes on the roots of
Dr. Khan, I think you have to wind up. The time is running short.
Yes, I'm coming on the management aspect.
Okay.
For nematode management, in fact, we have to take an integrated approach, and sometimes even the individually these methods may prove very effective. For example, some in fact, a plus point with the nematode is that their spread is not rapid. On their own, the nematodes can move hardly 1 meter in a year. They need the agencies for their spread from one field to other field and from one region to other region. So that's why the domestic quarantine may prove very effective in containing the nematode problems to a specific region. Then the cultural method, they are also very effective for suppressing, managing the other nematode problem. The flooding following deep water, summer following and drying of the soil may prove very effective. Then crop rotation. Nematodes are generally the host specific. If you grow some non-host crop for continuously for 2-3 years, then their population may substantially decline, and that would be a very economic method of nematode management. Then the preventing the spread of nematodes is also equally important, as well as preventing their multiplication. So the care should be taken that the overflowing of water from one field to other field may not occur. Similarly, the implements using in the area where the high infestation level should be cleaned before using them in the area where the nematodes are relatively the lower population. And another important is we can prevent by taking some simple measures. We can prevent the multiplication of nematode. For example, in the cereal, in the case of cereal, generally the root stocks are left in the field. That allows the nematodes to complete their life cycle even after the harvest. So if the root stock, the roots are also removed along with the harvesting, then we can curtail a substantial degree of expected nematode population in the field. In physical methods, heat treatment, the heat treatment is particularly effective against nematode. For example, the soil solarization and steaming for reducing the nematode population in soil. And then the hot water treatment is very effective against those nematodes, endoparasitic nematodes, which are seed-borne or soil-borne. For example, as the case of the Angonia typified seed-borne nematode. Then the biological control, the biological control may prove very effective. We have lot of paper, lot of information that the biocontrol agents, they are multifacial. They are effective against fungi as well as nematode, the nematode. Excellent example is the Trichoderma species. The Trichoderma species are my submission, my recommendation is that as we use the rhizobium in case of the legumes and the pulses, the similar strategy should be adopted for using the Trichoderma formulations by applying them on the seed. So in the cereals, that would provide the protection from the fungi as well as the nematodes. The chemicals, although there is a lot of you try on the chemicals, their indiscriminate should be checked. But these chemicals may prove very effective if they are applied as a seed treatment. In case of cereals, they fit well. A very low amount, for example, 5 grams of a pesticide per kg of seed would be environmentally acceptable within the self-regulating capacity of the environment, but may prove very effective management against nematode. Then the integrated management, the set of strategies can be applied and may prove effective against nematode. So my conclusion from this lecture is, although India is self-sufficient in cereal, but we can produce much greater amount to feed the burgeoning population and would also be able to export them if pest and disease-free crops are grown. Farmers normally ignore nematode infestation due to their hidden nature of damage, but plant nematodes cause significant loss to cereal crops also. The integration of nematode management practices such as polarization, crop rotation, intercropping, and use of biological pesticides in combination with chemicals or alone would effectively manage the nematode problems in cereals, which shall lead to considerable increase in the crop productivity with eco-friendly and socio-economic consequences. Thank you very much.
Thank you, Dr. Rahman, for the excellent presentation which you have given about the nematode, and he very rightly said the nematodes go unnoticed because of their invisibility in different way, but there is a certainly solution. And I think biocontrol and minimum use of pesticide will come in a long way to solve the problem. Thank you very much again. Now we'll go to next speaker, Dr. Arup Mukherjee. Dr. Arup Mukherjee is principal scientist in CRI Cuttack. He has been doing excellent work on biocontrol these days. I have personally visited CRI and seen what type of result we can achieve using the good formulation of biocontrol agent in rice. So may I request now Dr. Arup Mukherjee to present his finding.
Sir, I don't know visual or not. I'm sorry because I didn't know that. So I have to present my data. So may you hit some time, maybe after lunch?
Acha, you're not ready yet.
No, sir, I didn't know that I have to give a lecture.
I see. So I think possibly I shall talk to the organizer and find it out.
Sir, with your permission, sir, we can call next speaker Dr. Gururaj Sunkar from UAS Raichur.
Yes, but how about Dr. Mukherjee? Can you present afterwards?
Dr. Mukherjee can present at his convenience, sir. After lunch, there is another session with the same name, Eco-Friendly Management, the technical session 2B, to be chaired by Professor Pratibha Sharma and Dr. Kusum Mukherjee.
Good. Okay, you can present in the next session with Dr. Pratibha Sharma and Dr. Prashun Mukherjee as the chairperson.
Yes, sir.
Thank you. So now request Dr. Sunkant, Associate Director Research and Professor in Plant Pathology at Raichur, Karnataka, to present his talk on prospect of plant growth.
Good afternoon, sir.
Yes, good afternoon.
Yes, sir.
Please go ahead, but you should be brief. Yeah.
Sir, it is a recorded video. Shall I present, sir?
Yes.
Sir, they have put a recorded video, sir.
Yeah.
Is it okay, sir?
Is it okay?
Please increase the volume.
Dr. Ramlendu, better to present live mode now. If he's,
I'm not presenting. It is being presented from Dr. Sunkar's side.
Sir, just a minute, sir. I will share the slide.
Yeah.
Okay, just a minute, sir. Just a minute.
How many more speakers are left out this session?
Sir, this is the end of the invited speaker. Now we have 5 oral presentations, sir.
What, you have 5 more oral presentation?
Yes, sir.
That means you're running behind the scheduled time.
Chairman, sir, Mukhopadhyay, sir, is it visible, sir?
Yes, visible.
Yes, sir. This is the presentation. The topic is prospects of plant growth promoting rhizobacteria microorganisms for the management of.
Slides are not visible, sir.
It is not visible, sir.
Not visible, sir?
No, please.
Okay,
please
wait.
Screen, sir.
Wait, sir.
So, sir, I would like to request all the delegates. So, just present from your side and don't play the recorded video. We have severe problems from the last day with the recorded video. It will be nice if you can talk directly.
Sir, just a minute, sir.
But do you give a lunch break here in between?
Sir, after lunch break, we have another session. So, it will be good if we can
continue
for lunch.
Continue with this. Okay. And next, you are giving about 5 minutes time for the speaker.
Sure, sir. Okay, sir.
Okay. Well, I think you're wasting much of our time.
Can we call the next speaker, sir?
Yeah,
With
you
your
can do
permission.
that. You can do that. You can do that.
Dr. Sunkar, you can arrange your PPT. By that time, we can listen the next speaker. So the next oral lecture by Dr. Kusal Raj from HAU Hisar. Dr. Kusal Raj, can you start sharing your slide?
Yes, sir. Okay, I'm sharing.
उनको बुलाओ जो दिखता है कंप्यूटर को.
Now, is it my slides are visible?
Yes, sir. Please proceed.
Good
You have
afternoon.
6 to 7
Chairman,
minutes
sir.
time. Yeah.
Dear delegates, today I have been provided opportunity to make a oral presentation on the topic exploring biocontrol potential for management alternaria leaf spot of aloe vera.
Hello, sir.
Aloe
Hello,
vera
sir.
is a highly important cultivated medicinal plant and also extensively used in the cosmetic, pharmaceutical approaches and most applicable homeopathic plant worldwide. Aloe vera is a rich source of antioxidants
ये बैटरी
and
लो बोल
vitamins
रहा है. हाँ,
that
कनेक्ट करना
may
पड़ेगा आपको.
help to protect our skin. Aloe vera plant has a short, stout stem and a rosette of fleshy lanceolate leaves which have a serrated margin of small white teeth. Many fungal pathogens are responsible for the production of mycotoxin that alter the potentiality of this highly important medicinal plant. It has been frequently reported that aloe vera suffers from alternaria leaf spot disease in various parts of the world. Now, this pharmaceutically important plant of India faces heavy damage due to leaf spot disease at the harvest stage, and the symptoms are small, round to oval, dark brownish, necrotic sunken spots placed mostly on the leaf and tip with normal diameter of 1 to 3 mm. The fungal pathogen was identified as Alternaria alternata. Leaf spot pathogen Alternaria alternata destruct leaf mesophyll tissues and decrease antimicrobial potential. The pathogen conidiophore was straight, branched, golden brown in color. The conidia were golden brownish in color, formed in lengthy branch chains, obtuse in form with small pointed beak. Various fungicides used to combat this disease have deleterious effect on the environment and on pharmacologically important constituents of aloe vera. To avoid the harmful effect of the fungicide, an eco-friendly approach was adopted for management of Alternaria leaf spot. And the present studies were carried out to evaluate different bioagents, Trichoderma harzianum, Trichoderma viride, Pseudomonas fluorescens, Bacillus subtilis, Azotobacter coccoccum, along with the fungicide copper oxychloride at a concentration of 0.2 and 0.3% under in vivo condition. And the Alternaria leaf spot severity in aloe vera at different interval was recorded as per the following disease score. After the experimentation, among the different treatment, the observations were recorded and it was found that the Trichoderma harzianum and Trichoderma viride were found most promising in controlling Alternaria leaf spot disease to the extent of 44.5 and 43.97% respectively as compared to the control and were at par with the fungicide copper oxychloride. Conclusively, the biocontrol organism possess the potential to decrease the disease severity and also help to maintain the good health as well as the antimicrobial potential of aloe vera plant. With this, thank you very much. If any delegate has any query, I am ready to answer.
Thank you so very much. I think if we have a couple of questions, we can do that. No question?
Sir, Mukhopadhyay, sir, my
Yes,
slides are
please.
ready, sir. I am Dr. Gururaj.
Okay. Now
Shall
we
I
can
step?
follow. We can follow Dr. Gururaj then.
Okay, sir, please.
Thank you. Next speaker is Dr. Gururaj.
Okay, sir. Slides are visible, sir?
Yes, please continue.
Okay, sir.
Okay, good.
Okay, sir. So this is the topic that I wanted to present, the prospects of plant growth promoting microorganisms for the management of plant diseases. And before we go to the topic, all will know what is sustainable agriculture. So it is a pragmatic approach of nutrient management to ensure that ensure the nutrient requirements of crops to achieve optimum yield levels. And for this, it requires combines resource conserving technologies as well as principles of conservation agriculture and modern agriculture in a balanced way. So these combined resource conservation technologies and principles include zero or minimum tillage, use of crop residues, then soil test based application of nutrients, then management of weeds with very less safe herbicides, and most important is the management of pests and diseases, which includes the use of the biological control agents and our plant growth promoting microorganisms. So ultimately, the aim is to ensure that the crop is healthy and farmers do not incur the loss. And for this, in my opinion, there are two major hurdles. One is the climate change and its impact, and then increased pesticide usage and its residues in plant products. And these are some of the figures that I obtained from the literature. We know by 2050, the temperature is likely to increase by 1.4 to 5.8 degrees centigrade. The current increase, as per the International Panel on Climate Change 2018, it is already the temperature has been increased by 1 degree. And by 2030, it is going to increase by 1.5 degrees centigrade. And by 2050, it is 5.8 degrees centigrades. If you compare the world, India, 4 degree centigrade increase as compared to the world, just 2 degrees centigrade. Of course, because of climate change, the yield losses have been reported from different crops. The literature says around 10 to 20% loss in the yields due to increased climatic change and its impacts on agriculture. However, all the times it is not true. There are reports that climate change has increased the yields of certain crops. And by 2050, it is going to touch 50% loss. And as far as adverse effects of use of chemicals is concerned, WHO has reported that every year 1.5 million people pesticide poisoning injuries are occurring, and nearly 1 to 3 lakh people are dying every year because of pesticide injury. And the global target is by 2030, we have to reduce carbon dioxide content by 100 crore tons. So keeping this in view, and the food as well as health security, and the use of the environmentally safe, then non-hazardous, and then eco-friendly management practices for management of diseases, which includes the use of plant growth promoting microorganisms. And as you know, plant growth promoting rhizobacteria or plant growth promoting microorganisms, they are really promising for sustainable agriculture, and they can be one of the components in sustainable agriculture. Of course, we have opportunities and challenges in the use of these plant growth promoting microorganisms. But as far as our experience is concerned, for the last several years, we are talking about use of trichoderma, pseudomonas, bacillus, and other microorganisms. However, the streptomyces, it is also promising, and there are reports that streptomyces can be one of the bioagents for management of diseases, and it is less exploited. And as you know, plant growth promoting microorganisms or rhizobacteria, they colonize the roots and they influence the rhizosphere, and they stay there, and then they have impact on the crop for the management of diseases as well as plant growth promotion activities. So these are the microorganisms: Pseudomonas, Trichoderma, then Bacillus, and this is the mechanisms. These are the mechanisms by which direct mechanism as well as indirect mechanism. So direct mechanism by means of siderophore production, then hormone production, nitrogen fixation, phosphate solubilization. Indirect mechanism by means of competition for nutrients, induced systemic resistance, antibiosis, as well as parasitism. And this is about bacillus, and particularly streptomyces is less exploited. We have conducted 2 case studies to the use of PGPMs for management of the pomegranate wilt caused by Ceratocystis fimbriata. As I was telling you, as Jyotsana Sharma madam has just presented before this presentation, and pomegranate wilt is one of the nationally important disease, and in Karnataka also it is becoming a major problem. And several orchards, the farmers they removed, and they have gone for some other crops. That is the extent of the pomegranate wilt. And then we started working on this for management of this Ceratocystis fimbriata using some of the bioagents. And what we did was we have collected 35 isolates of bioagents, particularly Pseudomonas fluorescens, from healthy rhizosphere of pomegranate. And out of 35 isolates, when we tested for their in vitro efficacy using dual culture plate method, 11 isolates they are found promising, and all these 11 isolates they inhibited the growth of the Ceratocystis fimbriata to the extent of more than 50%. Then such isolates they are further studies for their biochemical characters as well as the morphological characters. Then these are the pictures, and these are the plant growth promoting activities. All the isolates they were positive for hydrogen cyanide, siderophore, as well as production of indole acetic acid. And further the efficient isolates, particularly PFP11 and PFP4. So these 2 isolates they are further tested under glasshouse condition using different combinations, and totally we have made 8 treatment including healthy control along with the ruling chemical, that is propiconazole. Apart from propiconazole, we have tested neem cave, castor cave, and pungamia cave. And out of them, particularly these 2, PFP11 and PFP4, they are found promising. They inhibited the control the disease, and and we have recorded the lesser incidence of 20 to 23% when you compare to the 41% in the control. Of course, in propiconazole, it is better than the bioagent treatments. Then another case study is on the groundnut against stem rot of groundnut caused by Sclerotium rollsii. And this fungus, it is becoming severe year after year. And as groundnut is grown throughout the season in Karnataka and adjacent states of Karnataka, Kharif, Rabi, and summer seasons. And it is nowadays, apart from stem rot, we are facing the problem of pod rot also. So pod rot stage is very damaging stage, and we thought of working on plant growth promoting microorganisms against this fungus. And what we did was we have collected 50 isolates of Pseudomonas fluorescens, Bacillus subtilis, as well as Streptomyces for the management of this. And you can see out of 50 isolates, in 19 isolates, there was inhibition of the growth of Sclerotium rollsii in dual culture plate technique. And this is the photograph. Then we have tested for out of those the 19 isolates, 5 isolates they were very promising, and such 5 isolates they were tested for their plant growth promoting activities as well as morphological characters. You can see here. Then this is the Bacillus subtilis. Similarly, 19 isolates. In 19 isolates, there is some inhibition of the growth of Sclerotium rollsii. And these, out of them, 5 best isolates, they were further studied for their morphological characters, as well as the
I think, doctor, you have to cut short.
Okay, sir. Okay. I'll take another 2-3 minutes,
yeah.
sir.
Yeah.
Then as I told you in the beginning, the streptomyces is less exploited, and we have collected again the 50 isolates of streptomyces, and out of 50 isolates, and some of the isolates they are promising, and these isolates they were further studied for their plant growth promoting activity as well as inhibition. And this is the data of plant growth promoting activity of Pseudomonas fluorescens, Bacillus subtilis, streptomyces, and they were positive for SCN production, siderophore production, and indole acetic acid production, and other tests also. Then we went for shelf life. The talc powder, it has reported a maximum shelf life of all the 3 bioagents. Then in the fields in a glasshouse study, and we have tested 2 promising isolates of each Pseudomonas fluorescens, Bacillus subtilis, and then streptomyces along with the ruling chemical carbendazim mancozeb, which is available as print. And and these isolates, they have given somewhat promising results. Among them, PF2 isolates, Pseudomonas fluorescens 2, it has given very good control of stem rot as well as pod rot by recording 23.33% of stem rot and 16.5% of pod rot.
Sir, please unmute.
Yeah, please wind up. Please wind up.
Okay, these are all some of the programs that we have taken up in our laboratory, and these are our students who contributed a lot for the management of this disease. So this is all I wanted to present, sir. If you have any questions, please.
Thank you very much. Can you hear me?
Yes, sir. Yes, sir.
Yes, sir. So if there is one question, please.
Okay, sir.
One question, if anybody has. Now you have to go for large scale multiplication of this potential isolate so that you can get
Yes,
a
sir.
control for the farmer's field. That is what I can say from my side. Thank you
Yes,
very
sir.
much. Thank you.
Yes, sir. We are doing it, sir. We are doing it.
Okay.
We are distributing to the farmers, sir.
Okay.
Under the experiential learning program as well as our university program.
So thank you very much. We can now go to the next speaker.
Sir, the next speaker is Dr. M.S. Jadhav from NCIPM.
Dr. Jadhav, please.
Dr. Jadhav, please share screen.
Come to slide mode, sir.
This is a beautiful photograph in farm in field. Dr. Jadhav, what are you? Dr. Jadhav is missing.
Yadav sir, your voice is not coming.
Yes, sir.
Sir, make it in presentation mode.
No, it's not coming. Let's go to the next speaker then.
Next speaker is Dr. Vishnu Maya Basia from Division of Plant Pathology, IIR. Vishnu ma'am?
My slide is visible.
No, sir.
I have shared my slide.
Go to the next speaker. Let him adjust afterwards. We can do that.
Yeah, it's visible, ma'am. Yeah.
Yes, am I audible?
Yes, yes, please.
Yes, you are audible.
Very good afternoon, respected chairperson and co-chair, Dr. H.B. Singh, my teacher. I always feel privileged myself to present before you. Now, from biotic stresses, toxins, toxin management, I'm taking you towards the abiotic stress management. And the topic of presentation is molecular programming of drought challenged Trichoderma harzianum bioprimed rice. I am, along with these authors, contributed this work. We know rice is the staple food crop for half of the population of the world, and rice is sensitive to drought stress, and it affects rice morphological, physiological, and biochemical and molecular level. And worldwide, extensive research is being carried out to develop strategies for the management of drought stress. And recent studies indicate that microorganisms, they can also be helpful for the drought stress management. So, Trichoderma species, we know known beneficial fungus is reported to have several mechanisms to enhance plant growth, and in recent years, microbial agents, this Trichoderma species and others, they have become popular as this plant growth promoter, and they are also helpful for abiotic stress management also. Keeping this fact in mind, objective for the study are to evaluate the biocontrol agents against the drought stress tolerance in rice, and to understand the mechanism of drought tolerance in microbial inoculated rice plants. So these are the different genotypes we have used.
आधे घंटे में आ जाएंगे हम
We
इसके
have
बाद खाना
used
ना खाएंगे
Trichoderma harzianum, different strains, Chaetomium globosum, and Telleromyces flavus. We have given the biocontrol agents as a seed treatment. Seeds were sterilized, and afterwards we have bioprimed them with the biocontrol agents at the rate of 10 gram per kg of seed, and they were sown in plastic pots. And this is the experimental layout for the experiment. And we evaluated the effect of biocontrol on different parameters of rice, and we observed Trichoderma isolates, they perform better than others. And further, for the wilting also, we evaluated, we found that as compared to control, Trichoderma isolates, they perform better in pot conditions. And further, exposure of plants to drought stress leads to the biochemical changes. Drought stress, this stress negatively affects the membrane integrity. Less electric conductivity in Trichoderma harzianum was observed compared to other. And further, we observed that the Trichoderma harzianum treated plants, they have less MDA content compared to control. So further, we have tested cell viability test with the fluorescein diacetate and propidium iodide, where green color represents the viable or live cells and red color represents the dead cells. And here we observed that after 10 days of inoculation, more green color cells were observed in treated plants compared to control, where we could observe almost all cells were dead. Similarly, we observed, studied the nuclear DNA content, and we here also nuclear DNA content, more nuclei were present in treatments compared to control. Further, we have conducted whole transcriptomic studies using rice variety IR64 and Trichoderma harzianum 2 isolates. This is the layout of the experiment, and this is the methodology we have followed. For drought stress and Trichoderma treated drought stress samples, 21 to 22 million high quality reads were obtained. The alignment results showed that 86 to 95% of clean reads were mapped on the reference genome. The assembly of mapped reads resulted in identification of 33,691 differentially expressed genes. Further, a total of 2,424 genes were we observed to be exclusively expressed in Trichoderma harzianum treatment, whereas 2,256 genes were exclusively expressed in drought treatments. Further, we generated heat map to see the expression pattern of these genes and to see highly expressed genes. Further, volcano plot analysis of DEZs, they showed remarkable differences in gene distribution patterns. Based on transcriptomic analysis, DEZs under drought stressed and Trichoderma harzianum bioprimed conditions, the genes were classified into 21 broad categories, and gene ontology study was conducted which revealed 66% geoterms were assigned for Trichoderma harzianum treated drought stressed versus drought stressed samples. For cellular process 39.5% and for metabolic process 38.5% genes were assigned. And further, KGG pathway database was also used to identify the role of Trichoderma harzianum induced genetic pathway. The exclusively expressed genes in Trichoderma harzianum inoculated metabolic pathways were mostly related to glutathione metabolism, steroid biosynthesis, carbon metabolism, where highly upregulated genes were included, were related to photosynthesis. This is some genes we have, and we got enriched genes for phenylpropanoid pathways, and earlier was for carbon fixation pathways. Further, to confirm the accuracy and reproducibility of the Illumina RNA-seq results, 12 representative genes were chosen to validate using real-time PCR, and observed that these PCR results, they were consistent with the RNA-seq results. Further, these are some of the genes we found they are expressed when we treated our rice plants with Trichoderma harzianum, and these are some of the Trichoderma gene which were expressed when we treated them in rice plants under drought stress condition. Further, those genes we have validated in different varieties of rice also, and we could observe consistent results. So coming to the conclusion of the study, significant differences we observed for the Trichoderma harzianum treatment in different rice genotypes, and biocontrol induces various metabolic pathways, and mostly photosynthetic apparatus, photosynthetic genes, antioxidative genes, and glutathione pathway related genes were observed upregulated. And further, regulation of carbohydrate binding module, polysaccharide lyase, glycoside lyase genes were more expressed in Trichoderma harzianum, and overall it can be concluded that the Trichoderma harzianum biopriming, it delays drought stress in rice cultivars by multitude of molecular programming. So thank you.
Sir, you are not audible. Please unmute.
Hello.
Yes, sir.
Yes, sir.
Yes. Please continue this work. This is a very good basic research, and with regard, and if biopriming can help the water stress, it will be a great achievement for the Indian farmers in the water shortage area. Thank you so very much. We go to the next speaker.
Thank you.
Dr. M.S. Jadhav can start.
That's the last one?
No, sir, another two.
Oh my God. Anyway, Dr. Jadhav is ready?
Dr. M.S. Yadav, sir.
Malkan Singh Jadhav? No. Go to the
Mahendra
next
Singh
one.
Jadhav, sir.
Next one.
Yeah, sir is
Dr.
ready.
Jadhav is ready.
Now it's
Yeah.
visible.
Please, your time is 6 minutes.
Sir, you are not audible, sir. Your slides, we can see your slides, but your voice is not coming.
Let's go to the next speaker, then let Dr. Jadhav set it further.
Yadav, sir, your voice is not coming.
Sir, may I present?
Yes, please go ahead. Next one. Let Dr. Jadhav set it all right.
So the next speaker is Dr. Bhina SS from Division of Crop Protection, ICR Central Tuber Crop Research Institute, Kerala, India.
Dr. Bina, please.
Am I audible, sir?
Yeah, you're audible, but your time is 6 minutes. Don't
Yes,
spend
sir,
time on introduction and other things. Thank you.
Okay, sir.
Okay.
Honorable Chairman, Co-Chairman, and distinguished plant pathologist. Title of my presentation is Eco-Conscious Approaches to Manage Fungal Disease of Aroids. Roots and tuber crops are unique in their way because of all these factors. I'm not explaining it. Coming to aroids, it comprises taro, elephant fruit yam, and tania. They are preferred due to their culinary delicacy, high nutritive and medicinal value. Taro leaf blight is the most destructive disease and a major constraint for production. TLB is caused by the pathogen Phytophthora colocaceae. It's mainly a foliar pathogen, though it affects petiole and cormals. Thus reduces cormal yield up to 50% and leaf yield by 90% in susceptible varieties. The symptoms start as a small water-soaked light brown spores on the leaves, and the spores enlarge rapidly, increase in size and number, coalesce, and lead to the complete destruction of the leaf. The petiole infection results in collapsing of plants. In case of cormals, it rot rapidly after harvest. Coming to management strategy, host resistance is the most ideal and economical one. All our germplasm are being screened in different stages. CTCR has already developed 3 resistant varieties, Muktakashi, Bhukripa, and Bhusri. In case of resistant ones, the spores restricted with a yellow halo. Based on the results of 400 accessions screened in field and 117 accessions with challenge inoculation, 10 accessions are identified with TLB resistance. They are being evaluated for further quality parameters. Taro is a clonally propagated one. Same cormals, whatever we consume, the same cormals are used for propagation. Hence, use of disease-free cormals and removal of infected tubers and leaves are at most important. Don't use mother corms for planting if the previous crop had TLB incidents. After planting, slightly alter the planting date in a way that the conditions favoring disease development is not coinciding with the cormal formation. Intercrop with non-crop host like okra, use short duration variety like Telia. The infection starts on the lower leaves which touch the ground when the previous crop is infected with Phytophthora colocaceae. We have found that mulching with organic or any other material can significantly reduce the disease incidence. 8 bacterial isolates and trichoderma isolates showed excellent control up to pot culture studies, but in field only 4 isolates, which is marked in green, performed well. The efficacy of root endophyte Piriformospora indica was also explored. It reduced disease incidence up to 74% in Srikaran, that is susceptible variety, and 70% Muktakashi, that is a resistant one. And that also increased level of chitinase and glucanase activity, and total phenol content was noticed in colonized plants. Role of vermi-wash and vermicompost on pathogen suppression was ascertained under field condition. And it was found that the cormal treatment with vermi-wash combined with the soil application of vermicompost and drenching and spraying at 60 and 90 days after planting decreased PDA and increased yield. Occurrence of TLB during rainy season and waxy leaf surface of taro make the fungicidal spray ineffective. Hence, we wanted to see whether the cormal treatment combined with soil application of biogens to the soil at the time of planting alone can reduce the disease incidence. The result indicated that cormal treatment with either Bacillus ameloleukophaciens or Trichoderma combined with soil application of bioagents enriched vermicompost can significantly bring down that incidence. And based on all these results, we have refined our management strategy as like this: growing resistant varieties, Treat the cormals in cow dung slurry enriched with trichoderma, strict field sanitation, mulching with paddy straw or locally available organic material, and BCA enriched vermicompost at the rate of 100 gram per plant before planting, and spraying as well as drenching with 10% vermi-wash, and it has to be repeated at 15 days interval during rainy months. And coming to elephant fruit yam, collar rot caused by Sclerotium rollsii and post-harvest rot caused by a group of fungi are the important destructive ones. Out of 14 fungi identified, Sclerotium, Lasiodiplodia, Cultutricum, and Fusarium are the most frequent and destructive ones. Collar rot cause 20 to 100% damage when conditions are favorable. First symptom is the water-soaked lesion at the collar region. The plant starts showing yellowing and finally collapses. In post-harvest rot, various kinds of symptoms of rotting are seen. These rots not only reduces the produce but also affects availability of planting material and crop stand in next crop season. And when it comes to collar rot, no resistant variety is reported so far. In this case, artificial screening or growing in stick plot is more reliable. 3 accessions, AM1, AM128 and AMW22. They showed some tolerant reaction and it's being further evaluated.
बहुत टाइम ले रहा है.
Reducing
घर में बना है.
inoculum is the most effective management strategy here. Always use healthy, disease-free planting material. Avoid using planting materials from infected area. Ensure that the seed material is stored properly. And coming to the bioagents, Bacillus ameloleukophasion, subtilis, and licheniformis and trichoderma, they showed very good potential in reducing the incidence. In field experiment, it was seen that comb treatment with vermi-wash combined with soil application of vermicompost and application of vermicompost after 90 and 120 days after planting can significantly reduce collar rot incidence and increase yield. In another field experiment, it was seen that the trichoderma, the vermicompost which was enriched with the trichoderma, it is equally effective. It is giving very good control and it is equally effective as the chemical control. And based on all these results, the management strategies refined as comb treatment with cow dung slurry enriched with trichoderma aspergillum and trichoderma aspergillum enriched FIM at the rate of 2 to 2.5 kg per pit at the time of planting. And once again, trichoderma aspergillum enriched vermicompost has to be added, and later removal of infected plants and additional application to surrounding plants with the trichoderma enriched vermicompost. And different strategies including bioagents, chemicals, and CTCRI developed cassava leaf-based biopesticide NANMA were evaluated for the management of post-harvest rot. Mealybug incidence is another important problem during elephant foot yam storage and it aggravates the rot. Hence, incidence of mealybug was also monitored. Cormal treatment with trichoderma enriched cow dung slurry or with the NANMA 0.7% can effectively manage both post-harvest rot as well as mealybug. And this is the way it was done. Here we are surveying the we are seeing the mealybug incidence. And based on the result, the management strategy for post-harvest rot is it's formulated as minimize injury to combs during harvesting, carefully remove infected portion from the comb, always store in a ventilated place and dip the combs in trichoderma enriched cow dung slurry or NANMA 0.7% before storage of the combs. And there are some points we have to address in future, that studies on emerging disease. Apart from these diseases I mentioned, now we get some foliar blight and pseudostorm rot also. So this has
I'm in a meeting.
Development of decision supporting system and integration of various strategies, studies on effect of nutrition on pathogen suppression, and finally investigation on soil properties that promotes the growth of bioagents. Thank you.
Thank you very much, Dr. Bina. I think you are able to supply this trichoderma preparation to farmers around, or
Sir, now I
Sir, for the experimental purpose, we are giving, sir. Commercially, we are not giving because of some rules, because they put forward that we couldn't make the CIB registration order, and all
Okay.
our research purpose, and for that we are giving to the farmers.
Very good, excellent. So we go to the next speaker then.
Yeah, the next speaker is Dr. Nehilal from ICR Center Potato Research Institute, Region of Station Merit.
Sir, my presentation remain. Am I audible?
Yeah, you are audible.
हाँ सर, फिर मेरी करवाओ सर.
साउंड थोड़ा कम है.
Dr. Jadhav,
हाँ सर.
you are not clearly audible. It is difficult to follow. Your sound is very low. So by the time you check your sound system, we can listen Dr. Nehilal.
नहीं, I have
Dr.
changed
Ghosh,
my
sound system आ रहा मेरा?
Nehilal, please go
ahead.
Dr. Ghosh, Dr.
Yes,
Ghosh.
yes, clearly audible.
Okay, thank you.
Dr.
Respected
Nehilal,
chairman,
please.
co-chairman,
Modipuram, Meerut,
and
yes.
delegates.
5 minutes time.
Okay, sir. Okay, no problem. I am presenting a research where antagonistic and phosphorus solubilization activities of native Pseudomonas species against soil and tuber-borne the disease of potato.
Yeah.
Here we
go ahead.
considering black scurf, dry rot, sclerotinia rot, and sclerotium wilt are the major diseases under soil and tuber-borne category. They cause up to 50% the losses. For their management, we have tried to search bioagent, especially bacterial isolate. So we have planned a 3 objective. First one, isolation and characterization of native Pseudomonas fluorescens species from rhizosporic soil. Second is bioefficacy against soil and tuber-borne fungal pathogen. Third was to evaluate phosphate solubilization potential and effect on agronomical parameter. So we have selected here 5 pathogen. One is Fusarium species. Second is Sclerotium. Third is Sclerotium, the Rolfosai, Rhizoctonia AG3 and Rhizoctonia AG first. We have collected 22 isolates from Punjab, Uttar Pradesh, and Bihar. And these isolates were characterized on the basis of morphological character, fluorescence color, shape, gram staining, catalyzed production, and motility and sporulation.
Okay.
Further, we tested all these isolates for the bioefficacy in 2-way, one a dual culture and volatile method. And we found that PF10 and PF14 showed highest inhibition of all these pathogen, up to 60% in case of dual method we got inhibition. In case of volatile test, we got up to 88% inhibition of the pathogens, these pathogens. These are the photographs showed that in dual culture PF14 and PF10 shows highest inhibition against all the pathogen. Similarly, we did the volatile test also and found that PF10 and PF14 among the isolate was effective for the inhibition of mycelial growth. Then we also tested for their the cell-free culture filtrate, and we found that 48-hour old culture filtrate were more effective than the 24-hour old culture filtrate for inhibition the mycelial
AC
growth.
थोड़ा बंद हो जाएगा AC.
And similarly, we have also tested percentage biomass reduction of these different fungal pathogen in 5 broth media. We found that in highest biomass reduction was recorded in king bee broth medium, followed by nutrient broth medium. The next, we also have tried to evaluate the phosphate solubilization efficacy of different these bacterial isolate and PVK medium, and we found that highest solubilization rate and solubilization efficiency and solubilization index were found in case of PF10 and PF14 isolate, that one 5.65. On the basis of these character, we have tried to just for initial try, we that also formulation, target-based formulation and this cell-based formulation. And we found regarding the emergence of, in case of treated tuber with these formulation, we found 95% emergence in comparison to control up to 85%.
Very good.
Similarly, on the another character, stem and leaves, highest number of leaves were recorded in case of PF14 target-based formulation. The next character, we also measure the plant height, root length, and root volume. And we found that all these characters are more root volume, root length than the comparison to control. And in the case of field, we found that the stem canker was percentage control of stem canker was 67%. Then the control. In the conclusion, we found that these two isolate bacterial isolate PF10 and PF14 was effective under laboratory condition, and their phosphorus solubilization index and solubilization efficiency was also higher. The both formulations showed a good efficacy for the agronomical parameter. And regarding the stem canker, it also controls 67% under field condition. We'll try these isolate further for the next year, whatever the similar result are getting on our under field condition.
Good, excellent presentation.
And
Very
these
good.
is conducted with the support of SERB, the DST project. Thank you all.
Thank you very much. So we go to the next speaker. Mr. Jadhav is ready, NCIPM, or yet to set his audio.
Manuel, please stop sharing your slide. Yeah.
Thank you.
Otherwise, what we do is we can take MS Yadav presentation in next session, sir, if not possible.
Yes, that's God. Let him set it all right.
Okay. Now he is coming, sir.
Is there?
Yes, he's coming. He's in my room actually. He's coming. So he will present here.
Okay.
Okay, Dr. Yadav, welcome. I am very sorry that your audio was not working. Welcome.
Final presentation.
You please go ahead.
Without headphone is also okay, sir. You can use. The sound is much clear here.
Yeah, IPS presentation. Final scissor webs. Presentation.
MS. Research.
Final IPS. F पे नहीं है क्या?
तो F तो नीचे है ना?
उसमें देख अपने IPS पे देख लेना IPS presentation दूसरी भी.
I think I would suggest give it in the next session. I think it will be too long a time, Dr. Yadav, if you don't mind. Give it in the next session so that you can formulate it. Thank you so very much, Dr. Ghosh, my co-chairman, Professor H.B. Singh. I don't see H.B. Singh. H.B. Singh is not around or where?
It says he left actually. He was some work, so he went, sir.
I see. But he should have taken permission from the chairman before he left, you know. Anyway, it's a good job all of you have done together. I'm very happy about it. The good presentations, especially the keynote speakers were very good. So I'm thankful to IPS for giving me the opportunity to chair this session and get my knowledge updated further. Thank you so very much.
So now, sir, I would like to thank Chairman Dr. A.N. Mukhopadhyay, sir, on behalf of society and myself. I would like to thank chairing this session and nicely conducted, Dr. A.N. Mukhopadhyay, sir, and Dr. H.B. Singh, sir. Thanks to all the keynote speaker, Dr. Becky Westerhard, Dr. Daniel Robert, Dr. R.N. Pandey, Dr. Professor M.S. Reddy, Dr. Ranjit Bandyopadhyay, and invited lecturer, Dr. D.J. Patel, Dr. Jyotsna Sharma, Dr. M.R. Khan, and Dr. Gururaj Sunkar, in oral presentation, Dr. Kushal Raj, Dr. Bishnumaya Basyal, Dr. Veena, Dr. Mailal, and all the participants who are attending this conference. So I would like to thank on behalf of society. So we will also, sir, one important thing, we will send the memento and a token of love from society to you, both the chair, by post, sir.
Okay, okay, welcome.
Kindly accept
Welcome.
it.
Thank you very much, my reporter. You have done a very wonderful job.
And also, I will also thank to reporter Dr. Mahilal and Dr. Amlindu Ghosh.
Okay. What is your good name? You didn't say your name. I have not introduced you.
I am Dr. Malkhan Singh Gurjar, sir.
Okay. Dr. Malkhan Singh, thank you so very much. God bless you.
I am treasurer of the society now, sir.
Oh, I see. Good, good, Dr. Malkhan. Thank you. I wish you all the best.
Thank you so much, sir.
We have to hold the flag of IPS high.
So we will try, sir. We will try our level best, sir.
Thank you. Thank you.
Yeah,
Bye.
highly thankful to you, sir. Dr. Mukhopadhyay, sir. We are very
Yeah,
thankful to you, sir.
Yeah, Madam
Very-
President, nice to
yes,
see
yes.
you after
Yes,
long,
yes, sir.
long
Yeah, yeah.
time. And I wish you all the best when you take over after Dr. Chakraborty. You have already going to take over tomorrow, or you have taken over already?
No, tomorrow.
Huh?
Tomorrow, sir. Tomorrow, not
Tomorrow. Yeah, we are waiting for the D-Day.
Yeah, yeah.
And I would like to have a party from you when I visit
Yes,
Delhi
sir.
next
Sure,
time.
sure, sir.
Thank
Sure,
you.
sir.
Good luck.
Welcome, sir.
Good luck. Bye.
Thank you, sir. Thank you so much, sir.
So now, sir, we will move to technical session 2B, sir. It is same on eco-friendly management. So for this session, I will invite Dr. Prasoon Mukherjee, sir. Prasoon Mukherjee, sir, you are here, I think. So I invite Dr. Prasoon Mukherjee.
Yeah, I am here.
Yes, sir. Yes. Welcome, sir. So presently he is working as a professor, head of environment and biotechnology section, BARC, Mumbai. And Dr. Mukherjee has immense contribution to basic biology and application of trichoderma as a plant disease control agents. And he has identified novel genes related to mycoparasitism and antibiosis. And he has published so many papers, around 70 papers in high impact journals. And he has developed and transferred 3 technologies, which resulted in many products that are available in the market. And he is recipient of several awards like Bicust Fellowship, Homi Bhabha Science and Technology Award, then Fulbright Fellowship, Pran Vora Award, M.J. Narasimhan Academic Merit Award, J.F. Dastur Memorial Award, and he is elected fellow of NAS and National Academy of Sciences, and he has been a visiting scientist in Israeli Institute of Technology and Texas A&M University, and he is presently editor of Fungal and Genetics and Biology and Frontiers of Fungal Biology and 3 Biotech. And Dr. Mukherjee edited 2 books published by Cabby and Springer. So I welcome, sir, and you kindly chair the session in this technical session 2B, sir. Second chair is our teacher or our mentor, Dr. Pratibha Sharma, sir, madam. Presently, she is a ICR Emeritus Scientist and Department of Plant Pathology, SK Agriculture University, Jobner. Professor Pratibha Sharma, presently she is a president-elect in society, and presently is ICR Emeritus Scientist and former principal scientist and head of the Division of Plant Pathology, and professor also in IRI. Her major area is research biological control agent, like mainly the trichoderma, metarhizium, Bavaria, Pseudomonas, especially their use in IPM and IDM different cropping systems. Professor Sharma has more than 100 peer-reviewed research papers in national and international journals with patent trichoderma on her credit, and she received many awards in professional society, including National Crystal Agri Award by Krishi Anusandhan and Krishi Vikas Foundation, New Delhi, and Sarda Lele Memorial Award. And she has been served as a secretary last 10-15 years. And Professor Sharma is presently working on consortia application of Trichoderma hergenium and metarhizium anisoply against the major pest in groundnut and cumin. So I would like to request Madam kindly chair the session on the eco-friendly disease management. So kindly, both the chairs kindly conduct the session.
Thank you, Dr. Malkhan. On behalf of society, I welcome Dr. Prasoon Mukherjee. So we both will be chairing this session, and so I think we start with his lecture first. It is his lecture. Are you ready, Dr. Prasoon Mukherjee?
Yeah.
With your presentation? Yes. So we will request Dr. Mukherjee first.
I don't know its title actually. I'm not having that information, but we welcome Dr. Mukherjee for this.
Can you see?
Yeah, it's visible.
Okay. Okay. So, should I start?
Yes,
Madam?
sir.
Okay. So this is the title. Okay. So, I thought, I mean, there was no communication actually regarding the title, so I could not send it. Trichoderma secondary metabolism, pathways and applications. Our lab mostly work on the mechanisms of biocontrol, basically, a little bit of basic research. And also we have one product being developed. So I thought of combining these two. They are related, but not very well connected. So the first half will be on discovery of secondary metabolism pathways. And the second half will be on the applications. I'll skip this slide because everybody knows about it. Regarding the mechanisms of biocontrol, you see mycoparasitism, antibiosis, induced defense, and competition is well known. And secondary metabolites have been found to be involved in all these processes. So what I want to highlight is secondary metabolism, though they are called secondary metabolism, or secondary metabolites, they are not really secondary. They play very important roles. In Trichoderma virens, the species I work on, the major metabolites are gliovarin. Then there are siderophores, both intracellular and extracellular. There is one steroidal metabolite called viridin, and another sesquiterpene called heptenidic acid. These are the non-volatile metabolites. And the volatiles, there are three major metabolites: germacrin A, germacrin D, and beta-caryophyllene. So our aim has been to discover the biosynthetic pathways based on genomics and genetic studies. So the first half I will be speaking about that. So identification of the siderophore gene clusters. Everybody knows that trichoderma produces siderophores, but which genes are responsible for the biosynthesis of the siderophores and what are the functions was not known. By genome mining, we identified the gene clusters in fungi and most other organisms. The secondary metabolites are produced by a group of genes called gene clusters. As you see here, for intracellular siderophore, there are 5 genes. And for the extracellular siderophores, we call SEED, D, and NPS6, there are 7 genes. We have a tool to knock out the gene, like it's like getting isogenic lines. You just remove one gene from the genome, and then they're compared with the wild type, and then that's how you know the function. So here, the ferric-protein synthetase, that is the intracellular siderophore gene, we deleted. And by HPLC, we proved that this is not producing, the mutant is not producing the siderophore. We did the phenotyping, and then the result was a bit surprising because the mutants in ferric-protein deficient mutants, they colonize the roots more vigorously of maize plants, but they had reduced ISR ability. So root colonization was improved, but ISR ability was reduced. Similarly, we also knocked out the extracellular siderophore gene called NPS6. As you can see here, wild type, the siderophore is present, and the mutant, the siderophore is absent. We are characterizing the mutant now. Identification of the gliovarin gene cluster. Gliovarin was discovered about 50 years ago, but nobody knew about the genes responsible for gliovarin production. What we did, our strain produces gliovarin, so we sequenced the whole genome of our strain, which was submitted to GenBank. And then by gene knockout, again, we discovered a huge gene cluster. 22 genes, they are responsible for the production of single compound gliovarin. Basically, by gene knockout, we could prove it. And then you see here by LCMS analysis, we proved that wild type, indeed, they produce gliovarin, but the mutants are not producing gliovarin. So thus, using this information, we could predict, because we know the genes, we know their tentative functions, putative functions. So we could propose a pathway for production of gliovarin, starting with one single amino acid, phenylalanine, how gliovarin is formed, synthesized by trichoderma virens. Similar strategy we used for viridin. Viridin was discovered in 1945, but we did not know the genetics of viridin production. The same approach like we used genome mining followed by gene knockout, and then we could identify a gene cluster comprising of 21 genes which are responsible for the production of viridin. Again, by LCMS, we could prove that knockout mutant, this is a knockdown RNA-I-based strategy. So we could prove that wild type they're producing by viridin, but the mutants are producing much less quantities of viridin. And again, based on this, our paper was published, and then immediately there was a paper after a few months from China. So they're also working on another organism which is producing dimethoxyviridin. So they proposed a pathway. Only the last compound, the viridin, is not produced in their organism. So we have identified by gene knockout that OMTB, that's O-methyl transferase B, that is producing viridin. So again, this pathway was discovered based on genomic studies. Coming to the volatile metabolites, we have identified a gene cluster, very important gene cluster. We call VIR cluster because it's from Trichoderma virens. It comprises of 8 genes. And we didn't know the function of it until we did a knockout study. We did a knockout of the VIR4 gene, that's a terpene cyclase. And the red line is wild type, and the blue line, which you can't see basically because there's no metabolite being produced. So 22 secondary metabolites are being produced. They're volatile sesquiterpene secondary metabolites. They are produced by this gene cluster. Interestingly, there is a GAPDH gene associated with this cluster. And when we knocked out the GAPDH, also we found the same thing. If we knock out GAPDH, so we have knocked out basically 2 genes of this cluster, and both are having the same phenotype. That is, they are not producing volatile sesquiterpene metabolites. Again, by with help of our chemist friends, we could propose a pathway for production of volatile sesquiterpene metabolites based on this information generated. Okay, now this is what about a bit of basic research I wanted to share. Keeping with the theme of the meeting and the session, I'll talk about a mutant which is producing more secondary metabolites, and we have gone up to the evaluation in the field and came out with a formulation which is doing very well. So I'll share some of the results with you. This is a mutant. You see the wild type is green, as you know, Trichoderma virens, and the mutant is somewhat brown in color. We screened, this was done by gamma ray induced mutagenesis. So you can see like the color of the filtrate also is darker. That's how we could screen, like we screen a lot of mutants, and then it came out with this mutant which is producing more secondary metabolites. As you can see in the bottom panel, the PTM inhibition also, you can see wild type inhibits, but not to the extent of the mutant, which is called G2. By HPLC, we proved that it is producing 2 to 3 times more secondary metabolites of all those I mentioned below, like before, viridin, glyverin, heptalidic acid. They're producing more. This mutant is producing more of those metabolites. So we wanted to support our claim with genetic studies also. So we did a transcriptome, and as you can see, about 20 genes which are known to be involved in secondary metabolism are upregulated in the mutant compared to the wild type. We targeted collar rot of chickpea, which we thought is a very serious issue. Not only in chickpea, but there are more than 500 plants getting affected. So if you can manage this single pathogen, we can manage many diseases basically. As you see, the damage caused, it causes seed rot and seedling damage. Like every one of us do, like we start with the dual culture. So in confrontation assay or dual culture assay, we did not find any difference between wild type and the mutant. We did an assay for parasitism of sclerosia also, because these sclerosia, they survive in soil. It's very difficult to eradicate them. But Trichoderma, some of Trichoderma virens especially, they love to eat these resting structures. But here also, we see like they are equally effective, both the wild type and the mutant. We formulated wild type and mutant in talc-based formulation, coated the seeds, and then evaluated extensively in greenhouse and microplot experiments to see if the mutant is better than the wild type. Yeah. So after exhaustive evaluation, we concluded that G2 mutant is better than wild type in containing Sclerotium rhodsi. So I talked to Dr. Kotastane from Raipur. Actually, he is my prime collaborator in this project. So he told, okay, I can take up some demonstration trial in our field, Colorado infested chickpea plot. As you can see, it started in 2015. We are still continuing in the last 5 years. We have extensively evaluated in many locations, including AICRP trials. And the results have been very encouraging. Just simple seed treatment can really do the miracle if you have the right strain and the right formulation. As you can see from this, this is Dhamtari, again Chhattisgarh near Raipur. This photograph was sent by Dr. Kotastane again. I mean, most of the photographs I will be showing will be photo courtesy of Dr. Kotastane. So this is 1819. This is a farmer's field again in Kabardha near Raipur. You can see that, for treating 1 hectare of seed of chickpea does not cost more than 100 rupees with the trichoderma formulation. But the yield gain was like what they said is about 20,000 rupees per hectare. So it's really a profitable proposition. We tried in soybean also. Germination is a big issue in soybean. So we tried this formulation in soybean, and the results are very exciting. As you see, the growth promotion also that is another thing. Like we are getting growth promotion of all the crops we have tested, especially under field conditions, including soybean, chickpea. This is maize. This year, I was not doing about this trial, but Dr. Kotastane just tried. Like he gave the formulation to a farmer, and who treated maize seeds, and he just sent a photograph last week that see the results are very exciting here. Also, like a lot of growth promotion effect with the seed treatment. This was done in Nadia district of West Bengal. We have a good friend, Dr. Rajiv Nath. He's very enthusiastic. So last 3 years, he has taken this trial. This year, data is awaited. So, this is 70 farmers field average over 3 years. And the yield gain is on an average 17,000 rupees, or the financial gain is 17,000 rupees per hectare. Bottom panel, you can see the effect of seed treatment, control and treated. Very nice growth promotion you see here. Last time, in a few months ago, in Central Zone meeting, I was presenting, and some gentleman raised the question, have you tried in Rajasthan? I told this year I have given the formulation, so results are awaited. So again, recently I got this data. I have not got the data, but the photograph from Jodhpur Agriculture University, and they are very excited about the results. So Rajasthan also really it is working well. This is in cumin. Some of these data have been published already, so if anybody is interested in frontiers. To summarize, trichoderma products, there are more than 1,000 secondary metabolites. Trichoderma produces 1,000 secondary metabolites. Many are antimicrobial and anti-cancer. Role of only a few are known, in microbial interactions and plant interactions. Most of them have unknown functions, and each genome harbors a very high number of genes or clusters for secondary metabolism. Only a few have been studied. A huge potential to discover novel metabolites using gene manipulation. A mutant with improved secondary metabolite biosynthesis has enhanced biocontrol potential. That is the second part of my study. Thanks to my teachers, especially Dr. A.N. Mukhopadhyay. He has been my mentor and guru ever since I joined MSc AG plant pathology in his lab. My students, my colleagues and my collaborators, especially I should take the name of Dr. Anil Kotastane, as I told, Dr. D.R. Saxena from Gwalior, and Dr. Rajiv Nath from BCKB Mohanpur. Thank you.
Thanks, Dr. Mukherjee, for your excellent presentation.
Yeah.
So I think all the students and they all will be getting a very good information. If anybody wants to ask the questions, I think questions are invited here. If not, then I wanted to ask you one question.
Yeah, madam.
Can you tell me that is the mutant allowed for the registration in Central Insecticide Board?
Yes, it is. It is a radiation-induced mutation. Mutant. It's not like a GMO. It's just like protoblast fusion. Same category it belongs to. Yeah, it falls in the same category. The protoblast fusion also has two mutations, as you know. For markers, they put two mutations and then they select. Yeah.
So I think the second question I wanted to ask you, only the seed treatment is helping the increase in yield in your case?
Yes, that's simple seed treatment, nothing else.
I think I request the other participants want to ask the question. Ask the question, otherwise then we start with the second presentation. So no questions, and we come to the second presentation by Dr. Jayaraj Jayaraman. Sorry, I want to ask my counterparts. Dr. Amlindu, are you going to brief the biodata of the speaker?
I don't have ma'am with me.
Should I have the copy with me? Shall I speak out?
Yes, sure, ma'am.
So, Dr. Jayaraj Jayaraman, he graduated in agriculture, earning a doctorate degree in plant pathology at Annamalai University. He served as a senior lecturer and till 99, and then completed his postdoctoral work at the Kansas State University, USA, as a on a visiting fellowship. He served as associate scientist till 2003 at KSU, USA, then later as senior scientist at the Simon Fraser University, Canada, between 2003 and 2009. In 2009, he joined UWI as senior lecturer in microbiology and biotechnology. Since 2014, he has been a professor of biotechnology and microbiology at the Department of Life Sciences, Augustine, UWI Station, Augustine. His research area is mainly on the fields of microbiology and biotechnology. And the specific research projects, they are being focused on the plant microbe interactions, elicitor biomolecules, biological control, molecular-based disease diagnostics, and many others, metabolic engineering. So we have a very experienced professor of biotechnology and plant microbiology. You are invited to deliver your lecture, please.
Ma'am, excuse me, ma'am. I don't see Dr. Jayaraj online. Dr. Jayaraj, if you are online, please respond. Yeah, he is not online, ma'am. So may we call Dr. D.B. Olufolaji?
Yeah.
Dr. Olufolaji, are you online?
Please unmute. Please
Are
unmute.
you online, Dr. David? I think he's online, but you unmute. Unmute yourself.
Yeah, I am unmuted. Yeah.
Open it. Open.
Yeah, you are on mute now.
Yes.
So,
I'm
Dr.
online.
David, can I introduce him, Dr. David? He is a lecturer, researcher in plant pathology, microbiology at the Federal University of Technology and in Nigeria. He started his working career at the Ilorin Sugar Research Institute, University of Ilorin, and he became top specialist in sugarcane pathology. Obtained his BSc and MPhil at the University of Ibadan, Nigeria, between 1975 and 85. And his PhD in plant pathology and microbiology from same university. He has carried out his research and published extensively in the area of plant pathology and microbiology in high impact factor journals. Traveled to almost 6 continents throughout the world, has immense research collaborations, belongs to several national and international scientific societies. Okay, so we invite you. He's also an international editor of Indian Journal of Phytopathology. So we invite you, Dr. David. You can start with your presentation, please.
Okay. I've sent my recorded slides.
Would you like to play that? Because in most of the cases, recorded slide it's not good, playing good. So I would request you that if you can speak directly with your slide.
Oh, I was thinking with the recorded slide that I will just listen to it, then respond to questions. But now I didn't prepare for. I have my slide there, but I didn't prepare for that. I'm preparing for. I prepare for the recorded slide so that I will speak to it. My slide is with you. Can you send it online?
Just give us some time so we can listen the next person, and by that time I will prepare your slide.
Okay.
Ma'am, with your permission, we can now call Dr. Arup Mukherjee.
Okay.
Pratibha, ma'am.
Sir, one more submission. Madam, with your permission, I request that those who have sent the recorded presentations, let them be prepared, because most of them thinking that the recorded will be played and whatever questions will arise, that will be answered.
I thought that you would have contacted me that the recorded slide I sent is not functioning. Probably I will have made additional preparation for this particular session.
Yeah, Dr. David, they will arrange it. Just wait for a moment.
Yeah.
Okay, I'll be waiting.
Please respond. Mukherjee, sir.
We can go ahead with the next.
Yes,
Go
yes.
ahead with the next presentation. Yeah.
Yes, I'm here, but I'm trying to log into my device because I don't know if it is properly available or not. Is it properly available?
You are audible. Could you please share your slide?
Yeah, please. Okay. Is it visible?
Just hang on. It's opening. Yeah, just make it presentation mode.
Okay. Is it okay?
Yeah, fine.
Is it okay?
Yeah.
Okay. Then thank you for giving me the opportunity to speak in front of you all. This is my proud privilege actually, in fact, to talk about you and dedicate this presentation to two persons. One is Professor A.M. Mukherjee, of course, and then Dr. P.K. Mukherjee, who have actually taught me how to work about psychology. I'm not an expert in this line. So, my presentation topic is the role of trichoderma for sustainable agriculture. Okay, so hello. So what happened actually that we while doing the sustainable agriculture, we have lost many things and we have done lots of harm to the environment, right? So that's why I wanted to show that a single microorganism that is trichoderma, how its huge diversity can help in sustain, it will make the agriculture sustainable, more sustainable, and sustain the production of agriculture. It can reduce the load of chemical pesticides, the reduction of water by reducing drought tolerance, reduce the use of chemical fertilizer, proper management of agricultural waste of plant residues, then maintaining the soil health by adding organic carbon to soil, and then
And then you can see here, I'm not going to elaborate about this picture because already many have talked and already delivered about that. So you can see that mechanism of trichoderma has biological control agent. I'm not telling because already Dr. Mukherjee has already told, PK Mukherjee.
Excuse me, sir. Sorry to interrupt, sir. You are logging with two systems. Your voice is humming. Please close one system, sir.
Echo is coming. Echo is coming.
Sir, you are in two system.
Just
Close one system.
Now is it okay?
Yes, sir. It is okay. Please.
Okay. Then these are the different mechanisms. Already many have showed it. Now I'm coming to our work, that how trichoderma can help in reducing the chemical pesticides. This is first work we did with Dr. PK Mukherjee when I was in Nagpur Central Institute for Cotton Research, and we developed a formulation that is known as effect of that is trichocas. And here, this is the pathogen we first reported from Wardha, and it has been published in Journal of Plant Pathology. That is Sclerotium delphini causing cotton seedling rot as well as seed rot. And when we found this, there was a confusion whether it is Sclerotium delphini or Sclerotium rofsi. Then when we studied in detail and we saw it is Sclerotium delphini, and this to avoid this disease, the cotton used to have alternate crop for groundnut, because this is a common pest to the groundnut, but it is now infecting groundnut. And these are the different species we isolated from bracket fungi as well as bark of eucalyptus and acacia. And then what we did, we made a soil, and all the soils are sterilized, and then we mixed with Sclerotium delphini your pathogen. We make seed soil. This is absolute control. No pathogen is there, no type biocontrol agent. And then we treated our seeds of cotton with different species of trichoderma. And you can see this is completely sick soil, no trichoderma seed treated. And you can see that only 2 seedlings are there surviving. And here it is one activity, only 5 seedlings are there. Here it is Hargianum, one we collected from eucalyptus. And you can see here, this is only 6 seedlings are there. But this one was found to be superior. And you can see here 8 seedlings are healthy. And when we studied their effect on the sclerotium of Sclerotium delphini or Sclerotium rofsi, you can see here, you can see this CICRE, it is totally overgrown on the sclerotium of the Sclerotium rofsi, whereas others, they are not that much successful. Then I was transferred to CRRI, that is Central Rice Research Institute. Then again, I wanted to continue that work, and the most hurdle was that in rice is grown in submerged condition. It is a water stagnant area. So I was not sure that whether it will work or not. Then what I did, I started searching my trichoderma from different tree bark, and then I got many. You can see here which are pictorially presented. These are different tree species I collected, and I saw that they are morphologically different. Then also I saw the Conidia 4 and Conidia, and then I use molecular characterization to identify them. And then we have identified them to belong to different species, and these are the sources. And most beauty of this work is that none of them are isolated from soil. You know that till morning I was listening all the presentation. The whatever trichoderma were isolated, they are from the soil, but these all are from tree barks. You can see different tree barks we have isolated, and this work has been published in Microbiological Research. And then we have taken 2 serious pathogen. One is seed blight of rice, another is seedling blight of rice. This occurs in almost all the seasons here, dry season and wet season, and this one occurs in dry season here. And then we characterize them for their efficacy against different pathogens, this trichoderma, and you can see most of the cases they are highly effective. But here are 3 trichoderma strains we got where the pathogen is overgrowing the trichoderma. So we rejected it, and this is the growth inhibition. And then what there is a question that whether our trichoderma will be able to inhibit the seedling germination or not. So we tested that and we compared with the market formulation, and you can see here this is normal condition that our trichoderma treated seedlings, trichoderma treated seeds, their germination was better, and these are sick soil, and you can see where trichoderma treated seeds, they are giving much better result, even in comparison with the market formulation what we got. Then we tested in the different pots, pot experiment, we got the similar result. Then we tested in the pot condition for seed blight. This is the control, you can see the lesion is growing like anything, and here we used one CRI T2 isolate, and you can see after little bit expansion of the lesion, it stopped, and here T3, it did not allow the lesion to grow. So this is the disease area, how it is growing in control, whereas in treated, these are the growth of the lesions area. And then we compared that we are able to successfully induce chlamydospore artificially, and we compared the chlamydospore and conidia about the efficacy, and you can see this is a disease control, and these are the treated with chlamydospore and conidia. And when we saw that we use chlamydospore and conidia as foliar spray as well as seed treatment, we are getting much better result. And then in the field condition, we wanted to see that when we use seed treatment or biopriming of seeds with trichoderma, then we in the field condition, what is the disease scenario? You can see the brown spot incidence in a corona variety, corona and Sahawagi, that corona is highly susceptible to almost all the diseases. And when we treated with CRI T2 or T3, this brown spot incidence is very, very less. Exactly similar is the case for seed blight incidence also. This is a control and these are the treated. Then we study different expression of different defense enzymes. Then we can see here that wherever trichoderma is it is treated with trichoderma, we are getting higher expression of different defense enzymes. Then we wanted to see the promotion of growth, how it is helping in the growth of promotion. You can see here the mean germination time is reducing when we are treating with trichoderma. You know the rice we use 21 days seedling to transplant, but when we treat with trichoderma within 12 days, the seedlings are getting ready to be transplanted. Okay. Then this is the microplot. You can see this is the controller. These are the treated with different trichoderma species. You can see the differences. Again, the photo from other side, and then you can see the seedling. You can see the root growth and the shoot growth. This is control, and these are treated with different trichoderma, and these are the two which are our candidates. Okay. Then we have seen their effect on seedling vigor index. You can see seedling vigor index is much higher in case of CRI T2 or CRI T5, and then different other agronomical parameters we have studied. You can see here that in all the cases wherever trichoderma is treated in comparison with the control, it is much better. Okay. Then NPK content of the total plant was also studied, and we saw that NPK control of NPK content of the root, shoot, or root, shoot, and root potassium content NPK in root, shoot is always higher in case of trichoderma treated seedlings. Okay. And then chlorophyll content also is studied, because this was studied because we wanted to see that how it is not allowing the plants which are treated with trichoderma to any yield loss, to face any yield loss. And we saw that it is preserving the chloroplast culture and chloroplast structure, and then it is helping to retain its photosynthetic efficiency, and it does not allow the plant to lose its your yield. And then we went for real-time PCR analysis for different antioxidant and defense related enzymes in two different varieties. This is Annapurna. You can see here when we treated with trichoderma, we got much higher expression of POX, LOX, PAL, then defensin and PR3 genes. You can see it is much higher when we treated with trichoderma in comparison with the control. Similarly, this is another variety, Shatabdi. It is highly popular in West Bengal. You can see here exactly similar scenario what we got in Annapurna. And this is, you can see this field was made in two half. One half I used trichoderma treated seedlings, another one was control. You can see here the plant height number of panicle emergence, everything is much higher in this case than this one. Then our director, he wanted to visit this field. Dr. Himanshu Pathak was the director, and he himself visited the field. We tested the yield also, and then we have seen it is showing 18% higher yield than that of control. And this is the farmer from Jajpur. This is the treated seedling he transplanted. Sorry, untreated seedling he transplanted. And this is the treated seedling he transplanted. Then we quantified the ECH42 gene in trichoma treated paddy soil, that how it is growing in the soil, and we could see that when we use trichoma treatment, seed treatment, then we got higher amount of trichoma seed treatment, but it did not affect the other microflora of the soil. And then you can see 100,000 grain weight is much higher when we use trichoma treatment than that of control, and yield per meter square also is much higher when we use trichoma seed treatment. And then average yield per meter square in the different rice varieties, we have checked. One we have taken Corona, one is Sahabagidhan, and you can see here trichoma treated, they have given much higher yield per meter square in gram than that of the control. And then this one is very beautiful photograph I got, and this farmer, he is from Kendrapara, from Odisha. Sorry. He took our trichoma formulation and he treated the seeds of black gram, and you can see here the plant stand here and plant stand here. And I have just given here a part of that photograph I have taken here to show the plant stand. You can see the plant stand here and just see the plant stand here in the treated. And then this one is done in, Koraput. Koraput district is a organic district. So in Koraput, I have tested in Niger. A farmer, I have not done it. It is done by a farmer, and you can see this is treated and this is untreated. Okay. Similarly, it has been done in small millet. You can see this controlled vegetative stage. This is treated vegetative stage, and this is the controlled reproductive stage, not treated, and this is the treated reproductive stage of small millet. Then comes to induction of drought, and you can see here that soils are almost cracked, and you can see this one, and this one, they are extremely green. This one also. Then what we did, we took them to the field to see whether in the field it is coming or not, and you can see after 15 days of 7 days of irrigation, we stopped watering. Then after 15 days, we again water withdrawal was there, and after that you can see the plant stand here, and you see the plant stand where it is trichoderma after re-watering after 15 days of water withdrawal. And then you can see here the disease incidence also varied in trichoderma treated. This is control and these are the treated. Exactly here also you can see that this is control and this is treated. Then we got different plant growth parameter also much better than in trichoderma treated than that of control. And you can see here, this is the control and this is the treated. You see the root length. Okay. And you can see similarly, this is a drought susceptible variety, drought tolerant variety, sorry, CR143. It is drought tolerant variety. And normally the root length is high, but when we treated with trichoderma, we see the root length. And this is a drought susceptible, that is IR20, and root length is very small. And when we treated, you see the root length is very, very long. And then we just study the different stress enzymes also. And then you see in the field, we have exposed them to the drought. This is the control, and this is the treated with trichoderma. This is after 22 days of your drought inducing. You see the soil is completely cracked, and this is completely rolled and almost dried, whereas the trichoderma treated, they are surviving excellently. Okay. And this also has been published in Frontier in Microbiology recently. If anybody wants, you can see it. And this another one, that paddy straw burning is a serious problem. I'll take another 5 minutes. So to stop that, we have used trichoderma by testing their activity of a different enzyme activity like cellulase, xylanase, and lactase activity. You can see here. And then we have exposed them for 45 days of trichoderma treatment. And this is the treated and this is untreated. And we have studied their effect on the rice, rice compost effect on the rice growth, and we have got better growth when we use rice treated with rice straw treated with trichoderma compost. And then stress enzyme also we have seen. And then You can see the plant growth promotion activity in rice variety using trichotillomania mediated rice straw compost. You can see it is much better here, the growth, than that of control. You can see in the pot also, for this is control, these are treated. And then chlorophyll content also is in control, it is very less than that of the treated one. Then mean germination time also varied a lot. You can see this is treated with trichoderma, this is control, and these have been covered in different newspaper. And in conclusion, I can tell that from all the above observation, we can conclude that the huge diversity in trichoderma species may help to make the agriculture sustainable, not only for crop production, but also saving the environment if we use them judiciously. There are many other microorganisms which can make the green revolution successful in true sense and leave the environment green for our next generation. In this context, I want to tell you that recently one of our paper has been accepted in environmental science and pollution research. Let us hope that it will come out within a few days. So this is all which I want to tell. Thank you very much for giving me the opportunity. This is my group, and this is my collaborators and my students. I am thankful to all of you, and of course I am thankful to the IPS. Thank you very much.
Thank you, Dr. Aru, for such a nice presentation and very useful presentation. So you have tried to solve not only the problem of disease, but also the how to utilize this rice straw and all this. I think I've seen there in Raipur also they are doing this similar kind of work with, I think, Prasu Mukherjee and yourself. You all are working with this. Thank you very much. Any questions, please?
I've got one question. It's very nice presentation, Dr. Mukherjee.
Thank you, madam. Thank you.
Yeah, I'm just wondering, have you tried to look at the effectiveness of trichoderma under prolonged drought conditions? Because what happens in a rain-fed situation, sometimes it doesn't rain for 3, 4, or even 5 weeks. So have you tested your product, under those circumstances?
Madam, I could not follow exactly what is that, where there is some network problem. Can you please repeat the question?
I'm just asking, have you tried your product to look at the effectiveness under prolonged drought conditions? Because I think, as I guess from your presentation, you tried for 7 days of like.
No, madam, you have not seen, madam, the my field condition slide I have shown, where we have water withdrawal is given for 22 days.
Oh, okay. 22 days, okay.
Yes, and madam, the question is that we are studying the detailed mechanism already. We have studied it, but I did not report it here because I didn't. It was very shortage of time. I had to present it. Thing is that, madam, actually in our case, what I have seen that their root length is becoming enormously long, almost 1 meter. Okay, so they are collecting the water from the inside, and our trichoderma is endophytic. Okay, so it is working. After 22 days, we have seen. This year again, we have taken in the field condition. Let us see what is the result.
Oh, that's great. And have you tried with other crops other than rice?
Madam, I have showed it that we have tried in small millet, we have tried in black gram, we have tried in Niger.
Okay, have you tried in crops like canola or brassica agentia like mustard?
Madam, thing is that I am in rice. So
okay, all right. Okay.
There are reservation, but if you want, I can share my formulation.
Okay, that's great. Thank you so much. Yeah, thank you. Yeah.
Dr. Jairaj has come. Has he joined, Dr. Jairaj?
Yes. Could you hear me?
Yes. Yes. Yeah. So we will request Amlindu.
Yes, ma'am.
Request Dr. David.
Dr. Jairaj is already available on.
You request Dr. David for the.
Hi, Dr. David.
I think we can request Dr. Jairaj to.
Dr. Jairaj is already available online.
Yeah, Dr. David, I checked with the IPS office and they have not received your PPT. So could you please send the mail so that we can download and float it from here? Otherwise, you can directly present from your side.
So now Dr. Jayarajan is already available. That can be scheduled.
Meantime, we can listen Dr. Jayaraj, ma'am. Chair, please.
Yeah, go ahead, please.
Okay.
Yeah, we welcome Dr. Jayaraj Jayaraman, Professor of Biotechnology and Plant Microbiology.
On site.
Is he online?
Yes, yes.
Okay.
I am online. Could you hear me?
Yes.
Yeah, I can hear you. I'm not
Yeah.
Name was
able to
changing.
see
That
you.
was the issue.
I'm not able to
Very
see
good.
you. Okay, I'll just introduce you. Though I had already introduced you earlier also. Professor Jayaraj, he graduated in agriculture and earned a doctoral degree in plant pathology at Annamalai University. He served as a senior lecturer at Annamalai University till 1999, then postdoctoral work at the Kansas State University, USA, and postdoctoral visiting fellowship was till 2000. Then he served as an associate scientist till 2003 at KSU. Then later as a senior scientist at Simon Fraser University, Canada, between 2003 and 2009. In 2009, he has joined as a senior lecturer in microbiology and biotechnology. And then onwards, since 2014, he is a professor of biotechnology and plant microbiology at the Department of Life Sciences, UWI St. Augustine. His research area is quite a wide range with the fields of microbiology and biotechnology. His focus is on plant microbe interactions, elicitor biomolecules for induced resistance, then biological control, molecular-based disease diagnostics, characterization, metabolic engineering, and antimicrobial resistance, and so on and so forth. And so he has a very good experience. So we invite you, Dr. Jayaraj, kindly continue with your lecture, please.
Thank you very much, Prof. Sharma, for this nice introduction. And I apologize for being a little late because of the time difference. And I thank Dr. Makesh for that kind wake-up call this morning. And then I was just able to log in and, just available, make myself available. And again, thanks for the opportunity. So though I have sent my presentation with voiceover, I don't know that there is some issues here. So I don't have a problem to do that again in person. Very good. So you are able to hear me and see the presentation?
So make it in full slide mode.
Yes, certainly.
Yes.
1 second. I'll do that. Yes. Is that okay now? Could you see?
Yes, yes,
Please
yes.
proceed,
Fine.
sir.
Okay.
Yes,
Very good. Very good. Very good. Very good. So the title of the presentation is Developing Integrated Disease Management Systems for Sustainable Vegetable Production in the Tropics. Tropics here mean Caribbean tropics. Okay, Caribbean is also considered as a tropical region. So here I'm going to talk only about Caribbean tropics, even though the tropics in Asia is other tropics which always people refer to. This is no way connected to the tropical Asia. This is only Caribbean tropics. And this is one of the research projects we have recently accomplished. We have been carrying out from 2012 to 2018 under the funding of European Union. And so we just accomplished, and this project has been completed. Now it is in the sustainability phase. After completion, we are in the sustainability phase studies. Just before going into the presentation, I want to give a brief introduction about the problems of the Caribbean, particularly with the diseases of vegetables. There is very little data about the emerging diseases on vegetables, and the data on seedborne spread, particularly the seeds and seed materials are being transported between the Caribbean island states, and there is no data about the spread of seedborne diseases. And the permanent disease monitoring systems is also inadequate. Remember, all these Caribbean countries are very small, and you can just size-wise and population-wise, it may be a little bigger than one district of India. So, but they're all called as individual countries. So having this kind of monitoring systems is a kind of difficult, and they are not paying much attention. Even though they do have some, it is highly inadequate, and there is no organized system at all available. And the molecular diagnostic facilities, they are available, but they are not what to say, in contemporary standards, they are not updated. And growers' practice normally dependent on the chemical control methods. So people are using plenty of chemicals. And we have also identified over the years several fungicide resistant strains. And I think you are going a little fast. Would you please give me control to change it? Yes. Would you please give me control? Yes. So growers are unaware of the integrated disease management systems. So we need to educate them. And before that, we want to develop the systems because many of the biological inputs are not commercially available. So we wanted to develop the inputs and also optimize them for the field conditions so that they can be made available for the growers. So those are the problems, and based on the problems, we have developed the objectives. And as I said earlier, to study the prevalence of crop diseases, particularly the emerging diseases through crop surveys, as well as trap plots and development of early and efficient diagnostic techniques for the identification of diseases, and the development of the IDM system for the vegetable crops. Here we focused on 3 model crops: tomatoes, cowpea, and pumpkin, which are extensively cultivated all over the region. And finally, we want to, after we have developed and optimized and tested the technology, we want to deliver the technology by transfer as well as a skill and knowledge transfer and outreach. So these are the technologies they have developed, based on the development of IDM treatments, which include all the available methods like cultural methods, biological methods, chemical methods. And after we have developed the inputs, we tested those inputs under field experiments as well as greenhouse experiments. We have conducted 2 bi-season experiments. Here we have only 2 seasons, a dry and wet season. And we have done these experiments over the period of 3 to 4 years in 4 different countries at multiple locations. So that was being done for several years on a continuous basis. So this give a brief gist of the methodology and the activities we have done. So assessment of disease and the diagnosis and the IDM trials, where we have incorporated all the different methods, and the outreach and technologies, wherein we have delivered so many trainings and workshops in all the countries. Some 5 countries in the Caribbean arc. And we have done conferences, publications, as well as field demonstrations or on-farm demonstrations. So these are all the type of parameters we have assessed. Different chemical fungicides. We have used a bunch of fungicides which are allowed for vegetables. Not the high toxic ones, but the safer fungicides. And they are not belonging to the same group. There is no redundancy in the type of fungicides as well as the pesticides. So we use a bunch of pesticides and fungicides. So that is to give an opportunity for the farmer to select 2 of them so that they can use these fungicides alternatively. And again, the type of the amount of fungicide use will be highly minimized. That means 1/3 of the regular use. And the remaining treatments were substituted by other methods. So we have also optimized the biological agents and biopesticides. We have developed some of them, and the cultural methods, particularly different fertilizer regimes and manures, and elicitors and biostimulants. These are not very commonly available here. So we have developed these. and tested under field conditions. This is just one example of field trials. We did more than 40 field trials, and this is cowpea, tomatoes, and pumpkins. And just an example of how some of the developed biocontrol consortia, the PGPR consortia, are effective in controlling the diseases. This is just an example on tomatoes of how many of these consortia were effective in controlling the soil-borne diseases, particularly the Pythium caused by Pythium sclerotium ralsii and Fusarium oxysporum. Okay. This is the evaluation of some of the bioelicitors. This is one of the commercial bioelicitors which is available. This is an imported product from Acadian from Canada. And this is a seaweed extract where you can see the extensive root growth compared to the control. And the plants are growing really well in the presence of seaweed extract spray. So here the type of application was a spray application, right? When they were applied in the field as well as in the greenhouse, we have done this experiment several times, and we consistently found that the application of seaweed extract has improved the growth as well as reduced the disease intensity, the Xanthomonas leaf spot and the alternative leaf spot. I'm just giving only 2 examples, but we have done this for various diseases. And addition of a small dose of fungicide, that means just 1 spray alternating with every 3 sprays of seaweed extract, augmented the effect. Here you can see the diseases are controlled better than the seaweed extract alone. And the interesting point here is even it is better than the fungicide alone. Okay, so the same thing was witnessed with the fruit yield, right? There was some kind of conflicting observations with other people that they were saying it is only a biostimulant. So we were one of the first to prove that this is not just a biostimulant, but also it is a bioelicitor. So when we did extensive studies with RNA-seq as well as the enzyme activity and transcript profiling through qPCR, we found on and on that they were able to evoke the JA pathway and the ethylene pathway and not the SA pathway, right? So we have also developed a chitosan formulation, and that chitosan formulation was also effective in controlling both bacterial as well as fungal diseases. I'm just giving an example for only 2 diseases. And when we analyzed the type of pathway induction, here also we found the PIN2 and the ETR genes are upregulated, which is indicative of the JA and ethylene pathway and not the SA pathway. And this is about some of our own formulations of seaweed extracts. And since we are in the Caribbean region, we are surrounded by the sea and we are gifted with the the growth of natural growth of seaweeds. And these are the 2 seaweeds which is available locally. One is called the Acanthophora spicifera, which is a red seaweed, and the other one is a Sargassum vulgar, which is a brown seaweed. Particularly this brown seaweed, Sargassum vulgar, is becoming a menace because we are getting huge landings of this Sargassum vulgar during the summer season, and as a result, the beaches are closed, and it is becoming a real nuisance for the beach. And people do not have a tangible way to utilize this biomass. It is just simply wasted. So we have a separate project working on different uses, potential applications, industrial applications, utilizing this biomass of Sargassum vulgar. One such method to use this Sargassum biomass is to develop some biofertilizers as well as biostimulants. So we developed one such formulation and tried in tomato as well as in sweet pepper. This slide is just about only these 2 crops, but we did in at least some 5 crops. So what we found is both extracts were effective, and they were able to control successfully both the fungal as well as bacterial diseases. And here again, addition of little dose of fungicide augmented the effect. So that was reflected upon the yield also, where you can see the application of the seaweed extracts improved the yield, the fruit yield in both sweet pepper and tomatoes. And addition of fungicide always improved the yield to the highest level. Again, we did the defense pathway analysis, and we also did the RNA-seq. And here what we found is the red seaweeds were able to upregulate the genes associated with the SA pathway, but the brown seaweed was not able to upregulate the SA pathway, but the J and the ethylene pathway. So the typical observation we found with the this red seaweed is initially they were able to upregulate the SA pathway, and then after some time the SA pathway goes down and it was taken over by the JA pathway. So this is the first report where we were able to say both pathways were upregulated in a harmonious fashion. Okay. So we also, since the plants that were sprayed with these seaweed extracts were able to produce more vegetative growth as well as a reproductive growth. Here I mean more number of flowers and indeterminate growth of the plants. And we were able to see this again and again in all the experiments. We wanted to understand the mechanism behind it. And this is one such experiment where we proved that the upregulation of hormonal genes, particularly the synthesis of gibberellin, auxin, as well as a cytokinin gene, where both seaweed extracts were able to upregulate these hormonal synthesis genes. We also did RNA-seq, and I'm just giving you just one slide, which shows the DEG tally. And you can see here the upregulation of several genes, I think several hundreds of genes compared to the downregulation. Unfortunately, these upregulated genes, when we look at their function, many of them are defense related. They are related to the defense pathways. So biosynthesis of secondary metabolites, which is involved in the synthesis of defense compounds, as well as the hormonal biosynthesis, phenylpropanol biosynthesis, plant hormone signal transduction, MAPK signaling, flavonoid biosynthesis, and the phytoalexin synthesis and diterpenoid synthesis. So all these are related to defense pathways, and that explains the enhanced resistance or induced resistance of plants to different diseases, including virus diseases and also the vectors. So just to summarize, this is the integrated disease management trials we have done in all these crops at different locations in different seasons. And we have used here 8 different treatments, and these 8 different treatments are combo treatments. That means it involves the use of all the parameters, all the treatments, and the available methods possible. And particularly the amount of fungicides is substantially reduced. That means only 3 sprays for the entire duration of the crop, only 3 sprays of fungicide along with the pesticides, but remaining is all substituted by other biological methods. And we found most of the diseases were controlled to the effective level in tomato, as well as the same thing we found in pumpkin also. So these trials have been done several times, and even now we are continuing because we have another small project we got from UNDP, and that allowed us to continue these trials for several years, and we are able to see the sustainable effect of all these treatments. And since we have followed, transferred this technology to the farmers, and farmers are using it, and we are able to see the same effect over and over. So to summarize, we have recorded the prevalence of diseases, particularly the emerging diseases have been characterized. We have characterized more than 7 or 8 new viruses and several fungal as well as and the bacterial pathogens, and new vectors and biotypes are identified. I could not tell you all these things, but many of them have been published, and I'm giving you the list of papers. And the PCR-based diagnostic techniques have been developed, and those techniques have been propagated to all the island states, and we have trained the people. And We have also developed a community-based disease-free seedlings production, and we have trained the farmers. And as a result, the farmers in a particular parish, here parish means a district. Okay, so the farmers in the parishes, they come together and develop their own seedlings, and we have trained them how to produce disease-free seedlings, and that has become successful. And as I said earlier, this usage of IDM combo treatments have minimize the disease as well as the pest disease incidence at 70% or even more, and reduce the incidence of vectors and virus diseases. And the yield increase was at least 50% more than the conventional chemical methods. And there was significant improvement in the nutritional value and the post-harvest quality when these IDM treatments were followed. And we have also done, the residual analysis of chemicals. And that has helped some of our farmers who are exporting hot peppers. The Caribbean region is very famous for hot peppers, not the hot peppers what is being grown in India. In India, we are growing capsicum annum, the hot chilies, but here it is called, they belong to the scorpion pepper and the Scotch bonnet pepper, which is capsicum chinense. So they are exported all over the world, particularly to the West. And the main problem is the fungicide residue or the pesticide residue. So by this way, we are able to cut down the residue, and they are able to export this produce all over the world. So the residue in soil, water, and plant we have analyzed, and that was minimized. And we have developed partnerships between all the countries, entire Caribbean region, and they are holding up all this partnership for both the transfer of technology as well as for training. And demonstration plots have been laid, and all these technologies have been propagated to the farmers as well as the agricultural personnel. We have done so many workshops, trainings, and conferences, and also publications and media documents. So we were able to train over the years some 100 agricultural personnel, who include agricultural officers, the technical officers, and even technicians, and also 200 lead farmers representing the region. So these farmers are belonging to the countries of the Eastern Caribbean, which is around 5 or 6 countries. So we were able to go there, and also we invited them here and trained all these lead farmers. So this is just one shot of the some of the workshops we have done. We have done several workshops, and you can see here the people are learning how to extract the DNA as well as do the PCR. And you may be surprised, some of them are farmers. There are also some big farmers who are so interested, and we didn't say no for them, because they also came and then learned some of our techniques. So these are some of the references, and I wish to acknowledge all my grad students, PDFs, and our group, collaborators and partners, farmers, and the funding. The funding was provided by ACP EU, which is more than €250,000, and that was a generous funding which we are able to use for all our research projects. And the CADIR and the Conservation CFH Foundation Fund, they were able to support our seaweed research. And currently we have a UNDP project which is helping us to continue these field trials, and we are evaluating at the field demonstration phase. At the sustainable phase, we are continuing the efficacy of all these treatments as well as the IDM systems. So with that, I would like to thank, and I really appreciate your patience. I also apologize for my non-availability for the beginning of the presentation. Either I was too early or because I logged in yesterday night, but at the time a session was not at all started. So then I went to bed, and I again thank my colleague, Dr. Makesh, who gave me the call, and that's how I am able to make it. And again, I appreciate your patience, and thank you so much.
Wonderful presentation, Dr. Jairaj. I'm sure
Thank you, ma'am.
Dr. Prasoon Mukherjee must be having questions, and he will be asking.
Thank you, sir.
Yeah, how are you?
Oh, fine, thank you.
Yeah. So excellent work and presentation.
Thank you, sir.
I just wanted to know, like, what this seaweed extract might contain, which is triggering so much response in the plant.
Yes, that's a wonderful question, but I think that question costs at least some $50,000. You know, we spent a lot of money to completely characterize the molecule by molecule what is present. And I think I need, if I describe the data, it cannot be done in one slide. So I can just say, put it safely, it has different compounds that includes carbohydrates, and these carbohydrates include polysacs and oligosacs. Both of these polysacs and oligosacs have high elicitor value. So they are not the same polysaccharides what we found in the plants. They are kind of different, and also oligosaccharides. The method of extraction we employ for this seaweed is alkaline extraction. So that alkaline extraction degrade all these complex molecules, make into small molecules, and these small molecules are highly bioavailable, and they are high signal value. So the signal transduction is taking place, and these molecules are mostly polysacs, oligosaccharides, betanes, amino acids, and minor level of micro as well as macro elements, and also a little bit of heavy elements. But I want to be very careful about the heavy elements. When you collect this seaweed extract from dirty places or polluted places, they contain high level of heavy elements. So we reject those things. So what we do, we just take a small boat and then go to the deep seas and collect the seaweed. We do not scrub the seashore. But when you scrub the seashore, you don't know from where it is coming from. So there may be a little higher level of heavy metals, which I don't like. So normally, if you prepare the right way, the heavy elements are less, but these heavy elements are of high elicitor value. So these are the components. They also contain trace levels of cytokinin-like compounds. So they are not exactly cytokinins. The structure, we elucidated the structure, they resemble the structure of cytokinins, but they have cytokinin activity. But when we apply all these things, there is upregulation of the cytokinin, gibberellin, and auxin genes. So what is happening is all these elements are able to directly involve with the plant, as well as they crosstalk with the plant pathways, and that also lead to upregulation. So it is happening in both ways.
Okay, thank you.
Thank you, sir.
Over to you, ma'am.
Hello, Chairman, Madam. Hello, I am audible. Am I audible?
Yes, please.
Yes, sir. My name is in the list or not? Myself, Gayatri Vishwa. Oral presentation.
Okay, in between.
Let me check.
Please check it. And Dr. David, are you ready? If Dr. David is not ready, should we invite Dr. Subramaniam? Has he given some information, Dr. David? We'll let you know, madam. We'll let you know. Definitely, your name must be there. They'll find out. Okay, in between, they'll find out.
Thank you, madam.
Yeah, we will find out. We'll find out. Amlendu, is Dr. David available? If not, we'll go to Dr. Subramaniam.
We can go next, ma'am.
Yeah. Okay. So we welcome Dr. Professor Subramaniam. Are you available? Are you there online? Professor Subramanian? I think he's not there. Can you see in the list?
No, he is not in the list, or maybe in a different name. Dr. Subramaniam, are you online? Please respond. Ma'am, we can go to Dr. Hesam N. Sasi.
Can you inquire about him also? Is he there? Dr. NRC?
Yes, I am around.
He is there.
Yes.
Yeah. So are you ready with your presentation, Doctor?
Yeah, I can just try to share screen.
So I'll just introduce you, and after introduction, we can So Professor Enasi is the director of the Institute of Bioproduct Development, University Technology, Malaysia, and the current co-chair for Food, Pharmaceuticals and Bioengineering Division, 15A Food, American Institute of Chemical Engineering. Professor Enasi received his BSc and MSc in microbiology from Shams University, Egypt, and from Germany, MSc Technology from Malaysia. He has 2 technology patents, more than 250 publications, and in peer-reviewed international journals, book chapters and books. He was a keynote, plenary, and guest speaker in more than 80 international conferences in field of industrial biotechnology. So we welcome you, Dr. Enasi. Please continue with your lecture, please.
Okay, thank you very much, Chairman. And can now I share my screen? Can you see my screen?
Yes, yes.
Okay, excellent. Thank you very much, Chairman. It's give me great pleasure and honor for being here today. And thank you for the invitation for the Indian Phytopathological Society for this event. My name is Professor Hisham Al-Inshasi. I'm current director, Institute of Bioproducts Development. And my presentation is platform technology for large-scale production of biological control agent for fungal oil palm diseases. First, I would like just to give highlight where I'm from. I'm from University of Technology, Malaysia. We are the top 100 university in the world in terms of science and technology. We have 2 campuses, one in Kuala Lumpur, another one in Johor, where is the main campus, just 30 kilometers north of Singapore. And our faculty in engineering is ranked as 53rd in the world according to the QS ranking. Yeah, as everyone knows, we're talking about the rhizosphere of the healthy soil. We have, in terms of the rhizosphere microbiome, we have the good, the bad, and the ugly. The good microbes are those related to physiology and metabolism and supporting the plant, tolerance to abiotic stress. They support the growth and development and nutrient acquisition and protection against pathogens and immune response. And the bad microbes, those do plant disease, and the ugly one, which is thus making contamination of the food of the food in the future after harvesting. I think our colleagues in the previous lectures, the excellent lectures we hear yesterday and today, they cover most of the topic, but my contribution here to give a case study and how we cover this in Malaysia. When you go for research focus in Institute of Bioproducts Development, which is my institute, in biological control, in good agriculture practice, we can say we do microbial fertilizer for the nitrogen fixing bacteria, phosphate solubilizing and phytohormones and others. Then we do also work for biological control, which is going to cover in my presentation, using Hendersonia strain, Trichoderma, Bacillus thuringiensis, another killer yeast, Bacillus firmus, and many other strains. And also we do post-harvest research for the killer yeast and microbial bioactives. Now, when you're talking about the biological control, most of the definition, they say, what's the biological control? It's a population leveling process in which the population of one species lower the number of others. But I think most of the people don't agree with this international definition nowadays, because it's not just a matter of population. It's also have some functional characteristics beyond the number of population. And usually, frankly, say that's a biological control, it doesn't mean insect controls anymore. The mechanism of biological control, they have 4 main mechanisms. Antibiosis, which is the production of toxic compounds, mainly by microbes. Competition in terms of space and food. Then parasitism, destructive mycoparasitism. And predations, which is specialized structure and predations. When you look for the challenge, I talk now about the industrial point of view. My background initial, I'm microbiologist, but since I have my PhD more than 20 years back from Germany in industrial biotech, my job is to develop products from biological system and microbes. I'm not go in depth in microbiological study, but my target to develop products for the market. And usually our challenge are 3 main things. Number 1 is microbial factors. Second is large-scale manufacturing and formulation and the field application. When you look for the microbial factors, the microbes must be grass, according to FDA, as generally regarded as safe, adapt easily to the plant cultivation conditions because they will live in this condition, and highly specific for specific type of pathogens, and not affecting biodiversity and compete with other beneficial microbes in the soil, and can multiply easily in targeted soil under the same conditions. It's not only the cultivation condition, but the type of soil, the pH of the soil, salinity, and all those stress, the microbe can survive and can be functional. The second thing is the large-scale manufacturing platform. Can be produced under defined condition. Is these microbes, when used in biological control, can we cultivate in the lab, as we have seen in the field, or not? Because of many of microbes, when you go to the lab, you cannot cultivate anymore. Those strains, it's not industrialized. Zero risk of contamination with other microbes, then manufacturing under sterile condition, and ease of in vitro propagation and process scalability. In some process, we have limitation of scalability. Is this scale in the shake flask, bioreactor, small one, large scale? Is this beyond cultivation of 10,000 liter? They have some problems in the cultivation or not? Then formulation in the field application, the shelf lifetime and stability of the during storage. Because if we have a live product, it means we need the products to be dormant. It's not alive, otherwise go for decline phase, and not dead, otherwise it will not work. The presence of the certain nutrients to support spore germination and dormant cells growth during the first days after application. And the final products form, the question, is this solid or liquid form? Product physical characteristics and the ease of application by farmers. Then we go further now in my presentation. We have a big issues in Malaysia, which is, Malaysia is the second largest oil palm plantations in the world with 9.7 billion. I know India, they have also a lot of palm oil plantation with a very good practice, but Malaysia currently is number 2 in the world after Indonesia. And oil palm plantation in Malaysia is suffering from the huge economic losses due to basal stem rot disease, which is for Ganoderma, and almost 5% of the oil palm plantation in Malaysia are infected. And even now, this number have been increased during this COVID time because of we don't have a lot of biological control and some access limitations on some plantations. And then this number expected to be now is about 7%. And the Ganoderma oil palm disease, if you see here, this is the oil palm plant, then it's in the roots here. We have the Ganoderma, which is Ganoderma puniense, and then this is for the upper part of the plate, and this is the lower part of the plate. This is the standard microbes of the Ganoderma. The worst things in the story is Malaysia. We have a challenge of location. If you see here, Malaysia in the south a little bit, we are very close to equatorial. Equatorial, it means here throughout the year, we don't have 4 seasons. We have only 1 season throughout the year, temperature 28 plus minus 3 or 4, and humidity throughout the year more than 85%. It means we are living in the biggest fungal incubator in the world because of the temperature and humidity is the best for the fungus. This is the big challenge. Therefore, it's flourishing disease here. Biological control of the Ganoderma, we have 2 approaches. One is Malaysian Palm Oil Board, which is the biggest association in Malaysia for palm oil plantation. And they come up with the Hendersonia. They come with the Hendersonia for biological control of the Ganoderma disease. In our institute, we come with the IBD. In IBD, we have a trichoderma to control Ganoderma disease. But we work for both for our industrial partner called All Cosmos Industries Numberhard, which is the biggest company now in Southeast Asia in biological control and biofertilizers. In trichoderma is a sexual fungus. As everyone talked today, I heard an excellent presentation for many researchers about the trichoderma. I know trichoderma industry and the trichoderma research in India. I consider this one of the best places in the world, whereas we learn a lot, and we have also some collaborators there. Then environmental and industrial application, many potential industrial application, which we use for enzyme production and which used also for many processes, and agriculture application, which is widely used in biological control. to assess the antifungal properties of trichoderma in our platform, our students, they isolate trichoderma, and we find trichoderma harzianum, what's all the special strains here, we isolate from Malaysian soil, and we did the antifungal properties during 3 techniques, the dual culture techniques, bilayered culture techniques, and isolation on potato dextrose broth, and then we use the filter. I showed you here, like example, dual culture technique, we have simultaneous growth. And if you have 6 days old culture, we have this in, this is trichoderma, this is have clear inhibition, the growth of Ganoderma. And then if Ganoderma is inoculate 24 hours prior to the Harzianum, then it's flourishing a little bit because it excretes some compounds as inhibitory effect, then trichoderma cannot go further. The second techniques, bilayer techniques, we put the 2 plates on the top of each other's. And then we realized that because of the production of some volatile compounds by trichoderma, which is inhibit the growth of the normal growth and the heavy growth of Ganoderma. The antifungal activities, we do also another approach. We, after fermentation, we just take the filtrate and put in the plate. And this is with the filtrate of trichoderma, this without filtrate. We find that here with the filtrate, it's inhibited the growth. It means the mechanism of inhibition of trichoderma is volatile organic compounds plus some other compounds, which is in the medium. We go further for growth kinetics and we optimize the process in a shake flask. We start from about 6 grams per liter and we go up about 8 grams per liter through optimizing the media using OFAD, 1 factor at time, and statistical approach. And we come up with some results, but because we have industrial partner in this work, I cannot reveal all results here. But some of the results I can share with you. When we scale up the process from shake flask to the bioreactor, we go from 6 grams per liter up to doubles, about 13 grams per liter. And this was a very interesting result. And now we develop many cultivation strategies of the feed batch, controlled feed batch, and exponential feeding strategies and others. And we just giving now, we reach a number about more than 35 grams per liter under submerged cultivation system using economic medium. Then Hendersonia also came to us in our institute from MBOB because we are industrializing platform in Malaysia. And we find Hendersonia inhibit the growth of Ganoderma very well. We cultivate the process. This is the batch cultivation in the bioreactor level. And we realize here, this is the Hendersonia growth. And we cultivate the Hendersonia and we work with Hendersonia small fragment and spores, which is the products. We go to the company and we reach about 14 grams per liter. This is the primary result we reach, but after this we reached higher cell density cultivation. In our industrial platform in Institute of Bioproducts Development, we are a high CUE Institute of Malaysia, which is #1 in bioprocessing of microbial and herbal process. And we have R&D platform, industrial and 1 and industrial 2. We have our cell bank, wellness industry culture collection. We have microbiological and analytical laboratories. Then we have 5 bioreactor, 16-liter sterile tank reactor. This for R&D. Then we have industrial 1, 16-liter, 150. Then we have another platform from 1650, 1500. Then we are doing high pressure homogenizing, self-clean separators. We come up with spray drying, freeze drying. It means with this concept, we come from vials to complete powder. This is what exactly industry need. Therefore, we work with many industrial partners. This is some photos from our platform, from working cell bank, laminar flow, shake flask, 16-liter, 150-liter, 1,500-liter with high cell density cultivation strategies. And then we go for separation, spray drying, or other drying techniques. For some process, we do spray drying. Some process, we don't use spray drying at all, but we have another techniques we use in drying. Then we have a bulk powder production, which is given to the companies. The conclusion one, the challenges to produce biocontrol agents in agriculture, we said microbial factors have been covered, large scale manufacturing, what we do, formulation and the field application, what we did. Also, final products cost must be competitive. These the things what we work with is the medium composition to make it the lowest cost possible, the maximal yield possible, and the shortest time production possible. These are the 3 triangle things we are work with industry. And then we commercialize through our industrial partner to support the governments and the farmers and consumer awareness. The most interesting things is the conclusion too. which is I love to share these cartoons usually with the people. When the people use extensive use of pesticides, the pesticides and the rats say to the man who spray, do you also eat these with that mask on? Because of, this is very dangerous. A lot of extensive use of pesticide, most of them are toxic, most of them are carcinogen, and most of them also not used in the company which they produced. Like example, in many countries, in developed countries, they produce a lot of pesticides, chemicals, but they never use in their land. They just give to other country to use. I'm so pity to say that, but this is the fact nowadays. And now we need to come up with our green technology as well, local green technology to save our people, to save our soil for sustainable agriculture practice. Thank you very much. This is my institute. We have 3 buildings, 3 big buildings. I have 80 staff. They work there with the students, another about 80, another 80 students, they work in our institute, but we have different fields. One of them is biggest platform is microbial processing. And this is a management building, which is I sit in the first floor here. And you are very welcome anytime to come to Malaysia. I love too much to collaborate. Indian Phytobiological Society. I was honored to be in the board of the journal for a couple of years. And it's honor for me to continue working with our Indian partners. Thank you very much.
So with the permission of chair, ma'am, we are just a bit slow. There are another 11 presentations left. So I request all the delegates to just stick to the time and finish your presentation within the stipulated time. Chair, please.
Dr. Prasoon, I would request you to please continue my presentation. I'm going in another session. Can kindly continue with the help us with this presentations. Ma'am Lendu can help you.
Okay.
Yes.
Okay, no problem. Sure. Yeah, Dr. N. Sasi.
Yes, please.
Yeah, I have a question regarding Hendersonia.
Yes.
What type of fungus is it and what is the mechanism of action? Like, can you throw some light?
Yeah, actually it's still under investigation for the deep mechanism of action, but they produce some antimicrobial compound actually against the Ganoderma. It's not just competing with the nutrients, but what is
the taxonomy of this?
What?
Which class it belongs to, like fungal? What type of fungus is it?
Yeah, Hendersonia classification is not in my mind now, sorry. But because of this strain given to us from research partner, and we are industrialization partner for this.
Okay, fine. Okay, thank you.
Thank you.
Yeah, I think we should go to the next speaker. Hello? Yeah, please stop sharing your screen.
Hello.
Yeah. We should move on to the next speaker here, please.
Yeah, so this is the end of the keynote lecture. Although I can see Dr. David is late, we have not received a presentation from Dr. David. So if you can share from your side, you are welcome, sir.
I think Dr. Amlendu better.
Yeah, so we can move on. Sir,
can you hear me?
Yeah, you can.
Please.
Can you hear me?
Yeah, please.
Yes, can you hear me? We have some technical problem here, but I will send the slides within the next 10 minutes or 5 minutes.
Okay.
All right.
We will take next presentation.
Okay.
But you can share from your side also, no issue. Okay, so by that time we can move on, and with the permission of the chair, sir, in the last session, one presentation could not be that time executed. So with your permission, sir, I would like to invite Dr. M.S. Jadhav from NCIPM.
Oh yeah, please.
Okay, IPS Secretary. IPS Secretary. Can you hear me?
Dr. David is here.
Hi, David. You are not audible.
I think he's muted.
Unmute, Dr. David, unmute yourself.
Hello.
Yes, please.
I'm sending it to IPS email.
Yeah,
is that okay?
Yeah, that is okay, please.
All right. I'll do that just to
Dr. Jadhav.
Hello, may I start?
Sir, please proceed.
Respected Chairman, my topic is biointensive strategy for sustainable management of disease of Brassica gentiana. And this is a field scene of a on-farm trial in which this sclerotinia on the leaf in control treatment as shown. So economic importance of mustard oil. Mustard oil is the world third most important source of edible oil after soybean and palm oil. And mustard oil is second most important consumable edible oil in India, and it contains essential fatty acids and the richest source of omega-3 alpha-linolenic acid. It also excellent source of essential B complex vitamin, folate, niacin, thiamine, and pantothenic acid. Then economic importance of mustard crop. India is the fourth largest edible oil economy after USA, China, and Brazil. India is a major importer of edible oil, and approximately 15 million tons of edible oil is imported in India. And for this, India spent more than 60,000 crore annually to augment the domestic supply. So mustard contribute more than 30% in edible oil production in India, and area under mustard in India is at present 6.12 million hectare, and production is 9.2 million tons, and productivity is 1.5 ton per hectare. So Brassica gentiana predominant and account for 80% of area under rapeseed mustard crops. So these are the important diseases of mustard. And number one is white rust, sclerotinia rot, alternaria blight, and sometimes this downy mildew, powdery mildew, and bacteria rot also occurs. So this sclerotinia rot caused by Sclerotinia sclerotium and white rust caused by Albugo candida and alternaria blight of mustard are emerging disease problem, and they combined cause losses up to 50%. In recent time, non-chemical agents are being propagated for management of plant disease to overcome the harmful effect of chemical pesticides. And now these existing control measures are application of chemical fungicides, which are often cost prohibitive, impractical, and hazardous to environment and human beings. Keeping this in view, need was felt to an alternative method for management of these diseases in eco-friendly manner by using microbial bioagent and plant extract. So objective of this study was this on-farm trial at CCS HAU Regional Research Station Bawal was to develop biointensive strategy for sustainable management of disease in Brassica gentiana. So what is this biointensive disease management strategy? Many aspects of field and crop management reduce the sources of primary inoculum. And these crop hygiene and various agronomic practices are major tools for prevention of such disease like deep summer plowing, soil solarization, elimination of weed host, regional specific crop rotation, cleaning of crop refuge, nutritional management has a very important roles, water management, regional specific recommended variety and hybrids, seed treatment, soil incorporation or green manuring of bioagents, and intercropping or mixed cropping. And overall, the regular monitoring is very crucial for disease management, as it is one of the most important decision-making tools. So this is number one disease, Sclerotinia rot. It can cause up to 40% loss, and the symptom of this lesion on the leaves are grayish, irregular in shape and size, and often associated with the petals. When there is a petal occurrence, then this disease start. This disease start after flowering. And this sclerotinia rot appear as a elongated water soaked lesion on stem, which are covered with cottony mycelial growth of this fungus. And these are the apothecia form under natural condition. And black hard sclerosia are seen in the stem when we split it. Then number 2 is this white rust. This white rust disease cause up to 34% loss in yield, and disease appears as a prominent creamy pustules. This type of pustules on the undersurface of the lower leaves. And at the time of this flowering stage, these type of stag heads are formed, and this is a field scene of a these are due to this climate change, these are occurring very frequently in last 2-3 years. This is alternaria blight. It is occurs throughout the world, and it can cause up to 70% of losses. It is characterized by formation of brown color, concentric rings on the leaves, stems, and also on the pods. Moist and warm weather or alternate period of rain and sunshine favor the development of this disease. And this pathogen survive on the soil on the affected plant debris. So keeping all these in view and the background of these 3 diseases, this experiment was laid out at CCS-HCU Regional Research Station, Bawal, Rewari, and RS30 cultivar were used, RBD design, and plot size was 5 by 5 meters. And these are the 3 different treatments. T1 was the soil incorporation of trichoderma at the rate of 2.5 kg per hectare plus seed treatment with Trichoderma viridi 10 gram per kg seed, and 2 foliar spray of freshly prepared aqueous garlic bulb extract at the rate of 2% at 45 and 60 days after sowing was applied in treatment 1. In treatment 2, it is a chemical based treatment and seed treatment with carbendazim 60 WP at the rate of 2 gram per kg, and seed 2 foliar spray of carbendazim at half strength 1 gram per liter of water at 45 and 60 days after sowing. This is a standard control, or this is in the package of practice of this zone, so it was kept as a standard control. And third is without trichoderma soil incorporation, seed treatment, and foliar spray. And white rust and alternaria blight on leaf were observed as per Kohn et al. 1990 0-9 scale. And sclerotinia stem rot was recorded as percentage incidence on the stem, percentage incidence of sclerotinia rot on the stem. So these are the results. So effect of different fungitoxicant on disease severity and seed yield of mustard. So for sclerotinia rot, this T1 give the lowest disease, and all the 3 treatments differ significantly. For white rust also, this biointensive trichoderma and garlic clove based treatment was found better, and yield was maximum in these treatments. And these are the 3 different treatments. So out of these 3 treatments, this T1 soil application of trichoderma viridi and seed treatment with the trichoderma and 2 foliar spray of freshly prepared aqueous garlic bulb extract was found significantly superior over chemical control in reducing the sclerotinia, white rust, and alternaria blight of Indian mustard. And minimum disease incidence of sclerotinia rot 11.9%, and disease severity of white rust 34.3%, and alternaria blight about 30%, and maximum seed yield of 2400 kg per hectare was found in T1 in comparison to corresponding value of 20.5 and 49.4 and 44% in control. And yield was also reduced in untreated control, and seed yield was significantly superior in this biointensive trichoderma based treatment than the chemical control methods. So on the basis of this study, we can conclude that soil incorporation of trichoderma viridi pre-incubated in 50 kg well-rotten farmyard manure before sowing, and seed treatment with trichoderma viridi at the rate of 10 gram per kg seed, and 2 foliar spray of freshly prepared aqueous garlic bulb extract at the rate of 2% weight by volume at 50 and 60 days after sowing was found very much effective. This biointensive strategy was found better as compared to chemical control treatment. Besides, it is also eco-friendly. And biointensive strategy could reduce the excessive use of chemical pesticide and favor the adoption of integrated disease management module, as well as agricultural practices that help restore the natural condition for survival of beneficial microbiota. So this was my short presentation. Thank you. If there is any question, you are welcome.
Thank you, Dr. Yadav, for a very nice presentation. Nice to see that it's working trichoderma against sclerotinia also in the field. I will think we are running short of time, so one question may be from the audience. We can take one question.
Yes, sir.
Could I just ask one question? So,
yeah.
It's very nice presentation, Dr. Yadav. Just wondering, the application of trichoderma in soil or as a seed treatment. So you reckon the disease control is because of hyperparasitism of sclerotia in the soil, or whether it prevents the ascospore infection via pathogens?
Yes, ma'am. This trichoderma is very much effective when we applied it as a incorporation in the soil before sowing, and we have did farmer field trial also in more than 500 hectare, and we have conducted a trial on this trichoderma based treatment at 3 locations, at Rari, Jaipur, Rajasthan, and at our own farm and Indian Agriculture Research Institute. And for the kind reference, this paper was also published in Crop Protection in 2019, and it was concluded that this trichoderma based treatment are very much effective for control of these fungal disease of mustard, that is sclerotinia rot is #1 disease, and this white rust is also due to climate change becoming an emerging problem, and alternaria blight is a worldwide problem, and it is also found effective in management of this alternaria blight also.
Okay, thank you so much.
My question was the seed treatment that you used. So
yes, we have also calculated the economics of this seed treatment, and if it is available in very low quantity, then we can do only seed treatment, and if this is more amount of this trichoderma is available, then we first advise pre-planting incorporation in the soil is a #1 found best. And if it is not available, then seed treatment is also very much effective. It protects the crop from pathogen up to 30 days.
Okay, thank you so much. I think we should move on to the next speaker. Hello.
Hello.
Please move on.
Yeah, let's go to the next invited speaker is Dr. Lata Nain, Principal Scientist, Division of Microbiology, Indian Agriculture Research Institute, New Delhi. She will talk on mitigating environmental pollution and improving soil health using fungal resources.
Dr. Lata, please.
Please.
Is she online?
Yes, I am there.
Okay, fine.
I am here.
So, ma'am, please conclude by 10 minutes.
Yes, sure. Thank you very much to IPS to provide me this opportunity to present my work. And hello, everyone. This is regarding using fungal resources for mitigation of environmental pollution and soil health, improving the soil health. As everybody is talking about disease and the different topic, how we can use fungal resources for that bettering the environment. So this is regarding the slide showing how much annual generation of biomass is there in India, and around it is 700 million tons. And out of that, sugarcane is the main contributor. Then comes the rice and wheat, and the cereal contribute around 70% to biomass, and out of that, rice is contributing 48%. And because of mechanical harvesting, most of the time farmers has less time, so they are going for burning, which is creating a lot of environmental pollution in and around Delhi, and it is major area of concern. So what we can use this agro residue for? So first of all, we can go for composting, which can be used for farming and bioremediation. We can also produce bioethanol from this feedstock, and we can also use this agro residue as a substrate for the industrial production of prebiotic, probiotic, and indigenous enzyme for biofuel production. So this how we can use these resources for second generation biofuel. In this case, because all the biomass is mainly consisting of lignin, hemicellulose, and cellulose, and lignin is a aromatic polymer, so it is very difficult to degrade. So first step is to remove the lignin with the help of white rot fungi or biochemical treatment. And these hemicellulose, cellulose may be hydrolyzed with the help of fungal enzyme, hydrolytic enzyme, and finally xylose, pentose sugar, and glucose hexose sugar are obtained. So there are three bottlenecks in this process. First of all, how the delignification is carried out most of the time by using LPE, which is generating lot of toxic effluent. And second step, saccharification, is by commercial enzyme, which is very costly, and mostly 40% of 40% cost is involved because of the enzyme cost. And last, that bottleneck is that most of the yeast are either using hexose or pentose, so co-fermenting yeast should be there. So I try to address these issues, and this slide is showing that how the cell wall structure is very complex, and the three steps are there: pre-treatment, saccharification, and fermentation. Fermentation may be of three types: by separate hydrolysis and fermentation, simultaneous saccharification and fermentation, and consolidated bioprocessing. And in this case, this most of the time it is physical treatment, chemical treatment, physicochemical treatment, all are energy consuming processes. So the main purpose of this treatment is to improve the surface area for enzyme attack and that microbial attack. So we try to use biological resources, mainly white rot fungi, for biological treatment of the residue. This is after the screening many fungi, we came up with that 4 fungi which were very promising in terms of biological delignification. One is Trametes hirsuta, Myrothecium rhododum, Marasimellis parmivorus, and one Actinomycetes Streptomyces brisirubin. We did the delignification process for 5 to 7 days. After that, to this biological treatment, we washed the material with mild alkali, 0.1 normal never, and then extract was obtained, which was acidified to recover the liquid. And the lignin, at least 50% lignin is removed by this process, and the pre-treated biomass was taken up for saccharification and production of fermentable sugars. This we confirmed that delignification has taken place by that mainly electron microscopy. And in this case, the fungus was able to remove the silica particles from the biomass and started colonization and making the holes and pores for the action of enzyme. We also carried out FTIR, and FTIR we found that major syringel component of lignin are being removed. Similarly, XRD also proved that the crystallinity of cellulose is reduced. To finally confirm that lignin is removed, we stained the material with KMNO4, and that amine is especially binding with lignin, and after biological treatment, the amine peak is not to be seen. That means the indirect evidence that lignin has been removed by white rot fungi. Second step is the saccharification, and we try to develop some indigenous enzyme cocktail And finally, we selected FOMA, Aspergillus niger, Terrius, and Aspergillus oryzae. And FOMA was found to be deficient in beta-glucosidase. Aspergillus niger SS3 was a Cargill isolate, which was psychotolerant fungi, was able to go at 15 degrees centigrade, and temperature for sacrification was 30 to 40 degrees. This was very good result because most of the enzyme work best at 50 degrees, and this was working at 30 to 40 degrees and reducing the energy which is consumed during sacrification. Similarly, Terrius, Aspergillus Terrius, was also very good for cellulase and gynogenous production. We tried to mix the secretome of these two, and we found that if we are mixing that SS3, Aspergillus niger, and CM20, Aspergillus Terrius, we get good amount of total sugars by sacrification. This we also carried out gymography of the secretome, and this shows that many isoforms of different enzymes were present in all these fungi. The secretome was also analyzed by LCMS, and we found that around 52% glycosyl hydrolysis are present, which are responsible for the reconstruction of cellulose and hemicellulose. Then Aspergillus Terrius again was the conditions were optimized for the production and maximization of synthesis enzyme, and we found that around 56% were glycosyl hydrolysis, having a mixture of different type of glycosyl hydrolysis, and 6% substrate loading was found to be best in terms of sacrification. Then finally, this psychotolerant Aspergillus niger was also taken up for enzyme production in secretome by mixture design, and in this metaproteomic analysis revealed that there are at least 10 to 15 type of glycosyl hydrolysis are there, and mainly consisting of glucosyl hydrolysis 3, which are mainly responsible for the cleavage of beta-1,4 linkage. And the final sacrification, after sacrification, fermentation was taken up at the fermenter level, and we could generate around 4.6 gram per liter of ethanol by using the biologically deliquefied material. These are some of the publications, and then we this was a chance discovery that this white rot fungus, this mushroom type, was growing on acacia roots in my house, and I brought it to the lab. We isolated Legorobasidium acacicola L1, which was able to decolorize the dyes, reactive dyes, within 4 hours without any intermediate, and this was a very good discovery because most of the time lignin, this removal or color removal is needing some intermediate, and in this case it was not desired, and within 4 hours it was decolorized. Then these fungal resources were also used to develop a compost nutland, and we tried to develop a consortium because a single fungi is not having all sort of enzyme which may degrade all these the polysaccharide like lignin, cellulose, and hemicellulose. Finally, we could get the 4 fungi which were capable of this degrading lignin as well as cellulose and hemicellulose, and this consortium was developed as compost nutland, which was also used for the bioconversion or the farm agro waste of IRI, and resulting in the saving of money. These are the publications from this work. And then finally, there is a concept given by Professor Turihaga that if we are using lactic acid bacteria, yeast, and photoautotrough along with the decomposing microorganisms, we can increase the efficiency of degradation. So this we try to isolate different fungi as well as bacteria, Phenarchaeopteris, Sporium candida, Tropicalis, Lactobacillus, Streptomyces, photosynthetic Rhodobacter. We developed the compost, and this was being used in different flower crops and tomato, which increased the shelf life and waste life of the flower, and yield also increased, and we can replace at least 50% of whatever the recommended dose of fertilizer there, and most of the time it was 20 kg per hectare, which was supplemented in the soil. Finally, for in situ degradation, we try to find out different type of fungi which are coprophil in nature, and it is very important because if we are using any pathogenic fungi or invasive fungi, in future there may be problems. So we selected Coprinopsis and Cythus, and they were found to be compatible. We developed a compost pest formulation and used in the field, and different hydrolytic enzymes were estimated in the field at different time intervals. And we found that T3 treatment, where straw was retained with microbes and urea, was doing perfectly well, and all the enzymes were highest in this case at 15 to 30 days after inoculation. The carbon dioxide evolution also was found to be highest at 15 days. That means the maximum degradation takes place from 0 to 15 days. And there was a 19 to 20% increase in grain yield of wheat. And we also found that soil health also improved in this case. This is the publication, and special thanks to my colleagues and students and SRF, and funding from different sources by which I could carry out this work. Thank you IPS, to give me this chance to present.
Thank you, madam. Very interesting and extensive work. How much you really get ethanol from one dry weight basis from rice straw?
Actually, we from 10 kg we can get at least 3 liters.
10 kg, 3 liters. Okay. Okay. Any question from the audience?
Sir, question can be written in the chat box. And
okay, fine.
So the next speaker is Dr. A.K. Chaudhary, Professor and Head, Department of Plant Pathology, UVKV Kuch Bihar, West Bengal. Dr. Chaudhary, are you online?
Yes.
Yeah.
So Dr. Chaudhary will speak on the disease dynamics and associated soil health parameters in rice wheat cropping system under conservation agriculture. Sir, please proceed.
Is it visible?
Yeah. Yes, perfect.
Oh, okay. Okay. Honorable Chair and Rapporteur, I first acknowledge to Indian Phytopathological Society for giving me this opportunity to share our ideas. That is the disease dynamics and associated soil health parameters in rice wheat cropping system under conservation agriculture. I think this is the only paper under conservation agriculture. So that's why I will try to finish it within 10 minutes. But however, I will give brief introduction about the conservation agriculture, particularly for the students. We know, everybody knows that we'll have to feed 9 billion people by 2050, but this is not a simple task. There are many challenges. One of the important challenges is the natural resource depletions, climate variability, high cost of inputs, and volatile food prices. Whether our excessive tillage is stealing our soil, we know that due to the intensive tillage, soil erosion is there, degradation is there, runoff is there. And during the climate vagaries, either we experience the crop failure or low produce. And another important thing is the labor shortage everywhere. So again, if we remember in 2018 at Delhi, from 2nd to 3rd May, we observed that high velocity dust storm swept across the North India, and more than 125 people died, and over 200 people were injured. But this dust bowl phenomenon of the dust bowl was not new. We get records in 1930s also, and if we see the Plowman's Folly that was written by the Faulkner in 1945, we see these photographs. So under these circumstances, now the conservation agriculture has come into the process, and according to the FAO, this is an approach to manage the agro-ecosystem for improved and sustained productivity, increased profits, food security, while preserving and enhancing the resource base and as well as the environment. It is characterized by 3 interlinked principles. One is the minimum soil disturbance, second one is the permanent soil cover, and third one is the crop rotation or intercropping. Why conservation agriculture is now becoming important? We know all these things, that it can conserve natural resources, it can reduce the global warming by acting as the carbon dioxide, saves times and fossil fuel by 30 to 40%, improves yield, controls soil erosion, low production cost. But what about the disease? will be disease will increase or decrease? I'm coming in my subsequent slide. Another, if you see the conservation agriculture area, you will find that globally it is 180 million hectare, and in Asia it is 13.93 million hectare. And among the major share comes from the Latin America and also North America. In India, the data is not well documented. However, it has been observed that more than 2 lakh hectares are under conservation agriculture. And another important thing is the rice wheat cropping system. We know that this rice wheat cropping system extends from India up to Bangladesh, Nepal, and Pakistan. And it occupies 13.5 million hectare, and this is the world largest production system. Okay, and in India alone, the rice wheat cropping system occupies 10.5 million hectare, and it contributes 40% of the country's total food grain basket. Regarding pathological point, you know that keeping the crop residues under no tillage condition may have an impact on the incidence and severity of the soil and residue-borne pathogens. Generally, what happens, the tillage practices change the physical as well as the chemical properties of the soil, which in turn influence the survival and multiplications of the plant pathogen. And we all know this microenvironment plays a major role on the pathogen as well as the antagonist. Please remember the antagonist also. And mostly the pathogen activities are increased under no-till condition, and sometimes it may be the major constraints for profitable farming. Generally, the reduced tillage changes the soil temperature, particularly decrease the soil temperature, increase soil moisture, changes the root growth, nutrient uptake, and also the population of pathogen vectors. The decomposition of the plant residue lead to the phytotoxin release and also stimulate the toxin producing pathogen, which predispose the plants more to the pathogen attack. Again, where the organic matter is more, you will find that some disease suppressive soils also there due to the competition effect. And another interesting observation was made by Giller in 2015 that due to the practice of the no tillage, the earthworm population increases. And this earthworm, due to the higher level of soil organic matter, and this earthworm reduces the Fusarium carbonarum in wheat. But there are many conflicting reports. Some reporting that disease is higher, and some are claiming that disease is less. Disease is higher, like in Septoria TTC, Septoria nodorum. I'm stressing on the particularly talking about the rice wheat cropping system, Rhizoctonia solani, Pythium species, Ericipi graminis. But some reports that disease is less, particularly for the spot blotch pathogen, Fusarium bipolaris sorokiniana, Fusarium carbonarum, and Fusarium avicenniarum. The possible reasons they have depicted that either due to the increase in soil moisture and disruption of the spore movement from straw to cork by large amount of straw. Again, many conflicting reports are there. Another important findings was made by the Sester and his group that they told that the presence of a soil cover will change the soil nitrate and ammonium content. And the degradation of the crop residues left in the soil under no tillage cropping system is a source of silicon. And we all know that this silicon improves the rice tolerance against the blast disease. Now, I'm coming to our experience. We are working since 2019 with the fund support from the CIMIT, ICARDA, Australian Centre for International Agriculture Research, ICR, and DVT. I'm not giving the data due to the time constraint. The data are huge. I am giving only the salient findings. The salient findings was based on more than 400 permanent participatory trials, and each trial was of 1 acre. The first findings is that disease and yield apparently seems independent of crop establishment method in most cases. However, CA, particularly the conservation agriculture, has a marginal yield advantage. In the initial year, what we have experienced, that disease is more, both in rice and wheat diseases, particularly the bipolar sorokiniana and Rhizoctonia solani, under no-till condition than conventional tillage. But with the time, after 3 years, we find what we have got, that the gap has been reduced, and sometimes no significant difference between the diseases in CA plots as well as the CT plots. When we assay the microbial activity and diversity, we observed that dehydrogenous activity, the microbial biomass carbon and acid phosphatase was more in conservation agriculture. We have observed the biological fingerprints and then conventional tillage. Regarding varieties, we don't find any difference. We have tested more than 50 varieties of rice and more than 100 varieties of wheat, and we don't find any difference between the CA plots and CT plots. We have estimated the survival, we have assayed the survival of the bipolar sorokiniana in residues of the wheat, and we observed that the population decreases during the hot summer months, but after the October, their population increases both in CA plots and CT plots if we keep the residues. Okay, so it has been shown to be positively correlated with bright sunshine hour and evapotranspiration, and it was negatively correlated with temperature and relative humidity. Regarding the survival of the seed blight pathogen, as what we observed, that obviously in no-till plots, their mycelial viability was higher than conventional tillage, and it is positively correlated with relative humidity, particularly the maximum relative humidity, and negatively correlated with temperature, bright sunshine hours, and evapotranspiration. We have assessed the soil populations of the Trichoderma and Pseudomonas fluorescens in most of the plots, and we got a large number of populations of Trichoderma and Pseudomonas in the CA plots after 3 years of continuous practice of conservation agriculture. We tried to reduce the disease in situ condition, as well as also another approach we have taken, that is the residue management. When we apply Trichoderma on residues or any fungicide, we got excellent result to reduce the pathogen population. So in conclusion, I can say that conservation agriculture is a new paradigm in the farming practices throughout the world, and the adoption of the conservation agriculture was mainly due to the wind and soil erosion faced by the farmer. Besides this, the excessive cost of energy and production inputs prompted the farmers to adopt CA without yield penalty. Yield is the most important thing. And second one is the agriculture practices having the presence of the crop residue as a plant pathologist, you all know, in the soil surface. They provide the residue and soil-borne microorganism, including plant pathogen, with a favorable habitat. Okay. Again, several diseases were reduced. I have already given under conservation agriculture practices, mainly due to increase in the population of the soil antagonistic microflora and improved soil health. And that increase in the disease severity due to the residue pathogen may be tackled with additional control efforts like disease control chemicals, biological control, and host plant resistance. But to improve the sustainability of conservation tillage from a plant pathology perspective, more knowledge is required on pathogens, microbial interactions with residue, and also on the direct effects of reduced tillage on host pathogen interaction in different environmental conditions. I acknowledge the fund support from different organizations, and last 2 years we have started our publication. These publications are not only solely based on the plant pathology, agronomy is there, soil science is there, economics is there, and we have been able to publish our findings in high impact journal like Renewable and Sustainable Energy Review, which has the impact factor of 10.56, or Journal of Cleaner Production, impact factor having 6.395, soil research from CSIRO, field crop research. Even I have written on review also, Recently, our one paper has been accepted in Frontiers in Science. That's all. Thank you. Thank you, IPS, for giving me this opportunity.
Thank you so much, Dr. Apurva Chaudhary. It's very interesting, and then, a very good beginning has been made. Long way to go, and I think this will be the practice of the future. Thank you so much. I don't think we're taking any questions, so we'll move on to the next speaker.
So with your permission, now we can call Dr. David Olufolaji.
Yeah, sure. First take questions, then you start. If anybody asks the question.
No, there is no question.
Okay, thank you.
Dr. David, will you talk yourself, or I need to play the recorded slide?
Okay. Which one do you want? Can you put the recorded slide?
Yeah, let's see.
Okay, let's see.
The impact of biocontrol of plant diseases on increasing food crops in Nigeria, Sub-Saharan Africa, by Olufolaji DB and Fakoya S, Department of Crop Soil and Pest Management, Federal University of Technology, Akure, Nigeria, and Department of Biological Sciences, Olusegun Agagu, University of Science. What is biocontrol? Biocontrol is a method of controlling pests and plant diseases using other biologically active organisms, such as microorganisms and botanicals. In Sub-Saharan Africa, crisis caused by plant diseases has been very overwhelming. This has led to huge loss to the local agrarian community and has negatively affected the standard of living in their domain. Due to their living conditions, the usage of more advanced disease control methods have been too cumbersome for them due to their level of education. Two methods that are commonly used in biocontrol of plant diseases are the use of antagonistic fungi and the use of plant extracts from botanicals. Very prominent antagonistic fungi that are commonly used in Nigeria are Trichoderma species, cowpea shaku rot caused by Microphomena fasolina as a pathogen can be controlled with Trichoderma asianum. You can now see in this slide the impact of shaku rot on cowpea from the stem and branches then down to the leaves. Then you can now see that the lower leaf and this part looks as if it's burnt, and that's why we got the name from shaku. It looks like shaku. Control of black rot disease of okra with Trichoderma asianum is another example of the impact of Trichoderma in controlling plant diseases. Control of Sphaerotium rossi, the rot fungus of tomato, using Trichoderma and Sphaerotium is another good example. You can see the okra, the black of okra on the watch, that is the fruit, and also the speck of black on the leaves of okra. You can also see the impact of Sphaerotium rossi on the fruit of this tomato. You can just imagine the farmer has this. It's not an interesting thing at all. It has devastated the fruits. Trichoderma species possess some attributes which are empower them in carrying out microparasitism on fungi. This also invariably prevents the pathogenic fungi from causing crop diseases. Trichoderma asianum exhibits the aspect or activity of mycoparasitism on Microphomina fasulina. What we are seeing here is the prophylactic way of carrying out the mycoparasitism. The Trichoderma asianum and Microphomina fasulina, they were treated on this place, this cigar at the same time. But as time goes on, you see the Trichoderma asianum expanding and pushing the Microphomina fasulina until
Hello. Hello, Secretary. Hello?
Yeah, I think the audio is gone.
It seems as if the pre-recorded one is not good enough.
Audio is not coming.
Yeah, audio is not coming.
Audio is stopped, I think.
Please check this one.
We have lost the voice.
Yeah, Dr. David, can you narrate yourself?
Yeah, that's better.
Okay. Just hold a minute.
Onward this slide, he can present.
It's as if I've lost the voice.
Yes, Dr. David, please, you present yourself now.
Dr. David, please.
Dr. David.
Dr. David, could you start from this slide?
Can you please speak by yourself? Yeah.
It seems as if we have lost the voice. Do you want me to start here or start from the beginning?
No.
From here?
From here, from here.
From here, okay. You know, we're talking about productivity in plant disease or in plants. Germination and seeding establishment is very important. You can see now from here the impact of trichoderma on germination and seeding establishment here. And you can see the control in which we have the germination percentages and seeding establishment percentages. The one with the highest concentration of conidia, concentration of T. asianum, they were not significantly different from one another. Next slide. Okay, where we are looking at the severity. The severity of Charcot rot on cowpea is so devastating. But now, when you increase the concentration of T. asianum, you discover that as the concentration, as the term progresses, the severity is reducing. In the control, you can see that the severity is so much, which means Trichoderma asianum is playing a major role in reducing the Shakuro disease on cowpea. Where the use of botanicals also dwells on extraction of active principles. You know the active principles? Like the active principles, the use of botanical dwells on the extraction of active principles. You know, we have essential oils and extract from botanicals that are used prophylactically and through curative means. Examples are as a director indica in controlling quadriforal wet rot of amaranthus. Also, brown blush of cowpea will be controlled by essential oils from Melina arborea and Zigibe officinale.
I think next slide.
Just indicate me when you want the next slide.
When we're talking about yield in cowpea, we talk about pod per plant and seed per pod. Here, the control aspects of Shakuro on cowpea, as per the impact of thiazianum, an essential oil from A indica, and extract from A indica 2, they play a major role. But you discover that comparatively with mancozeb, the official fungicide, thiazianum ranks close to mancozeb in the control of Shakuro disease of cowpea. Where advantages of our control strategies, you know, they are environment friendly, non-pollutants, easily biodegradable, non-phytotoxic, non-mammalian toxic, low and not residual effects, and easily applicable, and the cost of application is very low too. And these aspects are the aspects that we take into cognizance when we're talking about how to produce safe food for the teeming population of sub-Saharan Africa. Also, one of the advantages of bio control is that it conforms with the Environmental Protection Agency guidelines, that is safe food for common man by non-chemical, non-phytotoxic, easily biodegradable. All these are the things that are clamoring for by Environmental Protection Agency to produce safe food for human beings. However, biocontrol has some negative effects, which are just impact on the non-target and beneficial organisms in the agroecosystem. When they are used, sometimes they affect even the organisms that are not targeted, and thus they affect the agroecosystem negatively. Where comparatively with the chemical control and some other control, the slow speed in which they confer control actions when compared with chemicals and other methods, they are very slow. But what we are looking up to is the not easily biodegradable aspects, that they are eco-friendly in the environment, and this one will be beneficial to farmers on the field.
Next slide, next slide.
When we look at the impact of the use of biocontrol on the economy, social, and standard of living, the impact has positively increased the quantity and quality of farm produce, which are safe for human consumption as against most chemical control strategies. What we are saying here is that the impact of that particular mode of control of plant diseases, as per what we have seen as the advantages, they are economically viable and they are more beneficial to farmers And also, the social life of the farming communities will improve tremendously when they use biocontrol strategies. Since most of our research here could be diverted to the attention of the farmers should close to agri research extension officers who will go around to educate them about these biocontrol strategies against crop diseases. And we also advise farmers to follow the directive given to them by these extension officers as per biocontrol strategy results, because they are the people that will go to the farming communities and interact with them so that they can use the biocontrol strategies. They should also monitor the farming, their farms, so that at the end of the day, they will be able to know if there is any problem. If there is any problem in their farm, they should be able to liaise with the extension officers so that they can guide them on how to control or how to ameliorate the problems. In conclusion, biocontrol has enhanced increase in food productivity, sustainability, as well as improved food crops. What we mean here is that this biocontrol aspect in disease control is sustainable because of easy access, the advantages we have in biocontrol activities or strategies. They are sustainable because most of those materials that we use, they are available in our environment. Most of the time you don't buy them and they are easily approachable. Also, we discovered that the biocontrol strategies has also improved the livelihood of the farmers and the economy of Nigeria in sub-Saharan Africa.
Thank you so much, David. I don't think there is time for questions, so let's move to the next speaker.
Yes, we have some
behind. Yeah. Over to the organizers, please.
Come again.
Just wait for a minute.
We can continue with the other person.
Okay.
Yes. I'm listening.
There are no questions, we can continue.
Okay, ma'am. So the next presentation is by myself.
Yes.
And so just hang on for a minute. I just prepared the system.
Come again. I can't hear your questions.
There is no question, Dr. David. So thank you for your nice presentation.
Okay, thank you very much. Thanks for listening.
Is the slide visible? Is the slide visible, ma'am?
Visible, doctor. Visible.
Hi, good afternoon. I am Amalendu Ghosh from IRI New Delhi, and I'm presenting how we can control the transmission of chili leaf curl virus by simple application of double-stranded RNA targeting the hits of protein 70 gene of its vector Bemisia tabaci, that is whitefly. I'm sorry, I'm a bit low in energy. Since morning, I'm regulating this presentation. Okay, so now we all know that chili is one of the important crop in India, and we earn more than $300 million annually through the export of the chili, and chili leaf curl virus is one of the major constraints in the production. The most common approach to manage the chili leaf curl virus is to manage its vector whitefly Bemisia tabaci by insecticidal application. But the recent epidemics in Maharashtra, Madhya Pradesh, Andhra Pradesh showed us that insecticides are largely ineffective against the whitefly that quickly develop resistance against almost all classes of insecticides. At the same time, there is very limited host plant resistance. If we see the Bemisia tabaci begovirus interaction, the relation is persistent circulative type. That means once the virus is ingested, it comes to the elementary tract of the whitefly, and the major interaction takes place in that midgut, and the virus particle cross the midgut epithelial barrier to become circulative in the hemolymph. And from the hemolymph, it reaches the salivary gland. Once it reaches the salivary gland, it comes out with the fresh saliva to infect the healthy plant. There are several proteins that bind to the begovirus port protein in the midgut of the whitefly. And this is a novel approach if we can entrap this intra-relationship of Bemisia tabaci and the chili leaf curl virus by novel means. And one of these interacting protein is the hits of protein 70 of the Bemisia tabaci. In our initial study also, we recorded very high upregulation of the HSP70 of Bemisia tabaci post the acquisition of the chili leaf curl virus. In other studies also, begovirus CP and HSP that are co-localized in vitro and also in the midgut epithelial cell. So we targeted to knock down the Bemisia tabaci HSP70 by RNAi and see the effect on the transmission of the chili leaf curl virus. To do so, we use the Bemisia tabaci cryptic species SCR21 chili leaf curl virus isolate and the chili plant variety PT from non-Ms, and the HSP70 dsRNA of around 128 BP size was designed using the siRNA wizard without any cross-reactivity with that plants, mouse, rats, rabbits, human beings, and butterfly and ants. It was synthesized in vitro through in vitro transcription in LTP40 expression vector and transforming the HT115, and dsRNA was purified using DNase1 and the RNase treatment. Now, in the first stage, we evaluated this HSP70 dsRNA under controlled laboratory condition, and we standardized one artificial feeding system for the Bemisia tabaci adult, through which the HSP70 dsRNA was orally delivered to the adult whitefly at different concentrations, starting from 1 to 3 microgram per ml. And we recorded a very high mortality of around 82% post the exposure to the dsRNA at 24 hours. However, we did not record any morphodeformities in the killed whiteflies. Also, the effect of the dsRNA, we record that HSP70 mRNA expression was downregulated by around log 12 fold post the dsRNA exposure. And we also tried to see if there is any effect of the HSP70 dsRNA on the acquisition of the chili leaf curl virus copies by individual whitefly, and what is its effect on the biological transmission of chili leaf curl virus. So what we did, we used the whitefly that was survived post the dsRNA treatment, and adults were exposed to the chili leaf curl virus for 24 hours acquisition of the chili leaf curl virus, and then the virus copies was estimated in individual Bemisia tabaci in qPCR. You can see when we fed whitefly with 1 microgram per ml dsRNA, there was around 35-fold decrease of the virus copies in the individual whitefly than the control. And it increased up to 3,600-fold decrease when whitefly was fed with 2 microgram per ml dsRNA preparation. And interestingly, we did not record any virus copies in individual whitefly when whitefly was exposed to 3 microgram per ml dsRNA treatment. So maybe at this condition, whitefly stop acquiring the chili leaf curl virus, or maybe the virus concentration is too low to detect in the qPCR. That means that is the beyond the detection limit of the qPCR. And the same whitefly set was used to do the biological transmission to see the effect, what is the effect on the biological transmission. As I said, when we fed whitefly with 1 microgram per ml, there was 35-fold virus copies number decrease, but that was sufficient to make 100% infection in the healthy plant, that you can say that the decrease in the virus copy number has no effect on the biological transmission of the chili leaf curl virus by Bemisia tabaci. However, the transmission decreased to 40% when that was treated with a higher dose, and no transmission was recorded when whitefly was fed with 3 microgram per ml. So probably the knocking down the Bemisia tabaci HSP70 restrict the acquisition of the chili leaf curl virus by Bemisia tabaci, and thereby it restrict the further spread of chili leaf curl virus from infected to the healthy chili plants. These are some of the picture images of the experiments. You can see that in control where there is no dsRNA exposure, all the plants were infected by whitefly, by chili leaf curl virus transmitted by whitefly, whereas in a low dose also, there was all plants were infected by chili leaf curl virus, but at a higher dose only a few plants were infected by chili leaf curl virus, and no transmission was recorded when whitefly was fed with 3 microgram per ml HSP70 dsRNA. So now the question is that all these experiments were conducted under artificial or in the control laboratory condition, and the dsRNA was fed to whitefly artificially. That is not feasible under the natural condition where whitefly adults are highly mobile. So we thought if we can use it as an insecticide and spray on the plant like an insecticide. So we did one glasshouse experiment where the regular temperature fluctuates between 27 to 35 degrees centigrade. And the dsRNA suspension was sprayed on the chili leaf curl virus infected chili plants, not directly on the Bemisia tabaci. And Bemisia tabaci was released on the treated plant after 24 hours of the treatment. We used a 10 times higher dose than the control condition experiment. And we found there was a reduction of 10 to the power 12-fold reduction of the virus copies in the individual whitefly, around 10 to the power 12-fold post the exposure to the treated plants, and also the expression of the HSP70 that was downregulated by log 10-fold. Now the foliar spray of this dsRNA, HSP70 dsRNA on the infected chili leaf curl virus infected plant showed reduced transmission of the chili leaf curl virus from the infected plant to healthy plant. By the Bemisia tabaci, we recorded only around 6% transmission by the whitefly. And at the same time, we recorded very high mortality of the whitefly itself, around 87% mortality at 24 hours. And this mortality, a significant mortality maintained up to 7 days of the spray. And thereafter, a second spray is necessary to sustain the mortality up to 15 days and maybe sometimes up to 18 days. So this is in brief our study at this moment. And I would like to conclude that the topical application of the dsRNA on the chili leaf curl virus infected plants targeting the Bemisia tabaci HSP70 provides significant mortality of the whitefly. At the same time, it restricts the further spread of the chili leaf curl virus from infected to the healthy chili plant that we tested under the glasshouse condition. And this may be further assessed for its efficacy and persistent under the natural condition as an eco-friendly alternative to the chemical insecticides. So I acknowledge the support from my institute, my funding agency, collaborator, and laboratory students. Thank you all.
If any questions to Dr. Amlendu?
What is the stability of this, artificially synthesized protein outside the environment when it is sprayed on the chili plants?
So that I was showing, if you consider the stability with its action, so up to 7 days, it started with 80% on the 24 hours, and it increased more on the 48 hour, and after that gradually it decreased. But up to 40 to 50% mortality can be sustained up to the 7 days. And a second spray on the 8 days that further sustained the mortality up to 15 to 18 days. So you can say the stability under the glasshouse condition is around 7 days.
So, okay, this protein is directly interacting with virus or vector?
This is not the protein. So if you are talking about the HSP70 protein, so HSP70 protein is directly interacting with the code protein of the virus in the meat gut.
Okay. So then, okay, thank you.
Any other question, please? Up to the chair, please.
I don't think you are audible. Let's move ahead. Go to the next speaker.
Sir, am I audible?
Yes, you are audible. You are audible.
Yeah,
So-
you are audible.
So
let's go to the
next speaker is Dr. Mukesh Kumar Khokar.
I think Dr. Mukesh Khokar on behalf of Mukesh Khokar, Dr. P.N. Meena will present.
Yes.
Yes. So, Dr. P.N. Meena, you present.
Slide is visible?
No, not yet.
Your screen is visible.
Your screen is visible. Please open the slide.
Okay.
Please stick to time.
Now it's visible.
It's visible now?
Yeah.
Okay.
Yeah.
You proceed.
Respected chairpersons, I would like to present here my research topic on the impact of IPM interventions on inoculum density and disease development relationship between pathogen antagonistic microbials in transplanted and direct-seeded rice. Myself, Dr. P.N. Meena, or my co-author name is Dr. M.K. Khokar. We are the scientists in NCIPM in discipline of plant pathology. Now, as we know that rice is one of the most important staple food crops and that are severely affected by the Bakani blast, VLB, seed blight, and brown spot diseases. In India, most of the farmers depend on the advice of pesticide. They usually use 4 to 6 spray, which causes the adverse effect on environment, natural enemies, pesticide resistance, resurgence of pest populations, and human health hazards by leftover residue of the pesticides. So to get right from this measurable pest management system, ICR NCIPM developed a IPM package against destructive pest of rice to reduce pest and disease incidence. In this context, we were evaluated these IPM packages effect on density of the Trichoderma, Pseudomonas, and Fusarum in soils, and influenced by the IPM intervention in DSR and TR, and also determine the relationship between density in soils and disease incidence. So this experiment was conducted at 3 locations: Bambawar, Haridwar in Uttarakhand under transplanted rice, and Karnal under direct seeded rice. This experiment was conducted to assess the inoculum density and disease dynamics of Trichoderma, Pseudomonas, and Fusarum species under field conditions. These are the some IPM modules which were evaluated during this experiment. These are non-IPM modules that is already adopted by the farmers on all 3 locations. So comes on the result. Here we see the effect of IPM practices on soil microbes at Haridwar location. Here we found that the population density of Trichoderma and Pseudomonas was higher in IPM plot in comparison to non-IPM plot. But in case of Fusarum, the population density of Fusarum was lower in IPM plot in comparison to non-IPM plot. When we see the effect of IPM practices at Karnal location, here we found that the population density of Trichoderma and Pseudomonas was higher in control IPM plot as compared to non-IPM plot. But in case of Fusarum, the population density was lower in IPM plot as compared to non-IPM plot. When we see the effect of IPM practices at Bambawar location, here we found also same like Trichoderma population Trichoderma Pseudomonas higher in IPM plots in comparison to non-IPM plot, but in case of Fusarum, it is lower in IPM plot in comparison to non-IPM plot. When we go for percent change in microbial population in 2019 over 2017 IPM and non-IPM rice fields, we found that the population density of Trichoderma, Pseudomonas, Fusarum was higher in the year of 2019 in compared to 2017. Similar trend was also seen at the location of Haridwar and Kandal in Haryana. When we see the effect of fusion population on Bakani disease, here we found the positive relationship between fusion population and Bakani disease. When the population fusion was increased, the incidence of the Bakani disease also increased. But in case of Pseudomonas population, the incidence of sheath blight was decreased. Similar trend was also seen with bacterial leaf blight at Bambawad and with the Bakani disease at same location. When we see the effect of Pseudomonas population on against brown spot disease, we found the negative relationship between Pseudomonas and brown spot disease. And similarly, we see the effect of Pseudomonas population against the sheath blight at Haridwar location. Here we also found the negative relationship between Pseudomonas and sheath blight. Same trend was also seen with bacterial leaf blight and Bakani disease at same location. But in case of Haridwar, when we see the effect of Pseudomonas population against the brown spot disease, but here we found the positive relationship between Pseudomonas population and brown spot disease. When the population of Pseudomonas increased, the incidence of the brown spot disease also increased. Similar case was also seen with the Fusion population and Bakani disease incidence. But in case of Trichoderma population, when the population of Trichoderma was increased, the incidence of bacterial leaf blight was decreased. Similar trend was also seen against the brown spot disease at Kandal location. Now, when we see effect of Pseudomonas population against the bacterial leaf blight at Kandal location, here also found the negative relationship between Pseudomonas and bacterial leaf blight. When the population increased, the incidence of bacterial leaf blight was decreased. Similar trend was also seen against the brown spot disease and sheath blight disease. But in case of the Fusion population, when the population was increased, the incidence of Bakani disease was increased at Kandal location. So comes on the conclusion perspective, in transplanted rice, the density of the Pseudomonas was initially high in IPM as compared to non-IPM feeds. Disease dynamics study showed that bacterial leaf blight, Bakani and sheath blight are major disease in transplanted rice, while the BLB and brown spot were predominant in DSR cropping system. This study would provide a better understanding of the microbials and pathogen that could provide a basis for disease risk assessment and development of biological control strategy for management of rice disease in DSRs and TR. Thank you.
Thank you, Dr. Mina, for very brief, nice, crisp presentation.
Thank you, sir.
Should we take one or two questions or move on to the next?
Sir, we can take one question, then can move on.
Yeah, but we have 6 more, I think, no speakers?
Now 4 more, sir.
Okay, 4 more. Okay, fine. Any question? Okay, no questions. So let us move to the next speaker.
So the next speaker is Dr. Pandian from ICR Central Plantation Co-op Research Institute, Regional Station, Bittal, Karnataka.
Sir, am I audible, sir?
Yes, please.
Okay, thank you. First of all, I would like to thank the organizers for giving me an opportunity to present my research work in the technical session 2B, eco-friendly management. Most respected chairman and co-chairman and other dignitaries, I shall present my research work on identification of an effective strain of Trichoderma asperellum 8172 for the management of basal stem rot disease in Aricanet.
Okay.
So,
Aricanet
is one of the major cash or profit crop in India, and India is the largest producer and consumer of Aricanet in the world. And Aricanet is being an integral part of religious, social, and other cultural celebrations in various Aricanet growing tracts of the world. Coming to the Aricanet production, India is the leading producer of Aricanet in the world, and Karnataka is the leading producer state of Aricanet in India. So, Aricanet is severely affected by many pests and diseases throughout the year. So, to tackle those problems, farmers are using huge amount of insecticides as well as fungicides to manage the disease and pests. Such indiscriminate use is posing health risk to the terrestrial as well as aquatic habitat surrounding the environment. So basal stem rot is a major disease occurring in Aricanet, which causes almost 94% mortality in severe neglected gardens, and it is a slow decline as well as a lethal disease. So this picture shows the different images, symptoms of basal stem rot of Aricanet, starting from oozing near the collar region and drooping of crown region, as well as the ending stage is formation of mushrooms near the collar region, which is almost the penultimate stage of the disease. So, as I already mentioned, the basal stem rot is a soil-borne disease, and the use of fungicides, especially hexaconazole, invite health risks to the surrounding environment. So, in such cases, the alternative strategy is use of biocontrol agents, which is an effective and ideal strategy. So, Trichoderma arzianum CPTD based enriched neem cake formulation was effective against the basal stem rot disease in coconut, and it was successfully demonstrated in various farmers' gardens in Kerala and Karnataka. From CPCRA Kasaragod. So the effective biocontrol formulation is based on the native isolate, and the native isolates will perform better in the particular locality, and the effective strains is needed to develop the better Trichoderma based formulations. So no effective biocontrol agents are available for the Aricanet basal stem rot disease. So keeping this thing in view, the rhizosporic soil samples were collected from the Aricanet healthy palms bearing a stabilizing yield from the western parts of Assam, and we made it very strict that no earlier history of any application of Trichoderma in the Aricanet soil. So the rhizosporic soils were subjected to Trichoderma isolation using Trichoderma selective medium, and different cultural characteristics as well as microscopic features were recorded, and the antagonistic potential were assayed using the highly virulent Ganoderma lucidum isolates isolated from the Ganoderma infected Aricanet plant, and the best antagonistic potential isolates were selected further for plant growth promotion activity, and molecular characterization was done using IPS gene. These are the different representative images of different Trichoderma species isolated from the soil samples. And the microscopic characteristic like conidiophore and conidial characteristics are recorded critically. And the colony growth rate as well as the number of required for the full growth. Very fast growing isolates were selected further for the antagonistic assay. So a total of 69 Trichoderma species isolated, out of which 42 were selected for the further antagonistic activity. And the antagonistic activity here we used 5 different virulent isolate of Ganoderma lucidum, and 6 replications were kept for each isolates, and the observations were recorded mycelial growth inhibition of Ganoderma by the Trichoderma. This is a representative image for that Trichoderma aspergillum strain 8172, and the result shows that out of 42, the best performing 3 isolates were given in the graph, of which 8172 was better performing among the 3, with more than 85% of mycelial inhibition of the Ganoderma lucidum cultures. So the best 3 out of which the 42 isolates Trichoderma strains were selected further for PGPR activity with the following setup. By keeping Trichoderma arzianum CPTD 28 as a positive control, and Aricanet variety Mohitnagar was used, and the standard protocols were followed, and observations were recorded periodically. This is the different phases of the Aricanet experiment with plant growth promotion activity with the Trichoderma treatment. Soil and seed treatment were applied, and the parameters like days required for 50% germination, mean days required for germination, shoot, root, and total biomass were recorded. And coming to the results, if you see the seed and soil comparison, 8172 among the 3 isolate, 8172 were better performing in terms of shoot, root, and total biomass, as well as it requires less number of days for 50% germination and mean number of days required for germination. And compared to seed and soil, seed treatment is performing better than the soil treatment. Here we can see the representative image of control plant versus the Trichoderma aspergillum treated plants. And the root biomass also we can see the feeder roots and secondary roots were more in case of Trichoderma treated Aricanet seedlings as compared to the control. So the molecular characterization was done by using IPS, and it was confirmed as Trichoderma aspergillum, and multigene analysis is under progress. So the salient findings of my research work is Trichoderma aspergillum strain 8172 is efficient in restricting the growth of virulent Ganoderma lucidum pathogen, and it consists of promising plant growth promotion activity in case of Aricanet. And this particular strain will play definitely a key role in management of basal stem rot disease in Aricanet in Assam as well as other Aricanet growing tracts of India. Trichoderma aspergillum strain may be incorporated in the potting mixer for raising healthy arecanut seedlings in nursery, as it is already having promising plant growth PGPR activity. So the future line of work follows us. The field validation, this actually 1 year data only presented. The second year experiment is going on, already under progress. And after which the field validation of this Trichoderma aspergillum strain 8172 in arecanut based multi-species cropping system under some conditions. And the principal component analysis responsible for the biocontrol activity has to be found out. And evaluation of this strain against other major fungal diseases occurring in plantation crops, especially coconut and arecanut, has to be carried out. Thank you.
Thank you so much. I have one query, like, see, what was the strategy to give it the plant a lifelong protection? Like, I mean, it's a very long living.
You're asking about arecanut, sir?
Yeah, arecanut. What is the strategy to give it a lifelong protection by trichoderma? In
Sir,
nursery, you can
actually,
give seedling and all, but I mean,
sir, nursery actually
every year, something like that, around the tree, something like that.
Yes, sir. Actually, yearly twice we are applying, sir.
Okay.
The standard recommendation is yearly twice, post monsoon and pre monsoon we have to apply, sir. If we apply with the help of neem cake, it can take care of both pest and diseases like root grub, Ganoderma. So our standard recommendation yearly twice we have to give, sir.
Okay, good. Thank you. Any other question?
So, what is the dose you are taking, Thawa, for this? What is the dose?
For seed treatment or soil application, madam?
Soil application and seed both.
Madam, seed treatment, actually we are counting that colony forming unit, madam, 2 into 10 to the power of 6 colony forming unit. And we are treating the seed nuts in solution, madam. We have not formed any formulation type, madam. Just we are checking with the liquid cultures only, madam.
Okay.
Madam, you can take over.
But you have to.
So the next speaker is Dr. Rekha Balodi. Please share your slide.
Yeah. Is it visible, sir?
Just hang on. Yeah.
Yeah.
Make it in presentation mode.
Very good evening. I believe COVID has given us this liberty to connect from anywhere, and blessing in disguise, or give us as a reason to remain busy throughout the day in front of the virtual screen and all. This is Dr. Rekha Balodi from ICAR NCIPM. I will be presenting a very preliminary work that I am doing regarding the monitoring of native Trichoderma species population in the tomato field. And we know about the Trichoderma from a very long time. And Trichoderma, as we know, is in 1794 it was described for the first time and then elaborated for the biocontrol potential of its biocontrol potential against the plant diseases and all. And then the mechanism of Trichoderma species is deciphered from the mycoparasitism to the production of antibiotics to the secondary metabolites and then the mutants and whatnot. We know about Trichoderma. We have deciphered a lot about the Trichoderma species. But the problem is still at the lab level, the Trichoderma, yes, it works. It gives us so much positivity in the lab, telling that 90% it is controlling, giving the growth inhibition and everything. But when it goes to the field, it fails. So whatever we do for a very long time in the lab, field efficacy data, molecular characterization, everything, as soon as it goes to the field, it fails. So there we don't know how to do it, what to do it, the formulation, whether the strain should be more effective, whether the formulation should be more stable. We don't know how to go about it. So regarding this, it is completely a field study in which we have already taken in the Padhana village in Karnal district in Haryana, in which we have already we isolated the Trichoderma species before the transplanting of the tomato crop and on the Trichoderma selective media. And then we did the bioefficacy with the common soil-borne pathogen to just know whether the strain that we are using is going to be effective in the field or not. And then we prepared a tag-based formulation, and in the 5 different locations in the same field, we augmented the trichoderma we augmented it with the same trichoderma species. And then the CFU count was taken for like 6 months from the farmer's field. And these are the glimpses of the field activities that we conducted. It was the experiment was done in the farmer's field. So this is the view of the tomato field, the produce that the tomato, and then the various diseases that we saw this year in the field: late blight, early blight, and tomato leaf curl. These are like from many colonies that we could isolate from the soil. The 3 very distinguished colonies we took, and then we tested them against Fusarium and Rhizoctonia just to know about the efficacy against the soil-borne pathogen. And one of these, the number 2 here represented in the number 44, like that, coded like 44. It was taken to the for further studies. And from this particular strain, what we did was we made the type-based formulation, and as I told in the methodology, we augmented at the 5 different places in the field. And then at different time, we took the CFU count from the field, and what we saw was initially when we augmented the field, there was increase in the population of the trichoderma species. Then it became stagnant, and then there was a decline within the cropping season. And the green one is the CFU, and the number that is the gray bars that represent the diversity, actually the kind of different types of colonies, morphologically distant colonies that were that we could obtain from the field, like that it was. And then it is that was the cumulative data, the previous graph. The next graph is from the 5 different locations how the trend was. And it was haphazard. We actually in the next year and we are going to repeat it next year, and then maybe some correlation, something we can get. Then regarding the disease, since we got the early blight and late blight diseases in the field, so we took the data and we tried to know what is the disease progress curve of these 2 diseases. And since it was a biological control experiment, we only with the late blight I tried to get some correlation, a very weak correlation. Again, whatever I could get was a very weak correlation. But yes, there was a S-shaped curve for both early blight and late blight, and the CFU count as the like diseases progress, then the CFU count progress as well. In this experiment, it is a 1-year data only. And what I could conclude is when we augment the trichoderma species in the field, with the progression of the cropping season, maybe the thing become organic produce become less, and then the trichoderma, there is decrease in the trichoderma this thing. And then I would like to acknowledge Director ICR NCIPM vegetable team with whom we are working, the Sarpanch and the farmers of Padhana village with whose cooperation we were able to conduct these experiments, and Indian Phytopathology Society experts for giving me this opportunity to present my work. A very big thank you. Thank you. There's some problem with my camera. I think I'm not visible.
It's okay.
Okay, sir.
Thank you so much. Dr. Pratibha Sharma, please take over the proceedings.
Okay, thank you, Dr. Prasanth. Thank you very much. So now we go ahead with the next presentation, Dr. Lindu.
The next presentation is by Dr. Sumit Kumar Agarwal from ICR Indian Institute of Niche Research, Ludhiana.
Hello, sir. My slides are visible.
Just hang on, it's taking time. Yeah, please make it presentation. Yeah, it's visible, please.
Okay, sir.
Uh, a very good evening to respected chairpersons and all respected senior scientific colleagues and my dear friends. I am Dr. Sumit Kumar Agarwal and recently joined a scientist in ICR Maize Research Institute. So my topic is adoption of module for management of banded leaf and sheath blight of maize in India. So as time is very less, so I will go very focused to very particular points. As all of is very common, the Rhizotonia species is very common to every crop, either it's vegetables, cereals, or even tree plants. So definitely it's a very challenging to sometime it to develop or management aspect regarding this particular pathogen. So if we talk about symptom, the straw color that I have mentioned over here in first pick, even leaves and stalk, and then go on the all from starting from downward to upward, the plant symptoms appear as a colored necrotic lesion and with alternating dark brown bands, as you can see clear cut in first picture. And economic loss is reported right around 11 to 40%. If environmental conditions are favorable, it may go up to 100% also. And major challenge in Rhizotonia and pathogen like this is they are soil-borne, necrotroph, and wide ostrich. Definitely they survive well is very vast, so definitely it's very challenging. So for this particular research, we have selected susceptible cultivar Vivek QPM9, and the location, there were 4 locations: Ludhiana, Karnal, Delhi, and Pantnagar, and the season were 2018 and 19. And our plot size was 9 meter squares, including 6 treatment and 3 replication using RBD design. And we have inoculated the plants with artificial inoculation method, barley grain mass multiplication. So here complete this all treatments, 6 treatments you can see here. We have the importance of this research was just to see whether there is a difference or how we can develop multiple options to manage in disease management system. Anyhow, earlier also it has been reported that amistrotop, the azoxystrobin diphenocconazole effective chemical for this. So we have combined with this salicylic acid chemical approach. Then we have developed organic approach with soil amendment with trichoderma and seed treatment with trichoderma foliar formulation, and then foliar spray with neem leaf extract. And organic approach second, we have removed this neem leaf extract and we have used as foliar spray trichoderma formulation. Then we have developed IDM. We have taken biocontrol agent, trichoderma, then salicylic acid, elicitor, foliar spray of amistrotop and neem leaf extract. And we have also kept standard control, foliar spray with carbendazim and 1 positive control. So these are the all treatment details. So directly come to results. Overall, we found definitely chemical approach with the salicylic acid, amistrotop, give a higher disease control. That is 60.7%, and local around 1,000 or 500 meter square area. Accordingly, every data has been calculated and followed by IDM approach in the Ludhiana. And in case of Karnal, IDM approach instead of chemical approach showed a little bit higher impact on the disease, if you see the disease control part. So, and in case of Delhi, if we see the chemical approach was again was less effective compared to IDM approach. However, though both can be applied. In Pantnagar, again chemical approach was most effective compared to IDM approach. We have also calculated cost benefit ratio. Overall, the chemical approach giving a higher cost benefit ratio as all the locations. So this is definitely a viable approach. Because in case of BLSP, we don't have resistant cultivar. Even I have experience with the rice sheath blight also. So there also we don't have clear-cut resistance, and there is a challenging for breeding program also. So we are always it's important to follow the management practices regularly for this kind of pathogen or diseases. So overall, I will conclude here. The results are variation. Definitely, it's depending on the soil condition. In screening, what happens, sometimes we are reporting that these are the cultivars which are resistant, and next season or next season or next season, we find that the resistant or moderate resistant cultivar convert into susceptible. So the severity or changing according to environmental condition definitely, and chemical approach was found most effective here. And location wise, the farmer can directly utilize at Ludhiana and Karnal chemical IDM and organic approach one. Neem leaf extract can be used. And in case of Delhi and Pantnagar, chemical and IDM approach can be used effectively to manage this particular disease. So here is our team. Some of scientists has been gone to other institutes. Anyhow, work has been started already, and thanks to our director and our team, and definitely Indian Pathological Society to provide me this opportunity. Thank you very much.
Chair, please. Chair, please.
Hello.
Yeah. So
Yeah.
I'm sorry.
It's okay.
Yeah, thank you, Dr. Sumit. It was very interesting. Okay, you took stipulated time. You did not exceed the time. That was very good. And of course, you have a very big team. But the work has just, I think, initiated, and now you are not going to go for the formulation aspects and all that. Thank you very much.
Thank you.
Any questions, please, from anybody? Otherwise, we can proceed towards the. How many speakers left?
Ma'am, another one speaker left. Then we have two more speakers from other session who have joined this session.
Hello.
So we can ask the last speaker to then continue.
Ma'am, hello. I have one question.
Yes. Yes.
To Sumit sir.
Yes,
What
sir.
are your
Yes, sir,
prospects?
Yes, Sahil, please.
In response to the data you showed, what are your future plans considering this?
This actually that was not based on the plans. Actually, it was checked whether what are the alternate chemicals are available or its effectiveness is there or not. So directly we can provide or recommend these chemicals. Whatever we tested modules can be recommended to the farmers, and later on plan means if farmer says that particular chemical is showing resistance. Sometimes farmers comes to us that this chemical is not effective. However, some good companies are they are definitely providing good chemicals. So it's our duty we will continue to monitor whether effectiveness of these chemicals are persistent or not.
Okay, thank you.
The next speaker is Mrs. Shivani Gupta from YS Parmar University of Horticulture and Forestry, Solan. Shivani Gupta, are you online? Please respond. Yeah, probably she is not online, ma'am. So,
Okay, so we.
So ma'am, Dr. Sabarni Tripathi was listed as invited speaker in this session, but he just called that he has a problem in system and he could not present. So we have his slide. So if you permit, we can show the slide, or he can be shifted to the next session tomorrow.
Maybe better to skip to the
So
next.
we can allow
session.
those two speakers. I think we can.
Yes.
Yes.
So we have received the PPT from two more speakers. One is Dr. Tripathi and Mallikarjun Kinganal.
Yes, sir, I'm available now.
Yeah. Could you present, please?
Are you using the pre-recorded or I have to present it?
It will be good if you present directly.
Okay, let me try.
Otherwise, we can share the slide and he can present.
Yeah, that would be fine, sir, if it is possible from your end.
Okay, just hang on.
You check it.
Dr. Mallikarjun, there is some issue with your PPT. So it will be good if you...
It's coming.
It's coming, that's all, but it's a blank, showing blank, white only.
Are you able to see my screen now?
Yeah. Yes.
Yeah, please.
Is it visible now, sir?
Yes,
Yeah,
yes.
yes.
Come to slide. Yes.
Okay.
Come to
Chairman sir, co-chairman sir, rapporteurs, and all the participants of this national e-conference on plant health and food security challenges and opportunities being organized by Indian Petrochemical Society in Delhi. This is Mallikarjun Kengal presenting my paper on consumer-producer co-opted linkage through e-resources for farm solutions and marketing of producers during the COVID-19. We all know very much that COVID-19 impacted on Indian agriculture, especially the value chain of these agricultural commodities on both consumers and producers. Hello?
Yes, sir. Please.
Is it visible, sir, now?
Yes, sir. Visible and audible. Please play.
Okay. We all know very much that COVID-19 impacted on Indian agriculture, especially the value chain of these agricultural commodities on both consumers and producers had very severe hardship. Crop production suffered due to COVID-19 outbreak. It halted in marketing facilities and indirectly ruined the lives of many farmers and those who were one side producers, the other side processors, and also the consumers were all the three together were very much severely affected. No physical movement and transportation brought the rural and urban lives to a complete standstill. So growers, consumers were the worst affected outbreak of the COVID pandemic. So in India, the Kalburgi is the first district to record the death of human being due to COVID-19. And this closure of APMC markets and entire restriction on movement of the vehicles altogether halted the farmers' lives. And those who were visiting KVK's agricultural research stations for their technological inputs and crop protection measures, such as the farmers were very severely affected. On the other hand, consumers, irrespective of rich, poor, and middle class, all those struggled for the daily food needs. So under these circumstances, the Agricultural Research Station or Zonal Agricultural Research Station Kalburgi, KVK Kalburgi, and along with the Agriculture Department, Horticulture Department, Revenue Department of the Kalburgi district, we prepared an action plan and immediately implemented to help the farmers. So the study focuses on special initiatives undertaken during this pandemic period, both by ASL Pijanpi, KVK Kalburgi, and Agricultural Research Station Kalburgi. So the proactive interventions and involvement of all together has initiated, and in order to provide the necessary crop care solutions to the interested farmers, those who were visiting our KVK agricultural stations, they were provided SMS and WhatsApp image messages, videos, and live chat boxes were prepared for disseminating among the farmers, and the required information was passed to the individual farmers in groups based on their requirement, taking their phone numbers. On the other side, University of Agricultural Sciences, Raichur, established a pre-war zone. This was a special initiative taken by the university, and it was inaugurated by our Honorable Vice Chancellor. So this initiative helped the farmers to contact the Agricultural University on a toll-free number, and they can discuss their difficulties, whatever it may be, for crop production, protection, or harvesting, processing, or even for movement of the commodity shipping facilities. So such of the agri-war room helped in getting contact with the farmers. So the farmers were provided these kind of WhatsApp images along with the information on crop protection measures, or it may be pest, disease, or whatever it may be. So depending upon the seasonal incidences, the farmers were provided videos of and also the messages for their crop protection management. So for those approaching difficulties with the KVK for marketing of the commodities, the farmers groups were formed for the producers, and also the consumers group were formed for the buyers. So each of the farmers, they informed us whatever the produce they wanted to sell, and at the same time, in the WhatsApp group of the consumers, the indents were received whatever was requirement. You can just see a message which was posted in the consumers group that the grapes are available at 40 rupees per kg, and on the other side, the farmer was ready to bring his watermelon to the KV. So the KVK established along with the ZARS and Agricultural Research Station and our Agriculture Horticulture departments, a special facility was established at Agriculture Research Station for collecting the commodities produced by the farmers as an aggregating point in our university
University or our KVK campus, and thereby the producers were segregated depending upon the needs of the, and subsequently these segregated commodities were sent to the different consumers locality with protective gears and all these social distancing measures, so that each and everyone should get the, equal commodities was required. And for this, the agriculture department, horticulture department, and especially the Tata Trust Kalike, they were all roped together. In fact, they provided 12 vehicles with all mobility and drivers and other volunteers for the transportation and marketing of these agricultural commodities. So this helped in reaching each and every farmer and also each and every country to provide all the commodities which were produced and which were essentially needed and required by all the consumers. So you can see that even the women SSG members were roped in preparing the safety mask, which was essentially required during the COVID-19 outbreak. You can see the use of e-platform along with the gadgets, it helped in reaching the farmers for their producers to collect and also to sell them to the consumers. So the success story is such that totally 370 farmers were helped and 800 consumers were benefited, and rupees 12.7 crores was transacted during this special initiative taken by the KVK, and it was very much appreciated both by the government of Karnataka and government of India. In fact, the model entered into the collections of the best practices marketing farm producers during COVID-19 outbreak, the compilation by ICR. You can see the compilation, and this KVK initiated at our Agriculture Research Station Kalburgi initiative has entered into the ICR. So this is another one of the initiative taken by one of our farmers. He has produced his own branding, packing, and also the commodities. Another farmer with his own innovative, thinking, he converted his own motorcycle as a commodity carrier, and thereby, without any middlemen, he directly approached all these consumers, and he took the indent with the help of KVK on his mobile number and straight away delivered it to the required consumers. So by this, these are all the different success stories recorded during that period, so that the KVKs, agricultural research stations, and all to with the farmers. So this is in nutshell what I would like to say, that the agricultural research stations, the Krishi Vigyana Kendra, and all the line department staffs and all the agricultural research scientists, if we work together, such of the pandemics can be very much, successfully defeated, and the farmers who were in distress can be very effectively helped. Thank you very much.
Hello. Chair, please.
So now, after listening to the Dr. Mallikarjun's presentation, it was really very inspiring, otherwise encouraging also, that how they could really solve this. How could they pass on the whole technology and transfer, and they could really help the farmers through the without any social contact and all this. So how the technology has really taken help. With the help of the technology, they could really pass on the technology. So I think it was a good presentation. We can, if anybody wants to ask the questions, it's okay. Otherwise, we can request the last speaker to continue with the presentation.
Madam, actually, this presentation was supposed to be with you in session number 9. And morning, I was informed that it has to be now, in the session 2B.
No issue, sir. It was interesting. We all listened.
Definitely, it is very interesting. Yeah.
Thank you very much.
Even we are also informed. It's a good presentation, very good presentation. We were feeling very happy about it. No problem.
Yes, madam. Thank you very much.
Yeah.
Ma'am, we have a last presentation I have received from the society office. That is the Sivani. But what I can see, this looks like a more like a poster. You can see this only
then it should go to the poster then, no? Why it has come here then?
Amlendu, don't show here because it's like posters.
It must be a poster, yeah. I think it's a poster, or she wanted to speak.
Shivani Gupta, are you there? No, the participant is also not available. So if I am not wrong, no more delegates, speaker was left. If someone left, please respond. So I'd like to request the chairs to summarize the session.
Dr. Prasun Mukherjee, if you can give some remarks, and then we'll end with my remarks. And,
Okay, so we had a really very intellectually stimulating session, like covering all sorts of all aspects of health management, plant health management, including biocontrol, botanical control, and including your that minimal tillage practice, and all the speakers did very well. We are late, but not that late. I thank all the speakers for their time and then sharing their data and knowledge with us. Thank Dr. for co-chairing this. So,
voice is not coming.
Yes, madam. Yeah, I'm done.
So thank you all. Thanks all the participants. I thank Dr. Amlendu Ghosh and Dr. Malkhan Gujar, who have really, since morning, both of you are sitting. And Amlendu, you are looking in, I could see you in two places. So I could see both of you. And I really thank you. That's just to be on a lighter side. So it was so good. All of us, you were watching. You were working since morning. I'm seeing you that you are really on the job, and thanks to both of you. Of course, our both the reporters, I thank them profusely. But Dr. Khokar and Dr. Mukesh Kumar Khokar and Sumit Kumar Agrawal, both of them, they have helped us in the report years. I'm really thankful to see Dr. Prasun Mukherjee here, and it is so good to see you, Dr. Mukherjee. You were all the time here and really helped us in this whole session. Actually, biological control, when we are all together, we really feel encouraged to see each other and see our youngsters, like coming out. And of course, trichoderma is still favorite. I think it is an all-time favorite, in spite of so many people are trying so many other microorganisms, but somewhere else, everywhere I find trichoderma finds its place and its utility. So overall, it was very good presentation. All were very good, and I think the remarks, the summarization must have been given by our reporters. But of course, Dr. Prasun Mukherjee had informed us all about his strain, which is a mutant, and it has been found to be very effective in Raipur. I know I've seen also there. Also, I had gone once to Raipur. I saw some that trials were running there also, and you are also doing in soybean. So best wishes to you, Dr. Mukherjee, for your this trial and this strain that which it can find place in the commercial activity. And Dr. Arup Mukherjee, of course, he had presented his work on both the rice diseases, and importantly sheath blight and the seedling blight. There again, trichoderma, how it plays a role, both not only in the disease management, he also reflected his information on the composting and the other management practices. Then, of course, we could not immediately come in the sequence, but then Dr. Jairaj, he spoke about this biostimulants and especially the seaweed extracts. So he was talking about the seaweed extracts and how seaweed extract can work as biostimulant and bioregulators. All of them have given. Then Dr. Enhasi also, again, he also utilized this then technology for large scale production of biological control, and of course then trichoderma was also used here there also. So partly we feel that trichoderma is everywhere the part of the integrated management, or it is a biological control management, or we can also say now inorganic management, it is finding its place. Coming to Dr. Then Dr. M.S. Yadav, he had presented his work from NCIPM. Of course, I had missed his trial because somewhere I had gone there outside for the other session. Then Dr. Lata's presentation was on the waste decomposition technology and how she had summarized all about how different, along with the fungal decomposers, bacterial decomposers, the whole consortium. She had talked about that how they can work for this decomposition. Dr. David's time also, I was in the other one, and Dr. Pandyan, he spoke about the Trichoderma esperellum for the management of areca nut. Dr. Amlendu Ghosh was a very specific one, since he had used a double-stranded RNA for the management of the chili leaf curl virus. So very interesting. So it was found to be very interesting, and I know he's a very hardworking scientist. He's a part of this division only. So best wishes to you for this attempt, because double-stranded RNA is also part of our biological control, and we keep teaching also there. So practically you are doing it so good about it. Then Dr. Rekha, Dr. Sumit Kumar Agrawal, and Dr. Meena, they all gave very short presentations, and I think very well they covered whatever they wanted to speak about the management. Of course, it was in very short and very simple, and how the trichoderma they can use as a doses, different inoculum density. One of them spoke about the modules, and so like this they had incorporated this. And about Dr. Mallikarjun, of course, this has come from the other session, but Dr. Mallikarjun, we were really it was a very good information for all of us. And it was very important to understand, yes, how our scientists have really worked during the time of the COVID infection. And they have also how important are they when they are really working with the help of the KVKs, because overall, this whole system will work only when we are in the field. So thanks for your presentation also, and overall it was absolutely very informative and thankful. I again thank Dr. Prasun Mukherjee for chairing the session, and Dr. Amlendu Ghosh and Dr. Gujar, and all other participants who were patiently listening to this presentation. I think with this, I thank you all of you. Thanks very much.
So my work also, madam, has been done. So with on behalf of IPS Society, I would like to thank chairs, both the chair, Dr. Prasun Mukherjee, Dr. Pratibha Sharma madam, and rapporteurs also, Dr. Mukesh Kumar and Dr. Sumita Agrawal, and all the keynote speakers. Again, I would like to name also Dr. Prasun Mukherjee, Dr. Jairaj Jaraman, Dr. Olu Falaji, then Dr. Asim Anhasi, Dr. Lata, Dr. A.K. Chaudhary, Dr. Shravani Tripathi, Dr. Amlendu Ghosh, Dr. P.N. Meena, Dr. Thawa Prakash Pandyan, Dr. Rekha Balodi, Dr. Sumit Agrawal, and lastly, but not, I would like to thank my colleague, Dr. Amlendu Ghosh. We were engaged in both the sessions. Thanks to all the participants who are attending this session, the eco-friendly disease management. So again, tomorrow we will meet you at 10 o'clock for the next session. So thank you one and all.
Thank you, Mukherjee sir, and Pratibha ma'am.
Thank you.
Pratibha ma'am, thank you.
Thank you, sir. Thank you, ma'am.
Thank you. Bye.
Thank you, everyone. Thank you very much.
Bye, bye, everybody. See you now. Physically, we will be attending the conferences now. Okay.
Yeah.
I'm closing that.